React is a JavaScript library for building fast and interactive user interfaces. It was developed at Facebook in 2011, and currently it's the most popular JavaScript library for building user interfaces. As you can see on Google Trends, React is dominating the space of libraries and frameworks for building user interfaces. The other two players here are Angular and Vue. So if you want to expand your job opportunities as a front-end developer, you should have React on your resume. At the heart of all React applications are components. A component is essentially a piece of the user interface. So when building applications with React, we build a bunch of independent, isolated, and reusable components and then compose them to build complex user interfaces. Every React application has at least one component, which we refer to as the root component. This component represents the entire application and contains other child components. So every React application is essentially a tree of components. If you have worked with Angular 2 or higher, this should sound familiar. Here's an example. Let's imagine we want to build an application like Twitter. We can split this page into components like navbar, profile, trends, and feed. Here's a representation of these components in a tree. So on the top we have app, and below that we have navbar, profile, trends, and feed. Now feed includes several tweet components. Each tweet component can include a like component, which we can reuse on other pages or even in different applications. So as you see, each component is a piece of UI. We can build these components in isolation and then put them together to build complex UIs. In terms of implementation, a component is typically implemented as a JavaScript class that has some state and a render method. The state here is the data that we want to display when the component is rendered. And the render method, as you can tell, is responsible for describing what the UI should look like. The output of this render method is a React element, which is a simple, plain JavaScript object that maps to a DOM element. It's not a real DOM element, it's just a plain JavaScript object that represents that DOM element in memory. So React keeps a lightweight representation of the DOM in memory, which we refer to as the virtual DOM. Unlike the browser or the real DOM, this virtual DOM is cheap to create. When we change the state of a component, we get a new React element. React will then compare this element and its children with the previous one. It figures out what is changed, and then it will update a part of the real DOM to keep it in sync with the virtual DOM. So that means when building applications with React, unlike vanilla JavaScript or jQuery, we no longer have to work with the DOM API in browsers. In other words, we no longer have to write code to query and manipulate the DOM or attach event handlers to DOM elements. We simply change the state of our components, and React will automatically update the DOM to match that state. And that's exactly why this library is called React. Because when the state changes, React essentially reacts to the state change and updates the DOM. One of the questions that I often get is React or Angular? Well, both React and Angular are similar in terms of their component-based architecture. However, Angular is a framework or a complete solution, while React is a library. It only takes care of rendering the view and making sure that the view is in sync with the state. That's all React does, nothing less, nothing more. For this very reason, React has a very small API to learn. So when building applications with React, we need to use other libraries for things like routing or calling HTTP services and so on. But this is not necessarily a bad thing because you get to choose the libraries that you prefer as opposed to being fixed with what Angular gives you, which often breaks from one version to another. So that's all about React. Next, we're going to set up our development environment. Alright, this is where the fun begins. The first thing I want you to install is Node.js. Now, in this course, we're not going to use Node. We're only going to use one of its built-in tools, Node Package Manager or NPM, to install third-party libraries. So if you don't have Node on your machine, head over to nodejs.org and download and install the latest stable version. Once you do that, open up the terminal on Mac or command prompt on Windows and run this command. npm I, which is short for install, -g, which is short for global. And here's the package we're going to install. Create react-app. We're going to use this package to create a new React app. Now, I want you to install the exact same version I'm going to use in this course, because in the future, there might be breaking changes and you might get frustrated if what you see is different from what I'm going to show you. So here, version 1.5.2. Now, if you're on Mac and you haven't configured permissions properly, you need to put sudo in the front of this command. So, sudo. With this, we'll run this command under administrative privileges. Let's enter the password. Okay, beautiful. Now, the next thing you need is a code editor. The code editor I'm going to use in this course is Visual Studio Code or VS Code. Chances are you use the same because it's a beautiful, lightweight, and cross-platform editor. If you don't have it, you can download it from code.visualstudio.com. So here's VS Code. We're going to install 2 extensions that make it easier to build React applications in VS Code. So open up the extensions panel on the left and search for simple React snippets. Here's the extension I'm talking about. It's developed by Berk Holland, and currently there are more than 40,000 downloads. Very, very popular extension. So install it, and then you will have to reload VS Code. The other extension we're going to install is Prettier. So search for Prettier Code Formatter. This one is developed by Espen Petersen, and currently there are more than 2.7 million downloads. We use this extension to reformat our code. Now, one thing I highly encourage you to do so is to enable formatting on save. So whenever you save the changes, this extension will automatically reformat your code. To do that, you need to go to the settings page. Now here I'm on Mac. I'm not entirely sure how to do this on Windows, but that should be pretty straightforward. So here on Mac, we go to the code menu on the top, then preferences, and finally settings. So here on the right side, under user settings, I want you to add this setting. Editor.format unsave, set this to true. And finally, let me show you what theme I'm using here, because that's a question I get quite a lot. So on the top, go to the code menu, preferences, color theme. This is the theme I'm using. So IU or AU Mirage. So I leave it up to you to download and install this if you want to. Next, we're going to create our first React app. Now let's use the create React app package to create a new React application. So here in the terminal, let's run create React app and give our new application a name. Let's call it React app. Now this is going to install React as well as all the third-party libraries we need. So it's going to install a lightweight development server, Webpack for bundling our files, Babel or Babel for compiling our JavaScript code, as well as a bunch of other tools. So when you create an application using Create React App, you don't have to do any configuration. All the configuration is done for you. However, if you want to customize this configuration for your production environment, you can always eject by running npm run eject. We'll look at this later in the future. So now we have a fully working React app. Let's go to this new folder, React app, and run npm start. So this will launch our development server on port 3000 and open up Chrome or our default browser pointing to localhost port 3000. Now let's go back to VS Code and see what we have in this folder. So here we have 3 folders, Node modules, which is where we have all the third-party libraries as well as React itself. We never have to touch this, so let's not worry about it. We've got this public folder where we have the public assets of our application, such as a favorite icon and index.html. Now, if you look at this file, this is a very simple template. It doesn't really have anything. So a bunch of meta tags in the head section, as well as links to our manifest.json file and favorite icon. Manifest.json includes a bunch of metadata attributes about our application. Again, we don't have to worry about this, but if you look further below, here in the body section, you can see a single div with the ID root. This is where our React application is going to appear. So this div is the container for our React application, as you will see shortly. Now back to our files panel. We've got the source folder where we have a basic component that is app component. And that component is responsible for rendering this black banner on the top. So the output of that component is what you see here. Let's have a quick look at app.js. So you can see here we are using ES6 classes. We have a class called app that extends component, which is one of the built-in classes in React. Now, as you can tell, as a React developer, you need to understand what classes are and how to use them. If you're not familiar with these classes, I have a comprehensive course called Object-Oriented Programming in JavaScript. There, I cover classes in full detail. But to help you get started quickly, in the next section, I'm going to give you a quick overview of all the modern JavaScript features that you're going to use frequently in React applications. So if you're not familiar with classes or modules, don't worry for now. We're going to get to them shortly. Now look at this class. Here we have a render method or a render function where we return a markup like this. Now, this is something you probably haven't seen before because we cannot have markup like this in JavaScript. Note that this is neither a string nor HTML. This is what we call JSX, which stands for JavaScript XML. So we use this syntax, which looks very familiar to us, to describe what the UI is going to look like. So this markup represents this black banner on the top. This is the output of our app component. Now, to make this code work, we have to pass this code through Babel, which is a modern JavaScript compiler. So Babel will take this JSX syntax and convert it to plain JavaScript code that browsers can understand. Let me give you a quick demo. Head over to babeljs.io/REPL or REPL. Here we can type modern JavaScript code, and Babel will convert that code into code that browsers can understand. So here I'm going to define a constant, which is a new ES6 feature, call it element, and set it to a JSX expression. So h1, let's say hello world, and we close it here. Again, note that here we are not setting element to a string. This is JSX, so we don't have quotes here, right? Now on the right side, look, this code is converted to a call to react.createElement. The first argument to this method is h1, which determines the type of our element. And the third argument is the text that we want to put in between these h1 tags. So as you can see, using JSX to describe what the UI looks like is much easier than writing plain React code like this. So in our components, we'll always use JSX, and we'll leave it up to Babel to compile that JSX code into calls to react.createElement. Now back to our files panel. Here we have app.css, which includes all the CSS for our app component. You can see this CSS file is imported into our component here. We also have a test file that is app.test.js. In this course, we're not going to look at testing. That's a topic for my advanced React course. We also have index.js, which is the entry point for our application. Don't worry about the code here. We're going to write it from scratch in the next lecture. Similarly, we have index.css. We also have logo.svg, which is the logo of our application. And finally, register service worker.js. This is some code that is automatically generated by Create React App, and it may change or disappear in the future. But at the time of recording this, basically what this file does is it serves assets from a local cache in a production environment. So for now, we don't have to worry about this. Next, I'm going to all right, now I want you to delete all the files inside of the source folder. You're going to write everything from scratch. So let's start by adding a new file here. Call it index.js. Here we need to import a couple of objects from React modules. So if you're not familiar with ES6 modules, don't worry, just code along with me. We'll get to them in the next section. So import React from React. So this is the module, and this is the object that we're importing from that module. The other object we need to import is React DOM, and we're going to import this from React-DOM. Now let's define an element. So const element. Const is a new feature in modern JavaScript. Previously we used only var, but now we have const and let. Again, in the next section, I'm going to give you a quick overview of all these new features. So let's define a constant element and set it to a JSX expression. So h1, hello world, and close h1. Now, as I told you before, Babel will compile this down to a call to react.createElement. And this is the reason why we have to import React on the top, even though we're not going to directly use this object in our code. But when our code is compiled, because there is a reference to React, that's why we have to import it on the top. Now, let's log this element on the console. So, here's one thing you need to know about projects that are created with Create React App. Whenever you save the changes, this application is automatically restarted. So you don't have to go back in the browser and refresh it. This is what we call hot module reloading. So save the changes. Now, back in the browser, you can see I didn't refresh the page, and that black banner that we had on the top is now gone. Now, open up the console. You can do that using Alt, Command, and I on Mac, or Alt, Control, I on Windows. If that shortcut doesn't work for you, go to the View menu on the top, Developer, and Developer Tools. So here on the Console tab, you can see we have an object. This is the output of a JSX expression. This is a React element. So you can see the type of this element, the type property is set to h1, and we have a bunch of other properties here. So earlier at the beginning of the course, I talked about virtual DOM, which is a lightweight in-memory representation of the UI. It's not the real browser DOM, it's the virtual DOM. And this object you see here, this React element, is part of that virtual DOM. So whenever the state of this object changes, React will get a new React element. Then React will compare this element with the previous one. It will figure out what is changed, and then it will reach out to the real DOM and update it accordingly. Okay? So here we have a JSX expression. The result of that is a React element, which is part of the virtual DOM. Now we want to render this inside of the real DOM. And that's why we have to import React DOM on the top. So here we call React DOM dot render. As the first argument, we pass the element we want to render. So here's our element object. As a second argument, we need to specify where in the real DOM we want to render this. So temporarily, let's go back to the public folder. Here in index.html, earlier I talked about this div with the ID root. I told you that this is the container for our React application. So back to index.js, we need to use plain vanilla JavaScript to get a reference to that DOM element. So we call document.getElement by ID. And here we pass the ID that is root. So this React DOM will get a reference to this and render this React element inside of that element. Save the changes. Back in the browser, you can see our hello world message. Let's right click this and inspect it in Chrome Developer Tools. Here we can see our div with the ID root, and inside of this div, we have our React element, h1, with the tags hello world. Now, this is a very simple application. In a real world application, instead of rendering a simple element in the DOM, we'll render our app component. This app component is the root component for our application. It includes children like navigation bar, sidebar, profile, and whatnot. So we'll have a tree of components which will eventually produce a complex markup. Show you how to write some React code from scratch. All right, so we created a fully working React app with zero configuration. But sometimes, if you're an advanced developer, you may want to customize the default configuration that comes with this project. For example, let's say you want to customize the Webpack configuration. That's when you use the eject command. So open up package.json. Here under script section, we have 4 scripts or commands. Earlier, we used the start command to start our development web server. We also have build, which we use for building this application for production. So we'll get an optimized package. We also have test for running unit tests in this project. And finally, we have eject. We can run this command to eject from create React app and customize all the tools and configurations that come with this project. Now, the interesting thing here is that if you look at the dependencies section, you can see we have only 3 dependencies. We have dependency to React, which is the main React library. We also have dependency to React DOM, which is a library for working with the DOM. In the last lecture, we used the render method to render a React element inside of the browser DOM. And we also have React scripts, which is another library that takes care of starting, building, testing, and ejecting a create React app project. So the interesting thing here is that under dependencies, you don't see any references to tools like Webpack, Babel, and so on. And this is the beauty of using a create React app project. All that complexity is hidden. Now, if we eject from create React app, you will see all those dependencies appear under the dependency section. Let me show you. So back in the terminal, from the project folder, execute npm run eject. Note this warning here. Are you sure you want to eject? This action is permanent. Basically, ejecting is a one-way street. So don't do this unless you're an advanced developer and you know what you're doing. So don't do this, just watch what I'm doing. Let's go ahead. So now back in package.json, under dependencies, you can see every single dependency that is used in this project. You can see Babel libraries. Here we have ESLint, as well as a bunch of other libraries. You can see we're using Webpack version 3.8.1. Also, we have a new folder, config. This is where all the configuration is stored. So if you want to overwrite Webpack configuration for your development or production environments, you can open up these files and make any necessary tweaks. But earlier, before ejecting, we didn't have this config folder. Neither did we have all those dependencies in package.json. Everything was cleaner and handled behind the scene. So use eject only if you know what you're doing. To demonstrate the modern JavaScript features, I'm going to use a brand new React project. So in this project, let's open up index.js and delete all the code here and focus on plain vanilla JavaScript. So the first thing we're going to look at are the new keywords for defining variables and constants. So let's define a function, call it say hello. Here I'm going to define a loop. So for var I, we set this to 0. As long as it's less than 5, we increment I and log it on the console. Pretty simple, right? Let's call this function, save the changes, back in the browser. So here we see these numbers 0 to 4, pretty straightforward. However, there is a problem with the var keyword in JavaScript. In most programming languages, when we declare a variable, that variable should only be accessible in the block in which it's defined. This is what we call scope, right? So in this case, I should only be accessible inside of the for block. However, I can come here and log I on the console and you will see that I is still accessible here. Save the changes, back in the browser. Look, we've got I displayed here because in the last iteration, I becomes 5, and because 5 is not less than 5, we exit this loop. So this is what I want you to take away. When you declare a variable with the var keyword, that variable is accessible inside of the function in which it's defined. And this is one of those weird things about JavaScript that is different from other programming languages. So in ECMAScript 6 or ES6, which is the version of JavaScript introduced in year 2015, we got a new keyword for declaring variables, and that is let. So let came to solve this problem. When you declare a variable with the let keyword, that variable is only accessible inside of that block. Let's see the result. So save the changes back in the browser. Now we get this error on the console. I is not defined. So here's what I want you to take away. Variables declared with the var keyword are scoped to the function, whereas variables declared with the let keyword are scoped to the block in which they are defined. So going forward, you should prefer to use the let keyword unless you have a very valid reason for using the var keyword. Now we also have another new keyword in ES6, and that is const. We use const to define constants. I'm going to show you that in a second, but similar to let, variables defined with const are also block scoped, so they're only accessible inside of the block they're defined. Now let me show you the difference between let and const. So I'm going to delete all this code here. Let's define a variable with const, set it to 1. Now if we reassign this and save the changes, back in the browser you can see that x is read only. In other words, when you declare a variable with the const keyword, that variable cannot be reassigned. That's why we refer to that as a constant. So technically it's not a variable because it cannot change, it's a constant. So let's quickly wrap up. Throw away the var keyword and prefer to use const over let. Use let only when you need to reassign a variable. All right, now let's take a look at objects. So once again, I'm going to use the const keyword to define a variable, well, more accurately, a constant, and set it to an object. So as you know, objects in JavaScript are collections of key value pairs. So I'm going to add a couple of key value pairs here. The first one is name, which we set to a string, and the second is walk, which we set to a function. Now in object-oriented programming terms, if we have a function inside of an object, we refer to that function as a method. So here we say walk is a method in the person object. Now starting from ES6, there is a cleaner and simpler syntax to define a method in an object. So let's add another method here. I'm going to call this talk. Now here we don't need to add a colon and the function keyword. We can define it like this. So basically, we drop the colon and the function keyword, and here's the result. So here we have a person object with 3 members, 1 property, and 2 methods. There are 2 ways to access these members. We can use the dot notation, which you are probably familiar with. So dot, talk, or walk. We can also use the bracket notation. So person, we add square brackets, pass a string, and this string determines the name of the target member. So if you want to access the name property, we pass that here. And now we can reassign that to a different value. In terms of practicality, we use the bracket notation when we don't know ahead of time what property or method we're going to access. Let me show you what I mean. So I'm going to define a constant, call it target member, and set it to name. Imagine this target member is an input field on a form. Depending on what the user types in that input field, we're going to access a different property in this person object. That's when we use the bracket notation. So instead of hard coding name here, we pass target member. And once again, this could be an input field, so we could access the value property like this, and then dynamically access a property or a method in an object. If we know ahead of time what property or method we're going to access, we use the dot notation. So we write person.name, we set it to a different value. Next, we're going to look at the this keyword in JavaScript. So we have this person object with a walk method. Now let's modify this method and do a console.log of this. What is this? This is a special keyword in JavaScript which confuses a lot of developers because it doesn't behave the same as this in other programming languages like C# or Java. In these languages, this always returns a reference to the current object. Let me show you. So here, I'm going to call person.walk, save the changes, back in the browser. So we see our person object on the console. So in this case, this is returning a reference to this person object, right? However, this in JavaScript does not always work that way. Let me show you why. So I'm going to define a constant, call it walk, and set it to person.walk. Note that I'm not calling the walk method, I'm just getting a reference to this function. So walk is now a function. Let me show you. So console.log of walk. Now back in the browser. So you can see our walk constant is set to this function, right? Now let's see what happens when we call this function. So I'm going to call walk, save the changes, back in the browser. What's going on here? So we don't get a reference to the person object. We get undefined. That's why I told you that the this keyword in JavaScript behaves differently from other programming languages. The value of this is determined by how a function is called. If we call a function as a method in an object, this will always return a reference to that object. However, if we call a function as a standalone object or outside of an object, this will return the global object, which is the window object in browsers. But in this particular implementation, we didn't see the window object here, we got undefined. The reason for this is because in this React project, the strict mode is enabled by default. If you're not familiar with the strict mode, it's basically a mode to execute JavaScript code in a more protective way. So it prevents potential problems. That's why, in this case, instead of getting a reference to the window object, we get undefined. So in the last lecture, you learned that when we call a function as a standalone function outside of an object, this by default returns a reference to the global object, which is the window object. And if the strict mode is enabled, it returns undefined. In this lecture, I'm going to show you how to fix this problem. So no matter how we call the walk function, this will always return a reference to this person object. So one thing that might be new to you is that in JavaScript, functions are objects. So here, person.walk is actually an object. Don't believe me? Let me show you. So dot, look, these are all the members of the walk object. So every function in JavaScript is an object with these members. We've got this method here, bind, and we can use this method to bind a function to an object. What do I mean by this? So when we call this, note the first argument is called this arg. What we pass here as an argument will determine the value of this. In this case, if I pass this person object here, the bind method will return a new instance of this walk function and set this to point to this person object. So now when we call this walk function, we will see this person object on the console. Let's have a look. Save the changes, back in the browser. Look, the bind method fixed our problem. So let's quickly recap. Functions in JavaScript are objects. They have properties and methods we can use. One of the important methods that you see in a lot of React applications is the bind method. With the bind method, we can set the value of this permanently. So when we call bind on the walk function, we get a new walk function, and in that walk function, the value of this is based on the argument that we pass to the bind method. So because here we're passing the person object as an argument, we'll get a walk function that is always attached to this person object. And that's why when we call it here, without a reference to the person object, we'll still see the person object on the console. One of my favorite features in modern JavaScript is arrow functions. So let's define a constant, call it square, and set it to a function that takes a number and simply returns number times number. So this is the old JavaScript. Now, starting from ECMAScript 6, we have a cleaner way to write the same code. So let me duplicate this so you can see both versions side by side. To convert this function to an arrow function, we get rid of the function keyword and put a fat arrow between the parameters and the body of the function. Now, if we have only a single parameter, we can exclude the parentheses. If we have 0 parameters, we have to add empty parentheses. So this is a function that takes no parameters, okay? Now, let's revert this back. We have a single parameter number. Now, if the body of our function includes only a single line and returns a value, we can make this code even shorter. We can get rid of the return keyword as well as the curly braces. And this is the end result. So the code we have on line 5 is exactly equivalent to what we have here. You can see the syntax is cleaner and more compact, and you can read it like number goes to number times number. So we can call this square function like this and log the result on the console. And let's remove this. Otherwise, we'll get an error because we have declared the square constant twice. So save the changes. Back in the browser, we get 25 on the console. Now let me show you where these arrow functions are really useful. Let's imagine we have an array of jobs. So each job object has maybe an ID and a property called isActive, which we set to true or false. Now I'm going to add a couple more here and make the first 2 jobs active and the last one inactive. Okay. Now let's imagine we want to get only the active jobs. So we call jobs.filter method. The argument that we pass here is a predicate function. A function that takes a job object and returns a true or false. So when we call the filter method, this method iterates over this array. For each job object, it takes that job object and passes it to this predicate function. The job of this predicate is to determine if that job object should be returned from the filter method. So here we can return job.isActive. If we return true here, that job will be returned from the filter method. So we can get the final list and call it active jobs. Okay. Now here we have a simple function. And this is a perfect opportunity for us to use an arrow function and make this code cleaner and more readable. So I'm going to duplicate this line so we can compare them side by side. So as I told you, to convert this to an arrow function, we get rid of the function keyword, delete, put a fat arrow between the parameters and the body. Now we have a single parameter, so we can get rid of the parentheses. And we have a single line here. We're simply returning a value. So we can get rid of the return keyword as well as the curly braces. And we don't add the semicolon here. So this is the end result. You can see this code is cleaner and easier to read. So filter jobs where job is active. There is less noise in this code. One thing you need to know about arrow functions is that they don't rebind this. Let me show you what I mean. So I'm going to start by defining a person object. Here we're going to have a simple talk method. Let's log this on the console. Okay, so we call person.talk. What do you expect to see on the console? A reference to the person object, right? Let's make sure everything's working. So back in the browser. So we have this, and next to that, we have a reference to our person object, right? Now let's see what happens if we wrap this line inside of a call to the setTimeout function. So as you probably know, in JavaScript, we have this global function, setTimeout. We can give it a function and a timeout value, let's say 1000 milliseconds. So setTimeout will execute this function after this delay, 1 second, right? Now in this callback function, I want to log this on the console. So previously, when we logged this on the console, we saw the person object. Now let's see what happens when we log this inside of this callback function. So save the changes, back on the console. We get the window object, not the person object. What's going on here? The reason this happened is because here, this callback function is not part of any objects. So it's not like the talk method in the person object. It's a standalone function. And as I told you before, when we call a function as a standalone function outside of an object, by default, this returns the window object. Now, in the previous example, instead of the window object, we got undefined because in that particular case, when we got a reference to a method in an object, the strict mode kicked in and returned undefined instead of the window object. But in this particular case, in case of callback functions, the strict mode does not override this behavior. So this returns a reference to the window object. So how can we solve this problem? In other words, how can we have a reference to the person object inside of this callback function? Well, here's one solution. So in the old days, we used to declare a variable, call it that or self, and set it to this. So we set this variable outside of this callback function. And now we can use self inside of this callback function to get access to the person object, right? So now let's log self on the console. So self and self. Save the changes, back in Chrome. You can see we have a reference to the person object. So this is the pattern that we used in the old days. Now with arrow functions, we no longer have to do this because arrow functions don't rebind this. In other words, if we change this callback function to an arrow function, it will inherit the this keyword. Let me show you. So I'm going to change this to an arrow function and revert this back to this, right? Save the changes, back in the console. You can see this returns a reference to the person object. In other words, here in this callback function, because we have used the arrow function syntax, this is not reset. Instead, it inherits this in the context in which this code is defined. So this is what I want you to take away. Arrow functions don't rebind the this keyword. ECMAScript 6 introduced a new method in arrays called map. This is a very useful method, and in React, we use it to render lists, as you will see in the next section. So whenever you want to render a list of items, that's when you use the map method of arrays. So let's say we have an array called colors with 3 items, red, green, and blue. Let's imagine we want to render these using list items. So for each color, we want to have a list item like this, right? So we call the map method on this array, colors.map. Here we need to pass a callback function. The job of this function is to transform each element in this array. So this function is called by the map method for each item in this array. It takes one item at a time and returns a new item. So a callback function takes an item and returns a new item. Now in this case, I want to rename this item to color because we're dealing with an array of colors. Now we take a color, which is a string. We simply return a new string like this. We had the opening li tag plus color plus another string that includes the closing li tag. Now this map method returns a new array, so it does not modify the original array. Let's call that items. Okay, now we can simplify this code, we can make it cleaner. So we have a callback function. It's a very simple function and a great candidate for converting to an arrow function. So we get rid of the function keyword and put a fat arrow here. We have a single parameter, so we can get rid of the parentheses. We have a single line where we're returning a value, so we can get rid of the return keyword as well as the curly braces. Put everything on one line, get rid of the semicolon, and this is the end result. So you're mapping or transforming the array of colors. For each color, we return a string like this. Now we can take this to the next level and make this code cleaner. These concatenations here are a little bit ugly. So instead, we can use template literals in ES6. So instead of using single or double quotes, we use the backtick character. That's the character before number 1 on your keyboard. Here we can define a template for our string. So we want to have the opening and closing li tags. And in the middle, we want to render the color dynamically. So we add a $sign and curly braces. This is an argument placeholder. What we put in between the braces will be rendered dynamically at runtime. So here we want to render this color that we have here, right? So this is what we call a template literal. Now we get a new array. Let's log that on the console. So console.log items. Save the changes. As you can see, we have an array with 3 items. So this map method is very useful in React when rendering lists, as you will see in the next section. One of the modern JavaScript features that you see a lot in React applications is object destructuring. So let's imagine we have an address object like this. We have street set to some value, city, and country. Now let's say somewhere in the code, we need to extract the value of these properties and store them in separate variables. So this is what we typically do. Constant street, we set it to address.street, and similarly, city, we set this to address.city, and finally, country. The problem with this code is, oops, I missed a T here. The problem with this code is that we have this repetitive address.address.address.code in multiple places. Destructuring solves this problem. So if we want to have 3 variables or 3 constants, street, city, and country, and we want them to be set to these properties in the address object, we can rewrite this code like this. So constant, we add curly braces. This is the destructuring syntax. We add the name of the target properties, in this case, street, city, and country. We set this to the address object. So what we have on line 11 is exactly equivalent to these 3 lines. And we no longer have that repetition of address dot. So basically, we're extracting the street property from the address object and storing it in a constant called street. Now, you don't necessarily have to list all the properties in the address object. Maybe you're only interested in the city property. In that case, you can drop these 2 other properties. Now, what if we want to use a different name here? For example, what if we want to call this constant st? We can use an alias here. So we add :st. With this syntax, we're defining a new constant called st, and we're setting that to the street property of the address object. So this is object destructuring that you will see a lot in the future sections. Another modern JavaScript feature that we use quite a lot in React is the spread operator. Let's say we have 2 arrays, first with 3 numbers and second with 3 more numbers. Let's say we want to combine these 2 arrays. One way to combine this is like this. So combined, we get the first, call the concat method, and pass the second array. This is the old way of doing things. Now with the spread operator, we can rewrite this code like this. So constant, combined, we create a new array, we spread the first array, and that means we'll get every item in this array and put it in our new array. And then similarly, we'll spread the second array. So the spread operator is represented using 3 dots. Now, in the first glance, you may say, there is really not much of a difference between what we have on line 4 or line 5 in terms of the length of the code. So why is this an improvement? Well, What if we wanted to add an element somewhere in the middle? So we can simply come here and add an element right in the middle. But when using the concat method, if you want to get the same result, our code would end up looking more complicated. Similarly, we can add another element here at the end. So B, we can visually see what the end result will look like. So we have a new array. First, we spread all the items in the first array. Then we have A and so on. So basically, when we apply the spread operator on an array, we'll get each individual item in that array. Now, using the spread operator, we can easily clone an array. Let me show you. So I'm going to comment out these two lines. Let's say we want to clone the first array. We define a constant, clone. We create a new array and simply spread the first array. Now, if we log first and clone, you will see they are identical. Save the changes back in the console. So here's first and here's clone. Now we can also apply the spread operator on objects. So I'm going to rewrite this code, but use an object instead. So let's delete everything. Don't worry, you're not going to forget this. So let's define a constant, call it first. We set it to an object with the name property set to mosh. Then a second object with another property, job instructor. Okay, now let's say we want to combine these two objects into one object. We declare another constant called combined. We create a new object. Note that previously we created a new array because we were combining two arrays. Now we're combining two objects, so we create a new object. Now in this new object, we want to add all the properties of the first object. So we spread the first object. Then we'll also spread the second object. We can optionally add other properties. Let's say location Australia. Now if we log this combined object on the console, we get this object with three properties. Similarly, we can use the spread operator to clone an object. So if I want to clone the first object, I can do like this. A new object, we simply spread the first object and boom, we're done. Now let's talk about classes. So look at this piece of code. We have this person object with two members, name and walk. What if we want to create another person object that can walk? Well, let me temporarily duplicate this code and call this other object person2. Now there is a problem here. The problem is that we have duplicated the implementation of the walk method. Now this implementation is currently a single line of code, but in a real-world application, this method can be 5 to 10 lines of code or maybe more. If there is a bug in this method, then we'll have to come back and fix it in all person objects. That doesn't make sense, right? So when we have an object with at least one method, we need a blueprint to create objects of that type. And that's when we use classes. So let me show you how a class can help us solve this problem. I'm going to delete the second person object and create a class. So we start with the class keyword, give our class a name, person, and note that here I'm using Pascal naming convention. So the first letter of every word should be uppercase. Now, as another example, if we wanted to call this class cool person, we would have to name it like this. So note that C and P here are capital, okay? So here's our class. Then we add a code block. Now we need to move our walk method inside our person class. So I've selected this code. I'm holding down Alt and then press the down arrow. So we can move it like this. Easy, right? Finally, we need to add another method here. That method is a special method that is called constructor. So just like the walk method, constructor is a method, but the name is reserved. It's a special keyword. That's why, similar to the class keyword, it is orange. Okay? Now this constructor can take parameters. So we can pass the name from the outside and initialize it here. How? Well, we use this In this case, this always returns a reference to the current object. So we set the name property on that object to this name argument that we receive from the outside. Now we have a blueprint for creating person objects. So let's delete this code on the top. To create a person object, we can do something like this. So person, we set it to a new person object. So this new keyword or the new operator is very important here. When we have a class, to create an object using that class or that blueprint, we need to use the new operator. Now we add parentheses and you can see our name parameter. So if you ignore the new keyword for a second, this expression looks like calling a function. And that's exactly our constructor method in the person class. So the parameters that we define there, we can set them here. So I'm going to pass Mosh as an argument. Now we have a person object. You can see it has the name property and the walk method. With this person class, we have implemented the walk method in a single place. If tomorrow we find a bug in this method, there's a single place we need to modify. So this is the benefit of using classes. Next, we're going to look at inheritance. Now let's take the example from the last lecture to the next level. Let's say we want to define a teacher class. So class teacher. Here we add a teach method and simply do a console.log of teach. Okay. However, all teachers should be able to walk because they're all persons. We don't want to duplicate this walk method in the person and teacher classes. So how can we solve this problem? Basically, there are two solutions here. We can use inheritance or composition. The explanation of both these approaches is beyond the scope of this course. That's something that I have talked about in my other course, Object-Oriented Programming in JavaScript. But as far as React is concerned, you need to understand the concept of inheritance. So we can have this teacher class inherit from the person class, and this means it will inherit all the methods defined in this person class. How can we do it? Very easy. So here we add a keyword extends person. So teacher extends person. Now, if we create a teacher object, so teacher, we set it to a new teacher. Look at its constructor. You see the name parameter, right? So the teacher class is also inheriting the constructor of the person class. Okay, so let's pass a name here, Mosh. Now teacher dot, look, we have the name property, which we have inherited from the person class. We have the teach method that we added specifically in the teacher class, and walk, which we also inherited from the person class. So this is inheritance in action. Now let's take this to the next level. Let's imagine when creating a teacher, apart from the name, we need to pass their degree. So here in the teacher class, we need to add a constructor. This constructor should take two parameters. One is name, which we need to pass to the person class, and I will show you that in a second. The other parameter is the degree. So degree. Now, because we added a custom constructor here, we need to call the constructor of the person class. If we don't do that, we'll get an error. Let me show you. So down the bottom of this file, let's remove this line teacher dot, save the changes, back on the console. Look at this error, missing super call in constructor. And you can see it's pointing to line 12. This is where we are defining the teacher class. Right after that, we have the constructor. This is where the problem is happening. So back in the code, whenever we add a constructor in a child class, we need to call the constructor of its parent class. So here in the constructor, we have this special keyword, super, that references the parent class. So we call it just like a method. And you can see here we have the name parameter. So we pass this name argument that we receive here. So this will initialize the name property. Next, we need to initialize the degree property. So this, the degree, we'll set it to this degree argument. Now finally, on line 22, we need to pass the second argument, the degree, that is, let's say, Master of Science. So if we type teacher dot, now you can see we have two properties, degree and name, as well as two methods, teach and walk. So this is inheritance in action. As you will see in the next section, whenever we create a component, we should have that component extend the base component that is defined in React. Because that base component in React has a bunch of methods that we need in our components. So we're done with classes. Next, we'll look at modules. So here's the code that we wrote in the last lecture. Currently, this file is getting a little bit bloated because we have multiple classes defined in the same file. It would be much nicer if we split this code across multiple files. And this is what we call modularity. So instead of writing all the code in one file, we write our code in multiple files. We call each file a module. In the old days, we didn't have the concept of modules natively in JavaScript. So there were many third-party solutions. But starting from ECMAScript 6, we have the concept of modules natively in JavaScript. So let's go ahead and modularize this application. I'm going to move each class in a separate file. Let's start with the person class. So create a new file, back in index.js, select the person class, cut it, and put it here. Now let's save this as person.js. Similarly, we need to go back to index.js and grab the teacher class, cut it, create a new file, paste it here, and save it as teacher.js. So now we can see we have less code in each file, and our application is more maintainable. But we're not done yet. When working with modules, the objects we define in a module are private by default. So that means this teacher class that we have defined here is not visible to any other files or modules in this application. In order to make this visible, we have to make it public. And we do that by exporting this class to the outside. So we export it from the teacher class and then we import it wherever we need it. So doing that is very easy. We simply prefix the class with export. Okay, save the changes. Similarly, we go to the person module. So we need to export the person class because we have referenced that in our teacher module. Here, we're using the person class, right? But currently, we have not imported this person class here. So on the top, we add import, curly braces, person, from, in quotes. You can see IntelliSense in VS Code is suggesting a few libraries like React, React DOM, and so on. These are the libraries that we have specified as dependencies in package.json. So let me quickly show you. Back in the project, here, if you look at package.json, we've got 3 dependencies here. And these dependencies are stored in node modules folder, right? So currently, we don't want to import anything from these modules. We want to import from our own modules. So let's close this. So here we need to pass the relative path to the target file or the target module. We start with period, slash, and that indicates the current folder. Here are the files in the current folder. So we want to import this person class from this person file. Note that here we don't add the extension, just the file name. So we don't add .js, okay? And finally, we need to terminate this statement with a semicolon. So we imported the person class from the person module. Finally, we need to go back to index.js. And because here we're using the teacher class, we need to import it. So once again, import curly braces, teacher, from relative path, that is period slash teacher. Save the changes. Now to make sure that everything works, let's call the teach method. Save the changes. And here in the console, you can see the teach message. Beautiful. So we successfully modularized this application. In the next lecture, we'll talk about default and named exports. In the last lecture, I told you that the objects that we define in a module are private by default. So they are not accessible from the outside unless we export them. Let's explore this topic in a bit more detail. So here in our teacher module or teacher.js, I'm going to define a function. Let's call that promote. We don't have any code here, just a simple function. Now save the changes. Back in index.js, so on the top, we're importing the teacher class from the teacher module. Temporarily, I'm going to delete this. Press Control Space. So with the IntelliSense, you can see here we have the teacher class that is exported from the teacher module, but we don't see our promote function, right? So back to teacher.js. If we export this function, now we can import it in index.js. So save the changes, back to index.js. Once again, Control Space. Look, we have the promote function and the teacher class. So we can export one or more objects from a given module. These are what we call named exports. So what is exported has a name, like the promote function or the teacher class. Now, apart from named exports, we also have the concept of default export. And that is the main object that is exported from a module. Typically, we use default exports if there is only a single object that we want to export. Let me show you what I mean. So back to teacher.js. Let me temporarily comment this out. So you can see currently we are exporting only a single object. That is the teacher class, right? Now you might say, but Mosh, a class is not an object. Well, in JavaScript, technically a class is an object because JavaScript classes are syntactic sugar over constructor functions. And functions, as I told you before, are objects. So a class is technically an object in JavaScript. Now that aside, here we're exporting a single object. Now, we can add the default keyword here, and that means this teacher object is the main thing or the default thing that we're exporting from this module. Now with this, back to index.js, we don't need the curly braces anymore. We use these braces only to import the named exports. In this case, teacher is the default export, so we import it like this. Save the changes. You can see our application is still working. We've got the teach message on the console. So let me quickly recap. With default exports, we import them like this. Import whatever from this module. With named exports, we import them like this. We put them in curly braces. Okay. Now it is also possible that a module has a default export as well as a bunch of named exports. React module is an example of that. And I'm going to show you that in a second. So back to our teacher module. Here we have a default export, but I'm also going to export this function. So we have a named export as well as the default export, right? Save the changes back in index.js. So on the top, we are importing the default export. Also, we add curly braces, Control Space. Look, we have the promote function. This is a named export. We can import that as well. Now, why does this matter? This is a pattern that you see a lot in React applications. So as you will see in the following sections, on top of almost every file in a React application, we have an import statement like this. Import React, comma, braces, component from React. You can see this import statement looks very similar to what we have on line 1. So let's see what's going on here. Obviously, React is the module, but note that here we don't have period slash because we use that only for our own modules that are part of the project. But React is not part of our project. It's a third-party library that is stored inside of the node modules folder. Okay. Now React is the default export from this module, whereas component is a named export. So if I delete this and press Control Space, you can see all the named exports in the React module. 99% of the time, we're going to use the component class because we want our custom components to extend this component so they will inherit all the behavior, all the methods implemented inside of this class. Okay? So that brings us to the end of this section. I hope you enjoyed the material, and I will see you in the next section. All right, we're ready to start learning React. So over the next 2 sections, we're going to build this application. At the first glance, you may think this is stupid, but this is actually the pattern behind items in a shopping cart. So imagine each row we have here represents a product. Here we have the quantity of that product in the shopping cart. We also have buttons to change that quantity. Note that if the quantity reaches 0, this decrement button becomes disabled. Also, we are displaying the quantity in a yellow badge. So you will learn how to render content dynamically, how to apply CSS classes dynamically. We also have this delete button for removing an item from this list. We also have another button for resetting the quantity of all the items to 0. And finally, we have this badge on the navigation bar, which is like e-commerce applications. So as you add items in the shopping cart, it shows the total number of items in the shopping cart. But in this application, it behaves a little bit differently. It only shows the number of counters with value greater than 0. So currently we have 3 counters, but only the first one, its value is 1. And that's why we have 1 in the navigation bar. If I increment the value of the second counter, now we have 2 in the navigation bar. So this simple application exhibits patterns that you see in a lot of real-world applications. Now, let's get started. All right, let's start by creating a new project. So here in the terminal or command prompt, let's run create React app and give our application a name, counter-app. Okay, beautiful. Our new project is ready. So let's go to this folder, counter app, and start the application. Okay, beautiful. Now, here in VS Code, the first thing we need to do is install Bootstrap. In case you're not familiar with Bootstrap, it's basically a CSS library that gives our applications a modern look and feel. Now, to install Bootstrap, we need to go back in terminal. But if you look here in VS Code, we have this shortcut, toggle terminal. On Mac, the shortcut is Control and backtick. So let's open that up here. So here we have an integrated terminal. We can run npm install Bootstrap. Make sure to install the same version I'm going to install in this video. So version 4.1.1. Okay, beautiful. Now finally, we need to import this in index.js. So let's open up index.js. Here on the top, we need to add another import statement. So import quotes. Here in the IntelliSense, you can see Bootstrap. So let's go to this folder and then dist, which is short for distributable, then CSS, and finally bootstrap.css. So this is how we import Bootstrap CSS in our application. Save the changes. Back in the browser, you can see the font is changed. Next, we're going to create our first component. All right, now let's create our first component. So here in the source folder, let's add a new folder, components. By convention, we put all our components here. Now in the components folder, let's add a new file. We call it counter.jsx. Note that here I'm using camel notation. So the first letter of the first word should be lowercase, and the first letter of every word after should be uppercase. So if you wanted to call this file counter component, we would name it like this. Counter component with a capital C. Okay. Also, I highly encourage you to use the JSX extension instead of just JS, because with this, you will get better code completion. So here's our counter module. In this module, on the top, we need to import React and the component class from the React module. We can manually type it by hand, but let me show you a shortcut to generate this line. Earlier at the beginning of the course, I told you to install an extension called Simple React Snippet. So here on the extensions tab under installed, you can see I've got Simple React Snippets. This is a very powerful extension. It has a lot of shortcuts to quickly generate code. You can find all the shortcuts below. In this video, I'm going to use a couple of these shortcuts. One is imrc for generating the import statement, and the other is cc for generating a class component. So back in counter.jsx, type imrc, which is short for import React component, and press tab. Done. Next, type CC, which is short for create class, tab, done. And here we have multiple cursors. So what we type is reflected in both places. Let's give this component a name. So counter with a capital C. Now to stop multi-cursor editing, press the escape button. So we have this counter class that extends the component class that we imported on the top from the React module. This component class has a bunch of methods that we're going to inherit in this counter class. Okay. Now, this code also generates the state property. In this video, we don't care about this. We're going to look at that later in this section. So delete it and modify the render method to return a simple h1 with the text hello world. Now to refresh your memory, what we have here is a JSX expression. It's not a string, it's a JSX expression, which eventually gets compiled to calls to React.create element. That's why we have to import the React object on the top, even though we are not going to directly use this in our code. Okay, so let's delete this line. So we have a simple component that when rendered returns an h1 element, right? Now note that in this generated code, we're defining the class here and then exporting it separately on line 9. This is different from what I showed you in the last section where I talked about modules. There, we defined a class and exported it on the same line. So here we can do something like this. Export default class counter. And then we can delete what we have on line 9. But going forward, I prefer to stick to the template that is generated by this extension, so I don't have to modify it every time. Okay, so let's revert this back. We're done with this component. Now let's use it. So save the changes. We need to go to index.js. So on the top, we can type index.js. And if you're curious how I brought up this little panel, you can find the shortcut here under the Go menu. So on Mac, it's Command and P. On Windows, I'm not sure. You need to find it yourself. So let's go to index.js. Here we need to import our counter class. So import counter from /components/counter. And note that because counter is a default export, we don't need curly braces around it. Okay. Now finally, on line 9, where we are rendering a React component, instead of the app component, we're going to render our counter component. So you can see with these components, we are extending the HTML vocabulary. So wherever we have a counter element, we'll get the output of the counter component, which is determined by what is returned from the render method. Now, back in the browser, we can see our counter component rendered in the DOM properly. All right, now let's add a button here. So right after h1, I'm going to add a button. We set the inner text to increment. Now you can immediately see a compilation error here. You have a red underline. JSX expressions must have one parent element. Why is that? Well, earlier I told you that these JSX expressions get compiled to a call to React.create element. Now, the first argument to this method is the type of the element that we want to create, in this case, h1. But when we have two elements side by side, Babel doesn't know how to compile this long expression into a call to React.create element. What is the type of the React element that should be returned from the render method? We can't tell. So one solution is to wrap this with a div. So let's add a div here and close it at the end. Now, when Babel sees this, it will compile this expression down to something like this. So we'll have a React element with the type div, and inside of that element, we'll have two other elements, an h1 and a button. Okay, so delete. Now see what happens when I save the changes. The prettier extension that I told you to install at the beginning of the course automatically reformatted this expression. Now it's more readable. And it also put parentheses around that. This is essential because of something that we call automatic semicolon insertion. So in JavaScript, if you have a return statement and nothing in front of it, JavaScript will automatically put a semicolon here. So if we add a div on the next line, JavaScript is not going to see that. It thinks you have a return statement with nothing in front of it. To solve this problem, we should put a parenthesis right in front of the return keyword and then close it at the end of our JSX expression. Okay, so delete. Now the good thing is that whenever you're dealing with a long JSX expression, as soon as you save the file, this prettier extension would automatically put these parentheses for you. So you don't have to do it manually. All right, save the changes. Now back in the browser, here's our button. Let's inspect this. So here we have this div with the ID root. This is coming from our index.html. I showed you this at the beginning of the course. So this is the div or the container for our React application. Inside of this div, we have this other div, which we added a minute ago, to wrap our h1 and button elements. Okay. Now, sometimes you don't want an extra div that is not doing anything here. In that case, you can use react.fragment. Let me show you. So back in the code, we imported this React object on the top. This React has a child called fragment. So we can replace these two divs with react.fragment. Now, if you're curious how I edited both these instances at the same time, this is called multi-cursor editing. So we can select a piece of code, press Command and D on Mac or Control D on Windows to find another occurrence of that selection. Now, if you have more occurrences, you keep pressing Command and D or Control D. Now we have multiple cursors. We can change all instances in one go. So react.fragment. Now save the changes. Back in the browser. This time, inside of our root div, we only have the h1 and the button. They are not contained by another div. All right, now let's take this to the next level. Instead of hard coding this hello world here, I want to display a value dynamically. So here in the counter class, we need to add a property, call it state, and set it to an object. State is a special property in React components, and basically it's an object that includes any data that this component needs. So in this case, let's add a property in this object, call it count, and set it to 0. Now here we could have a complex object. For example, we could have an address that could have a street property like this. So basically this state object includes any data that this component needs. In this example, all we need is a count property. So let's simplify this. Now I'm going to replace h1 with a span. So I've selected h1 and I'm pressing Command and D. Now we have multiple cursors. Let's change both instances to span. Done. Now let's remove hello world. Here we want to render something dynamically. To do that, we add curly braces. And in between these curly braces, we can add any valid JavaScript expressions. So if you want to render the value of the count property here, you would write code like this. This, to reference the current object, .state.count. Now save the changes. You can see the result here. So this is our count. If I change this to 1, save the changes. Now we see 1 here. Beautiful. Now, as I told you, in between these curly braces, we can write any valid JavaScript expressions. An expression is something that produces a value. For example, we can write something like 2 plus 2, save the changes, we get 4 here. Or we can call a function that returns a value. For example, let's add a method in this class, call it format count. In this method, we want to check the value of the count property. If it's 0, we want to return 0 as a string. Otherwise, we want to return the value of the count property itself. So we can do something like this. Return this.state.count. If it equals 0, we're going to return the label 0. Otherwise, this.state.count. Now, before looking at the result, I want to quickly improve this code. Look, we have this repetition of this.state.count. Whenever you have code like this, that's a perfect opportunity to use object destructuring that you learned about in the last section. So we can destructure this object and pick the count property. Like this. Const, we add curly braces, count, we set it to this.state. So we're picking the count property of this object and storing it in a separate constant called count. Now, I'm going to select this expression, press Command and D, so both these expressions are selected. Now let's change both of them to count. That is better. Save the changes. And finally, back here, let's call this.formatCount. Now, save the changes. So currently our count is 1. That's why we see 1 here. Let's change this to 0. Save the changes. We get the label 0. Now, to take this to the next level, we can also return a JSX expression here. Because as I told you before, JSX expressions get compiled to React elements. So here, instead of returning a plain text, we can return h1 with 0 as the inner text. So save the changes. Now we have an h1 here. So this is what I want you to understand. JSX expressions are just like normal JavaScript objects. You can return them from a function, you can pass them to a function, you can also use them as the value of a constant or a variable. So here I can define a constant and set it to a JSX expression. That's perfectly fine. So now let's simplify this code. We don't need this anymore. And here on line 19, I just want to return 0 as a plain text. Next, we're going to look at setting attributes. In this lecture, you're going to learn how to set attributes on these elements. For example, let's add an image here. We want to set the source attribute. If we have quotes here, whatever we type in between the quotes is rendered as plain static text. In this demo, we want to set the value of the source attribute dynamically. So let's add a property in this state object, call it image URL, and set it to something like this: HTTPS pick some photos/200. This will generate a random 200 by 200 pixel image. Now, back to our image element, let's replace the quotes with braces. In the last lecture, you learned that we can use these braces to render values dynamically. So here we want to render this.state.image URL. Save the changes. This is what we get. Beautiful. Now back to our code. So setting attributes is pretty straightforward, but let's look at setting the class and style attributes because they're a little bit different. So I'm going to delete this image element as well as the image URL. Let's say we want to apply a class to this span element. The name of the attribute is not class, it's class name. Because as I told you before, these JSX expressions get compiled to React elements, which are essentially plain JavaScript objects. We cannot use a class property on an object because that's a reserved keyword in JavaScript. So the name of the attribute in JSX is class name. Here I'm going to use a couple of bootstrap classes. One is badge and the other is badge-primary. Save the changes. This is what we get, a blue badge. Now this badge, this span is pretty close to this button. We can add a bit of margin to let the UI breathe. So back in the code, the name of the class is m-2, so margin 2. Save the changes. Now you can see there's a bit of space in between the span and the button. That looks better. Now similarly, let's apply a class to this button. So back in the code, here's our button, class name. We set this to btn, btn-secondary, and btn-sm, which is short for small. Now, if these classes are unfamiliar to you, you need to look at Bootstrap documentation. That's an entirely different topic. We cannot talk about it in my React course. So save the changes. And now our button looks different. That's much better. Now, finally, let's look at applying styles. So for the most part, it's best to use classes. This is for performance and maintainability. But there are times that you may want to break the rules if you know what you're doing, and you may want to apply a style to a specific element. Now, in JSX, we have this style attribute that we need to set to a plain JavaScript object. So first, we need to add curly braces here. Now, in between these curly braces, we need to pass a plain JavaScript object. Here's one way to do this. We can define a property, call it styles, set it to an object. The properties of this object are CSS properties in camel case notation. For example, font weight. So the first letter of the first word is lowercase, but the first letter of every word after is uppercase. Now we can set this to a numerical value like 10, and React will automatically convert this to something like this. So it will append pixels to the end. Actually, this should be font size, not font weight. So font size, 10 pixels, or just a numerical 10. And we can also set font weight to bold. Now we can pass this object here. So this dot styles. Save the changes. Now you can see our text is a little bit smaller and bold. To demonstrate that this is actually working, let me change this to, let's say, 50. Save the changes. And now we have a big badge here. So this is one way to apply styles. We define a property here and then reference it in our JSX expression. But maybe you want to apply styles to a couple of different elements, so you don't want to define multiple properties in this class. If that's the case, you can use inline styles. So here, in between these curly braces, we can just pass an object and set the properties on that object. So let's say font size 30. Now we don't need this styles property anymore. Let's save the changes. With this syntax, we'll get double curly braces. Now back in the browser, you can see our badge, its font size is now 30. In this section, we're only going to use the classes, so I'm going to delete the style attribute. Done. Next, we're going to look at rendering classes dynamically. Our badge is currently blue, but let's change this application such that if the value of the count property is 0, we want to render this as yellow to indicate some kind of warning. Otherwise, we want to render it as blue. So back in the code, when we use the badge primary class here, we get a blue badge. If we use badge warning, we'll get a yellow badge. So in this lecture, we want to render one of these classes dynamically depending on the value of the count property. And this is a pattern that you see a lot in real-world applications. So here's one way to do this. We can define a constant here, call it classes, set it to a string. In this string, we're going to include all the classes that we're going to pass here. So we start with the primary classes that we want to have in all cases, that is badge and M2. So badge and M2. Now, depending on the value of the count property, we want to add badge warning or badge primary to this string. So classes plus equal. Now note that we're modifying this, so we cannot use a constant. That's when we use the let keyword. So if this.state.count equals 0, we're going to append badge-warning. Otherwise, we're going to append badge-primary. Now, we could make this a little bit cleaner, so we don't want to repeat badge dash in a couple of places. We can add that here, badge dash, and here on line 10, simply append warning or primary. And finally, replace these hard-coded classes with what we have in this variable. So save the changes. Initially, our count is 0. That's why we have a yellow badge. But if we go back here and change the value of count to 1, save the changes, now we get a blue badge. Awesome. But we're not done yet. Look at our render method. These two first lines are purely about determining the class for this label. They are polluting our render method. It would be nicer if we encapsulated these two lines in a separate method so the details of calculation of the classes is not causing this method to get bloated. So let's extract these two lines in a separate method. Now let me show you a quick tip. I'm going to select these two lines, right click, look at this refactor menu. Note the shortcut. On Mac, it's Control, Shift, and R. So I'm going to use this shortcut, and this brings up the refactoring menu. So here we have a refactoring command called extract to method in class. So let's go ahead with that. Now you can see VS Code automatically extracted these two lines into a separate method. Now we need to give this method a name. Let's call that get badge classes. Always use descriptive names that determine the intention of your code. This makes it easier for other developers to read and understand your code. Okay, so here's our new method. Now we can simplify this code. We don't need this separate variable here. We can call this method directly right here. So this that get badge classes, and then we delete this variable. Now we can see our render method is cleaner. It's not bloated with various responsibilities. Save the changes to make sure everything is working. Our badge is blue, beautiful. Finally, let's change this to 0. Save the changes, and now it's yellow. Perfect. Next, we're going to look at rendering lists. In this lecture, you're going to learn how to render a list of items. So let's imagine we want to render a list of tags here. We start by adding a new property to our state object. Tags, we set it to an array of 3 strings, tag 1, tag 2, and tag 3. Now, here in our render method, we want to render these tags using UL and LI elements. Now, if you have worked with Angular, you have seen the ng4 directive. We use that to implement a loop in our templates. But in React, in JSX expressions, we don't have the concept of loops. Because JSX is really not a templating engine, it's just a simple syntax that will eventually get compiled to React elements. So how can we render a bunch of list items here? Well, in the last section, I talked about the map method of arrays. We can use the map method to map each element in this array into a React element. And with this, we can render a list of items. Let me show you. So here, we want to render something dynamically, so we start with curly braces. Next, we get this .state .tags. This is an array, so here we have a map method. Now, as the argument, we need to pass an arrow function. Tag goes to. Now, we get each tag and map it to a list item. As simple as that. So basically, what we're doing is we're getting a string and mapping it to a JSX expression, which gets compiled to a React element, which is essentially a plain JavaScript object. So even though the syntax here looks a little bit funny, what we're doing is taking a string and mapping it to a plain JavaScript object, right? Now, here in this JSX expression, we want to render the tag dynamically. So once again, we add curly braces and render the tag. As simple as that. So this is how we render a list of items in React. Let's save the changes back in the browser. So here are our tags, beautiful. However, if you look at the browser console, you should see this error. Each child in an array or iterator should have a unique key. The reason React is yelling at us here is because it needs to uniquely identify each item in this list. Because if the state of this React element in the virtual DOM changes, React needs to quickly figure out what element is changed and where in the DOM it should make changes to keep the DOM in sync with the virtual DOM. So, back in the code, whenever you're using the map method to render a list of items, here, for each item, you need to set the key attribute. So key, we set this to a dynamic value. Here, each tag is a string, and that string is unique. So we can use the same value for the key attribute. Now, in a real application, your tags might be objects, so they could have an ID property. Then you would use that here. Now, just note that this key should only be unique in this list. That is the list of tags. It doesn't have to be unique in the entire application or on the entire page. You could have multiple lists, and each item in a given list should have a key that is unique only in that list. Okay? Now, save the changes. Back in the browser, you can see the warning is gone. In this lecture, you're going to learn about conditional rendering. Now, to help us focus only on a single thing, I'm going to temporarily clean up this code. So in the render method, we don't need the span and the button. Let's delete those. Also, we don't need these two helper methods in the class either. So let's focus on something really simple. So we have an array of items, and we're rendering that in a list. Now here's the new requirement. If this array has at least one element, we want to render that array in a list. Otherwise, we want to display a message like there are no tags. How can we implement this? Well, once again, in JSX, unlike Angular, we don't have if and else because JSX is not a templating engine. So to render elements conditionally, we need to go back to our plain old JavaScript. Here's one way to implement this scenario. We can add a separate helper method like render tags. In this method, we can have our if and else statements. So if this .state, .tags, .length equals 0, we're going to return some text like there are no tags. And of course, instead of returning just plain text here, we could return maybe a paragraph. We're returning a JSX expression, which is a React element. So there are no tags. Or if you don't want to display anything, you simply return null. Okay? So this is the case for an empty array. Otherwise, we want to render the array using UL and LI elements. So I'm going to cut this code from here and simply return it in our method. Finally, in our render method, we add curly braces and call this .render tags. So depending on our state, this method will return either a paragraph or an unordered list with a bunch of list items. Pretty straightforward, right? Save the changes. Back in the browser, currently we have 3 tags, so we see them here. Now, back in the code, if I empty this array and save the changes, we get this message. There are no tags. There is also another technique for conditionally rendering content. Let me show you. So back in the code, here in our render method, just before rendering the tags, let's imagine we want to render a separate message based on a given condition. So we have only a single if statement without an else part. Okay? So we can add our curly braces here. Write the condition, let's say this .state, .tags, .length equals 0. If that's the case, we want to render an additional message. We add our logical AND operator here, and then whatever we want to render, we add that here. Let's say, please create a new tag. Save the changes. Back in the browser. So here's our message, please create a new tag. This is rendered only if our array is empty. Now, let's investigate how this expression works under the hood. So here we're applying the logical AND operator between two values. The first value is the result of this expression, which is a Boolean. It's either true or false. And the second value is a string. In JavaScript, unlike other programming languages, you can apply the logical AND between non-Boolean values. So let's go back to the browser and open up the console. Here in the console, I'm going to write plain JavaScript code. If we type true and false, we get false. What if we type true and a string, like hi? What do you think we're going to get? We get hi. Here's the reason. When a JavaScript engine tries to evaluate this expression, it looks at the first operand. In this case, the first operand is true, so it will look at the second operand. The second operand is not a Boolean true or false, so the JavaScript engine tries to convert this into what we call truthy or falsy. An empty string is considered falsy. A string that has at least one character is truthy. So in this case, hi is considered truthy, so essentially we have two operands that are both truthy. In that case, our JavaScript engine will return the second operand. Let's take a look at another example. So, true and hi and a number. Once again, the first operand is truthy, so the evaluation of this expression will continue. The second operand is also truthy, so the evaluation continues. Now we get to the third operand. In JavaScript, number 0 is considered falsy. Any numbers but 0 is considered truthy. So once again, here we have 3 truthy operands, and the result of this expression will be the last operand. So we get 1. So back to our render method. To conditionally render content, we can use the logical AND operator. First, we add our condition, then AND, and then whatever we want to render after comes here. It can be plain text or another JSX expression. Now let's see how you can handle events. So all these React elements have properties that are based on standard DOM events. For example, here in our button, we have a property on click. You also have on double click. If you're working with input fields, you have on key down, on key press, on key up, all those standard DOM events that you're familiar with. So here, let's handle the on click event. We set this to curly braces because we need to pass an expression. Now, the way we do this is by defining a method here, and the naming convention we use for that is handle. What are we handling here? Increment. So handle increment. Let's do a console.log increment clicked. And then finally, we need to pass a reference to this method here in between curly braces. So this dot handle increment. Note that we are not calling this method. We're simply passing a reference to it. This is different from handling events in vanilla JavaScript. In vanilla JavaScript, we call the target function when setting the onClick attribute. Also note that the name of the event here is case sensitive. So if we use a lowercase c here, we're going to get an error because React elements don't have a property called onClick with this naming convention. Okay, so let's revert this back, save the changes. As you can see, the Prettier plugin automatically reformatted this code. So now each attribute or property is on a separate line. Now back in the browser, let's click this button. There you go. We get these messages here. Beautiful. Now here in this method, we need to increment the value of the count property. But currently there is a problem with our implementation. So if we log this.state.count, we're going to get an error. Let me show you. So here, let's log this.state.count. Save the changes. Back in the browser, click. There you go. Cannot read property state of undefined. So back in the code, this is undefined in this method. Let's verify that. So let's just log this on the console. One more time. Let's click this. You can see this is undefined. So currently we don't have access to the state property. Why? That's the topic for the next lecture. So in the last lecture, you learned that in this event handler, we don't have access to this. Why is that? Well, earlier in the last section, you learned that this in JavaScript behaves differently from other languages. So depending on how a function is called, this can reference different objects. If a function is called as part of a method in an object, this in that function would always return a reference to that object. However, if that function is called as a standalone function without an object reference, this by default returns a reference to the window object, but if the strict mode is enabled, this will return undefined. And that's the reason in this event handler, we don't have access to this. So what is the solution? Again, in the last section, I talked about the bind method. We use that method to solve this problem. Let me show you. So here in this class, we're going to add a constructor. This is a method that is called when an object of this type is created. So in the constructor at this point, we do have access to this. So let me show you. Here I'm going to do a console.log saying here we are in the constructor. Let's see what is the value of this. Save the changes. Back in the browser, we get this error that you have seen before. This is not allowed before super. So because we added a constructor in this child class, first we have to call the constructor of the parent class using the super keyword. So we call super, save the changes, back in the console. Now you can see in the constructor, we do have access to our counter object. So this is not undefined at this point. So this is a perfect opportunity to use the bind method. So let's remove this line and type this, that handle increment. So earlier you learned that functions in JavaScript are objects. So they have properties and methods. One of them is the bind method. And with this method, we can set the value of this. So I'm going to use this here. And this bind method will return a new instance of the handle increment function. And in that function, this is always referencing the current object. So no matter how that function is called, this is not going to change. It's always referencing the current counter object. So this method returns a new function. We can get that function and reset handle increment like this. So this, that handle increment, we set that to the function that is returned from the bind method. Okay, so save the changes. Now back in the console, when we click the increment button, we no longer see undefined here. So we have access to the current counter object. And with this, we'll be able to update the state property. So here's one solution to bind event handlers to this. But you might find this a little bit noisy because in every component, you have to add a constructor. You have to call the base constructor. And for every event handler, you have to write code like this. There is another way to solve this problem. This is currently experimental and it may break in the future. So let's see how that works. Instead of adding this constructor, we can convert this function into an arrow function. Once again, in the last section, I told you that arrow functions don't rebind the this keyword. They inherit it. So we can set this to an arrow function and this will solve our problem. Save the changes, back to the browser. Let's call this button. We get our counter object, perfect. So you can see using an arrow function is cleaner and simpler than adding a custom constructor and rebinding every event handler manually. So going forward, I'm going to use this syntax, but if this feature is not available at the time of you watching this video, use the former approach to bind event handlers. Now that we have access to the current object in our event handler, it's time to update the value of the count property. So in React, we do not modify the state directly. In other words, we don't write code like this. This.state.count plus plus plus. It's not going to work. Let me show you. Save the changes, back in the browser, Click this button. See, nothing is happening. Well, technically, the value of the count property is being incremented, but React is not aware of that. That's why it's not updating the view. To solve this problem, we need to use one of the methods that we inherit from the base component in React. So we call this .setState. This method tells React that we're updating the state. Then it will figure out what part of the state is changed. And based on that, it will bring the DOM in sync with the virtual DOM. This is different from frameworks like Angular. In Angular, we don't have to do this. Angular automatically detects the changes because in Angular, all browser events are monkey patched. So whenever you click a button or type something in an input field, Angular is notified. It runs its change detection algorithm. It figures out what is changed and it will update the view. React doesn't work that way. We have to explicitly tell React what is changed. So here as the argument to setState method, we pass an object and the properties of this object will be merged with what we have in the state object, or it will override those properties if they already exist. So here I'm going to pass the count property and I want to set its value to this .state.count plus 1. So we get the current count, increment it, and then set it. Now let's delete what we have on line 9, save the changes back in the browser. Let's click this button. You can see our count is incremented because React is aware of the state changes. Now that you have seen a complete example of a component, let's see what exactly happens under the hood when we click the increment button. At this point, we're calling this .setState. This method is telling React that the state of this component is going to change. React will then schedule a call to the render method. So sometime in the future, this method is going to be called. We don't know when. This is an asynchronous call, which means it's going to happen in the future. It may happen 5 milliseconds later or 10 milliseconds later. We don't know. So at some point in the future, the render method is going to be called. This method, as you can see, will return a new React element. That element is this div that we have on the top. This React element has two children, a span and a button. So our virtual DOM is a tree of 3 elements. A React element on the top, that is our div, with 2 children. Okay? So here's the new virtual DOM. We also have the old virtual DOM. React will put these side by side and compare them to figure out what elements in the virtual DOM are modified. In this case, it realizes that our span is modified because that's where we have used the count property. So it will reach out to the real browser DOM and update the corresponding span so it matches the one we have in the virtual DOM. So nowhere else in the DOM is updated, only that span element. Let me show you. So here I'm going to right click on our badge, inspect it. This is what we have in the DOM. Now every time I click the increment button, you will see that only the span element is updated. So click, see, you can see only the span element is highlighted and nothing else in the DOM is affected. Currently, our handle increment method does not take any parameters. But sometimes in real-world applications, we need to pass arguments with our events. For example, let's imagine here we're dealing with a list of products in a shopping cart. When we click the handle increment button, we want to pass the ID of a product. How can we do this? Well, earlier you learned that in onClick, we need to pass a function reference. So here we cannot call handle increment and pass an argument like 1. We need to pass a function reference. So here's one solution. We can temporarily define another method here. Let's just call it doHandleIncrement for argument's sake. Now, similar to handle increment, we're going to use the arrow function syntax. So we have a function with no parameters. In this function, we can call this .handleIncrement with an argument. Let's say that argument is a product object with the ID 1. Now we can modify handle increment and add a parameter, call it E as in short for event, or product, whatever that parameter is representing. Now we can log this on the console. Okay, and finally, in our render method, instead of referencing this.handleIncrement, we can reference this.doHandleIncrement, right? Back in the browser, when I click the increment button, you can see our product object, which is the argument to the handleIncrement method. So this was one simple solution, but writing code like this is messy. We don't want to redefine another similar method as a wrapper just to pass an argument to the actual event handler. A better solution is to use an inline function here. So in onClick, instead of referencing this, the doHandleIncrement, we can simply pass this arrow function in between curly braces. So we write code like this. No parameters goes to this.handleIncrement, and then we pass an argument. Now, when rendering a list of products in a shopping cart, in our map method, we have access to a product object. So instead of hard coding this object here, we will pass a reference to the product that we're currently rendering. Okay? With this, we no longer need this helper method. So to recap, whenever you need to pass an argument to your event handlers, simply pass an arrow function here in the body of that function called the event handler and pass an argument. All right, now let's set up our Vidly project. So here in the terminal, let's run create React app and call this project Vidly. All right, our project is set up. Now let's go to the Vidly folder. We need to install two libraries. One is Bootstrap and the other is Font Awesome for rendering beautiful modern fonts. So npm install Bootstrap. Make sure to install version 4.1.1 so you won't have any issues following the course in the future. The other library is Font-Awesome, and the version for this is 4.7.0. Okay, beautiful. Both these libraries are installed. Now we need to import their CSS. So in VS Code, let's go to the source folder, open up index.js. Here we're going to import bootstrap/dist/css/bootstrap.css. And similarly, we're going to import font-awesome/css/font-awesome.css. So both these libraries, as you know, are installed under Node Modules folder. When we build this application, Webpack, which is the tool that bundles our JavaScript and CSS files, will pull in these CSS files and put them in our final bundle. Okay, now from the project folder, let's start this project. So this is what we get, but we want to get rid of this black banner and replace this file with a basic Bootstrap template. So head over to getbootstrap.com. Under examples, here we're going to pick a very basic template. So let's scroll down. Under framework, this is the template that I'm going to use, starter template. So open this page, right click, and go to view page source. Pay attention to what we have under the body tag. So first we have the definition of our navigation bar. We're going to ignore that for now. We're going to come back to that later. After nav, we have this main tag with the class container. This represents the content area of our application. Now in this template, in this content area, we have a div with the class starter template, an h1, and a paragraph. We don't care about this part because this will change from one page to another. What matters here is having this main tag with the class container. So back in our project, in index.js, you can see we are rendering our app component, which is the root component for our application. And this is where we have this black banner. So we want to go to our app component and modify our render method so it looks similar to Bootstrap's starter template. So back here, let's go to app.js. Here's our render method. You can see we're returning a div with the class name app. This is exactly where we have that black banner. So I'm going to delete everything here. Instead, I'm going to return a main element with the class name container. So this element will be the container for our content area. So for now, we can put a simple heading here. Let's say hello world. Save the changes. You can see the black banner is gone. And this is our content area, which is currently in the center of the screen. Now let's open up the browser console. The shortcut on Mac is Shift, Command, and I, and on Windows is Shift, Control, I. So currently we have one warning. In app.js, logo is defined but never used. We're going to get rid of this line because that logo is part of the starter React project. So here in app.js, you can see line 2 is grayed out. We don't need this. Let's delete it, save the changes. Back in the browser, we don't have any warnings or errors. Beautiful. Now finally, I want you to look at the zip file I've attached to this lecture. Inside of that zip file, you're going to find a folder called services. Expand that, you will see two files, fake genre service and fake movie service. We're going to use these two files throughout the first few sections. These files include a bunch of functions for getting the list of movies and genres, or adding a new movie or deleting one, as well as some sample data that we can use while building this application. So copy this folder inside of the source folder. So here we have our services. Look at fake movie service. You can see on the top we have an array of movies. Each movie object has an ID, title, genre, number in stock, daily rental rate, and publish date. Now the reason the ID field is prefixed with an underline is because that's the default name of the ID column in MongoDB. So to keep things simple, I wanted to stick to that convention. All right, here's your exercise for this section. I want you to build a movies component for displaying the list of movies in our application. So currently we have 9 movies in our imaginary database. There's really no database behind this application yet. Instead, we have 9 movie objects in the memory. And these movie objects are defined in our fake movie service that we added to our project earlier. So here we have an array of movies with 9 movie objects. So on the movies page, we have a message on the top showing 9 movies in the database. Below that, we have a table with 5 columns. Our columns are title, genre, number of movies in the stock, and the daily rental rate. Next to each movie, we have a delete button. When we click that, that movie disappears. You can see our message is updated here. If I delete all the movies, let's see what happens. So here's the last one. Are you ready? Delete. The table disappears and our message changes to there are no movies in the database. So I want you to spend 20 to 30 minutes on this exercise. There are actually multiple exercises here. So focus on one part at a time. Don't try to do too many things. First, work on rendering the table. Don't worry about the delete button. Make sure the table is rendered properly. Then add the delete button. And finally, work on this message on the top. Now, as part of this exercise, you need to get the list of movies from our movie service. Let me give you a quick tip about how to do this. So, if you look at our fake movie service, on the top, you can see this array of movies. And below this array, you can see a bunch of exported functions. Here's one, get movies, that returns all the movies. Here's another, get movie, that returns a movie with the given ID. Now for this exercise, you need to call this function to get all the movies. This is how you need to do this. So here's my implementation of the movies component. On the top, you can see I've imported the get movies function from this module. You can see I've used curly braces because we are importing a named export. Now, below that, we have our movies component. Here's our state object with one property, movies, that I have initialized by calling the get movies function. Now, this is not the right way to initialize the state property, but for the purpose of this exercise, that's perfectly fine. In the next section, you will learn the proper way to initialize the state property when I talk about component lifecycle hooks. For now, don't worry about it. So go ahead, spend about 20 to 30 minutes on this exercise. You will see my solution over the next few videos. I just want to let you know that over those videos, I'll be typing reasonably fast because I'm assuming you have gone through this exercise. So I don't want to waste your time typing slowly, assuming that you're going to code along with me. I'm assuming that you have already gone through this exercise and you want to quickly see how I would solve this exercise. All right, I'm going to start by creating the movies component. So here in the source folder, we need to add a new folder, components, and in the components folder, we're going to add a new file, movies.jsx. Now, remember the shortcuts that I taught you earlier? So IMRC, which is short for import react component. So look, import react component. Okay. The other one is CC, which is short for create class. Now we're going to call this movies and press the escape button. Okay. Now for now, I don't want to render a complex table. I just want to render a simple message and make sure we have built the skeleton properly. So let's just add an H2 element here, movies component. Save the changes. Now we need to go back to app.js. So this is the container for our application. Earlier we added this hello world here. Now I want to replace this with our movies component. So on the top, first we need to import movies from current folder /movies. And then I'm going to replace this with a movies element. Now note that in JSX, if there is nothing between the opening and closing tag, you should use the self-closing syntax. If you don't do this and save the changes, this prettier plugin will automatically do this for you. So back in the browser, we have an error here, module not found. So we can't resolve this movies module because I made a mistake. So back in app.js, if you look at the project folder, app.js is not in the components folder. And for now, I don't want to move it there. I just want to leave it here. So the correct path to the movies module is like this, components/movies. Now back in the browser, here we have our movies component rendered properly, beautiful. So back in the movies component, here we want to render a bootstrap table. Let's have a quick look at bootstrap documentation to see what the structure of a bootstrap table looks like. So on getbootstrap.com, let's go to the documentation and here search for tables. And next, if you scroll down, you can see the structure of a bootstrap table. So we need a table element with the table class. Inside the table, we should have a t-head for our heading. Inside the t-head, we should have a tr. And inside the tr, we should have a bunch of th elements. Now, next to the t-head, we should have a t-body. And inside that, we should have one or more trs with a bunch of td elements. So pretty straightforward, right? Now, back in our movies component, instead of manually typing the structure like table, t-head, tr, this is so time consuming. Let me show you a quick way to generate this markup. So we want to have a table with the class table. Inside the table, we should have a t-head. And inside the t-head, we should have a tr. And inside the tr, we should have 4 th elements. So th times 4. Press the tab, and this generates this markup for us. This technique is called Zen coding. So let's add our column headings here. The first one is the title of the movie. Then we have genre, we have stock, and rate. Now, similarly, we should have a t-body. Inside the t-body, we should have a tr. And inside the tr, we should have 4 td elements. So td times 4. Tab, we get this markup. Now, we want to render this dynamically. So for each movie, we should render a row. Now we need to get our movies, store them in an array, and map each element in that array to a tr element. So on the top, we need to import our fake movie service. Let's have a quick look at this file. So fake movie service. So on the top, you can see we have an array of movies, but because we have not exported this, this is private in this module. Now, if you scroll down, you can see a bunch of exported functions. The first one is get movies, which returns all the movies. The second one is get movie, which returns a movie with a given ID. And we got a couple more functions that we don't care about at this stage. So we need to import this function from this module. Back in our movies component, on the top, import. We're going to use curly braces because we're dealing with named exports. We want to import the get movies function from. Now currently we are in the components folder. So we need to go one level up and then go to the services folder and then load the fake movie service. Okay. Now here's our state object. We should add a property to it called movies. And we're going to initialize it by calling this get movies function. Now, this is not the right way to initialize the state property. We're going to look at that later in the next section when we talk about components lifecycle hooks. For now, don't worry about it. So we have initialized our state object. Now, finally, here, we should add a JavaScript expression. We get this .state.movies, call the map method, get each movie object and map it to a tr element like this. So cut this from here and paste it here. Save the changes to reformat the code. You can see this prettier plugin automatically closed our TD elements because we didn't have anything inside them. So now I have to delete this and one more time generate 4 TD elements. So TD times 4. Okay, now we have the opening and closing tags. So in the first column, we want to render movie, the title. And the second one, we want to render movie, the genre, the name. In the third column, movie, dot number in stock. And finally, in the last column, movie, dot daily rental rate. Save the changes one more time. Back in the browser, we should see the list of our movies in a table. Beautiful. Next, we'll add a delete button to each row. All right, now we want to add a delete button on each row. So first, let's add a new column here. In the T-head section, we need a new TH. This is going to be an empty TH because we don't want to have a label in the heading of this column. Next, we're going to add another TD here. In this TD, we want to render a button with a few bootstrap classes. So the first one is BTN. The second one is BTN-danger to give it the red color. And the last one is BTN-SM to make it look small. Press the tab. Here's our button. Let's call this delete. Before going any further, let's look at the result. So back in the browser. All right, our delete button is rendered properly. Beautiful. Now we need to handle the click event. So here we want to handle the onClick event. We set this to an expression. And here we should call a method like this. This.handle delete. Okay. So let's go ahead and create this method. Just above the render method, we add handle delete. Now earlier you learned that here we should use the arrow function syntax or bind this event handler in the constructor so we can get access to the current object. So I'm going to use the arrow function syntax to simplify things. Now technically here we need to get access to the movie that is going to be deleted. So this method should have a movie parameter, and that means we need to change this expression here. So in order to pass an argument, we need to change this to an arrow function. So here a function with no parameters, and in the body of this function, we're calling this.handle delete with an argument. That argument is this movie object that we are rendering. So here in our map method, this is the movie object that I'm talking about. So we pass that movie object as an argument to handle delete. Now to make sure we have set this up properly, let's go back to our method and do a console.log of this movie object. Save the changes back in the browser. So I'm going to open up the console. Okay, first of all, we have an error here because each child in an array or iterator should have a unique key. This is something we forgot to apply. So back in our render method, this is where we are using the map method of arrays. So as I told you before, every time you use this method, you should set the key attribute or the key property on the element that you're repeating. In this case, we want to set this key to movie.underline_id because that uniquely identifies each movie object. Now, back in the browser, you can see the error is gone. Let's delete this Terminator movie. So delete. On the console, we get the movie object. You can see the title is Terminator. Beautiful. Let's delete Die Hard. Now we get Die Hard on the console. Perfect. Now the last part is to update the state of this component. So back in our movies component, we need to update the state and basically remove that movie from our movies array. As I told you before, we should not directly update the state. Instead, we should call the setState method of our component. So we should create a new movies array that includes all the movies except the movie that we have passed here. This is how we can achieve this. So we define a constant, call it movies. Then we access this .state.movies. We use the filter method to get all the movies except this movie object. So we pass an arrow function here. M goes to m.underline_id does not equal movie.underline_id. So we are getting all the movies except the movie that we have passed here, right? So now we have a new array of movies. We can call this .setState. Here we pass an object. In that object, we should set the movies property to this movies object. So this object, the properties we have defined here will override the properties of our state object. Now in modern JavaScript, if the key and value are the same, we can simplify this code by removing this repetition. So we only pass this movies. Okay. Now let's test this. So back in the browser, I'm going to delete Terminator. It's gone. Now let's delete Trip to Italy. That's gone. Beautiful. So we're done with the deleting of movies. Next, we're going to render a message on top of this table. Back in our render method, if we have at least one movie, we want to return this table along with a message on the top that indicates the number of movies. Otherwise, we want to return a message like there are no movies in the database. So I'm going to add a conditional statement. If this .state, .movies, .length equals 0, we want to return, let's say, a paragraph with a message like there are no movies in the database. Okay. Otherwise, we want to render this table with a message on the top. So let's add a paragraph here showing, like here we want to render the number of movies in the database. What is this number? That is this, .state, .movies, .length. This is exactly the same expression we wrote earlier. So let's clean up this code by refactoring this expression into a separate constant. We can define a constant, use object destructuring. We're going to pick the length property of this .state, .movies. Now, it's better to rename this constant to something like count or movies count. So with this, we can replace both these expressions with count. That's better. So if count is 0, we're going to return this message. Otherwise, a different message and a table. However, if we go back in the browser, we're going to get an error because we're returning 2 elements from our render method. And as you learned earlier, in JSX, we should always return a single element. If you want to return multiple elements, they should have a parent. In this case, we can wrap these two elements with a div or a React fragment. So I'm going to add a React.fragment here. Now, let's select this paragraph and the table together, cut them, and we want to place them in between React.fragment. Okay, so here's the end result. React fragment, paragraph, table. Now back in the browser. So showing 9 movies in the database, beautiful. Now, if we delete all these movies, we'll get a different message. There are no movies in the database and our table disappears. Beautiful. Now currently this message is so close to the top of the screen. So let's add a padding to make this look better. We need to go to index.css. This is where we have the basic styles for our application. So you can see padding is set to 0. I'm going to change this to 20 pixels, 0, 0, 0. So that is 20 pixels on the top and 0 pixels on right, bottom, and left. Let's look at the result. That is better. In the last section, we worked with single components, but a real-world application consists of a tree of components. So in this section, we're going to look at composing components in React. More specifically, you're going to learn how to pass data between your components. You're going to learn how to raise and handle events, how to have multiple components that are in sync, as well as functional components and lifecycle hooks. These are all very important topics that you will use quite a lot in real-world applications. By the end of this section, you will have a very deep understanding of React components. Are you ready? Now, let's get started. So far in this application, we have worked with a single component. So if you look at index.js, you can see we are rendering a single counter component in the DOM. But as I told you before, a React application is essentially a tree of components. So we can compose components together to build complex user interfaces. And that's what we're going to do in this lecture. So I'm going to add a new component to our application. Here in the components folder, let's add a new file, counters.jsx. In this component, I want to render a list of counters. And then in index.js, instead of rendering a counter component, I want to render a counters component. With this change, our component tree will look like this. Okay, so back in index.js, instead of importing the counter component, let's import counters from the counters module and render that here. Now, back to our new component. On the top, imrc tab, cc tab. Let's call this counters. Okay. Now, in the render method, let's add a div. This is going to be the wrapper or the container for all our counters because we want to return a single element from the render method, right? So here, we want to add multiple counter components. First, on the top, we need to import the counter component from the current folder counter module. Now here, let's render a few counter components, save the changes, back in the browser. You can see we have multiple counter components. Each component has its own state that is completely isolated from the other components. Beautiful. Now let's take this to the next level. Instead of hard coding these counter components here, let's add an array of counter objects to our state property and render them using the map method. So here, let's add a new property, counters. We set it to an array. In this array, we're going to have counter objects like this. Each object should have an ID property, and we're going to use this to uniquely identify each counter. We should also have a value property, and we will later use this to set the initial value for each counter. For now, I'm going to set this to 0. Now let's duplicate this multiple times and change the IDs Okay, beautiful. Finally, let's get rid of these counters. Instead, we want to render an expression. Here, this, dot state, dot counters, dot map. We get each counter and map it to a counter component. Also, we should set the key property to counter.id. Save the changes. We still get the same output, and each counter has its own state. Beautiful. However, all our counters are initialized to 0, and the value that we set here is not applied to this counter components. So if I change the value of the first counter to 4, we still get a counter initialized to 0. We'll fix that in the next lecture. In the last lecture, we set the key attribute to counter.id. Using the same syntax, we can set additional attributes here, and with this we can initialize our counter components. So I'm going to put this on a new line so you can see clearly. Now let's add a couple more attributes here. So I'm going to set value to counter.value, and also selected, I'm going to set this to true. For now, I have hard-coded this value. Potentially in the future, this can be set to a property in our counter objects. Now, back in our counter component, here in the render method, I'm going to temporarily add a console.log and show you this .props. So every React component has a property called props, and this is basically a plain JavaScript object that includes all the attributes that we set in counters component. So these two attributes, value and selected, will be the properties of that props object. Key will not be part of that because this is a special attribute for uniquely identifying elements. So now, let's save the changes and go back to Chrome. You can see we have 4 messages on the console because we have 4 counter components. Look at the first message. Our props is an object with 2 properties, value, which we set to 4, and selected, which we set to true. So now we can read this value and use that to initialize each counter component. So back in our counter component, instead of initializing the count property to 0, I'm going to set it to this .props.value. Save the changes. Back in Chrome, you can see our first counter is initialized to 4. Beautiful. So here in the render method, we no longer need this line. Let's delete that. Also, I would like to rename this count property to value to be consistent with the property that we are setting from the outside. This makes our code cleaner and more maintainable. We don't have to do all the guesswork to remember what name we used where. So put the cursor here, press F2, and rename this to value. We should also rename this count property to value. So it's more meaningful to say a counter has a value as opposed to a counter has a count. Now, one more thing before we finish this lecture. Back in our counters component, here I've set selected to true. If I exclude the value, by default, it will be set to true. Now, going forward, we don't need this attribute, so I'm going to delete it. In the last lecture, you learned that the attributes that we set here are passed to our component using a single JavaScript object called props. Now, we have a special prop called children, and we use that when we want to pass something between the opening and closing tag of an element. So here, counter is self-closed, but sometimes we want to pass content in between the opening and closing tags. Maybe we want to pass an H4 here with some kind of title, like this. A real-world example of this is when using dialog boxes. Imagine instead of the counter component, you have a dialog box component, and you want to allow the consumer of that component to pass content to be rendered on the dialog box. So let me show you how to do this. Save the changes. Now, back in our counter component, one more time, in the render method, I'm going to show you the props property. So console.log of this.props. Now, back in the browser. So here's our props object. You can see we have the value property just like before, but we have a new property called children. Let's take a closer look. So children is essentially a React element. As we can see here, the type of this React element is h4. So back in our counter component, here in the render method, we can simply render the children prop. So here inside this div, right before our span, I'm going to render this.props.children. As simple as that. Save the changes. Now you can see each counter has a title. We can also make this dynamic. So here in counters component, instead of hard coding this title, we can do something like this: counter number, and then render counter.id dynamically. And here's the result. Now in this particular example, we didn't really have to use the children. We could simply pass the ID as another attribute. We could set that here, counter.id. And in our counter component, we could simply render an h4 that includes this.props.id. We would get the same result. But as I told you earlier, there are times that you want to pass complex elements to a child component, such as a dialog box. In those cases, you use the children prop. Now going forward, we're not going to use the children props, so I'm going to delete the code that I wrote in this lecture. So back in our counters component, let's delete the children. Done. In this lecture, I'm going to introduce you to a very useful tool for debugging React applications. This tool is currently available as an extension for Chrome and Firefox, and as a standalone app for Safari and Internet Explorer. So if you're using Chrome or Firefox, simply search for React Developer Tools. When you install this, you will see a new tab in Chrome Developer Tools. So here in our React application, let's open up Chrome Developer Tools. Here you can see we have a new tab, React. On this panel, you can see the tree of our components. So on the top, we have the counters component. When you expand that, you'll see a div, and below that, you will see all our counter components. Similarly, you can expand each counter component to see its content. So here we have a div with a span and a button. Now, why is this useful? Well, let's go on the top and select the counters component. On the right side, you can see the props and state for this component. So in this component, we don't have any props. So our props is an empty object, but our state has a counters property, which is an array of 4 objects. Let's take a look at the first counter. You can see the key is set to 1. Our props object has 2 properties, ID and value, and our state object has a value property, which is initialized based on props.value. So this panel makes it really easy to visualize what's going on the page, what are various components, what is the state of each component, and so on. We also have this search bar here. So if you're working on a complex page with several components, you don't have to expand them all here. You can simply search for that component in the search bar. Another useful feature here is this $R. So note that as I select each component here, we get this equal $R. What is this? Well, I'm going to select the first one. You know that in the first component, our value prop is 4. Now, if we go to the console tab and type $R, look, we get the instance of our first counter component. So let's expand this. Look at the props. Here we have an object with 2 properties, value, which is 4, and ID, which is 1. So with this $R, we can work with the instance of any components on our page. Let's look at another example. Here I'm going to type $R.render. I'm going to call the render method. You can see we get a React element, which is a plain JavaScript object the type of this element is div, because here in the render method, we are wrapping the content of our counter with a div. So that's why the type of the React element that is returned from this method is div. Now this $R feature is not limited to React. We have something similar in the Elements tab, but a lot of people are not aware of that. So here in our Elements panel, let's scroll down, expand our root div, expand this again. Here's our first counter, find the button, select that. You can see we've got equal $0. Similarly, we can go to the console tab, type $0, and this returns that button element in the DOM. We can do something like this, $0.click. We can click the button, and now we can see the count is 5. Let's execute this one more time. Now the count is 6. So have React Dev tools in your toolbox. It makes it really easy to build and debug React applications. So here in the counter component, we're using props to initialize the state. One of the things that confuses beginners to React is what is the difference between props and state. So in this lecture, I'm going to clarify this. Props includes data that we give to a component, whereas state includes data that is local or private to that component. So other components cannot access that state. It's completely internal to that component. In other words, if we go to our counters component, this is where we're using the counter component. All the attributes that we're setting here, these attributes are part of the props, the input to the component. We cannot access the state of this component. The state is local and internal to that component. Similarly, this counters component has its own local state, which is completely invisible to other components. Now, sometimes a component may not have a state. It may get all the data that it needs via props, and you're going to see that later in this section. One more thing you need to know about props versus state is that props is read-only. In other words, we cannot change the input to this component inside of this component. Let me show you. So if we go back to our counter component, here in handle increment, I'm going to change one of the properties of the props object. So this.props.value, I'm going to set that to 0. Let's see what happens when we click the increment button. So here I'm going to click this button. We get this error, cannot assign to read-only property value of object. So React does not allow you to change any properties of the props object. It's purely input to a component, and we should not modify the input. If we need to modify that input during the life cycle of a component, then we need to get that input and put it in the state. In this case, our counter component has its own local state, so we can modify this value in our handle increment button as we have done here. So let's delete this line. Next, we're going to talk about raising and handling events. Now let's take this application to the next level. I want to add a delete button next to each counter. So here in our counter component, in the render method, right after our increment button, I want to add a new button. So a button with a few classes, btn, btn-danger to make it red, btn-sm to make it small, and m-2 to add a bit of margin around this button and the increment button. Now let's type the label, delete, save the changes, back in the browser. Here's our delete button, beautiful. Now let's handle the click event. So here we want to add onClick and set it to a method in this class, like this, that handle delete. However, if you look at the state of this component, you can see in this state object, we only have the value property. But in order to delete a counter, we need to delete it from this array of counters that we have in the counters component. And this brings us to a very important rule of thumb in React applications. The component that owns a piece of the state should be the one modifying it. In this particular example, this piece of the state, that is the list of counters, is part of the counter's component. So modifying the state should be done by this component itself. Adding a new counter to this array or removing an existing one should be done inside of this component. Now, in the last lecture, you learned that the state is something private and internal to a component. It's not visible to the outside. So you might be wondering, how can we modify this state from the counter component? Because this is where we have placed our delete button. To solve this problem, we should modify our counter component to raise an event. We're going to call that event onDelete. So our components can raise events, and this is the naming convention we use to name those events. So the counter component will raise this event, and our counter's component will handle this event. In other words, we should implement the handleDelete method in the counter's component, not the counter component. This concept of raising and handling events is something that you see in a lot of libraries for building user interfaces. It's not specific to React. Now let me show you how to implement this concept in React. Basically, we need to add a new method to our counter's component and pass a reference to that method via props to the counter component. So here in the counter's component, let's add a new method, handleDelete. This is our event handler. Here, let's do a simple console.log event handler called. Now we want to pass a reference to this function using props to our child component, that is our counter component. So earlier we passed a couple of props here, value and ID. Now we can pass another prop. We're going to call that prop based on the name of our event. So the name of our event is onDelete. We're going to set this to this.handleDelete. So now that we're passing a reference to this function, to our child component, let's go to our child component and modify this onClick expression. So instead of referencing this.handleDelete, which does not exist in this component, we want to reference this.props.onDelete, because that's the name of our prop, right? Save the changes, back in the browser. Here with the React tab open, let's look at one of our counters, look at the props. Now we have a new prop, onDelete, which is a function. So let's go to the console tab, click this button, we get the message event handler clicked. So in this implementation, our counter component is raising an event and its parent, that is counter's component, is handling that event. This is a very common pattern that you see in a lot of real-world applications. And you're going to see several more examples of this throughout the course. But we are not done yet, because in our handleDelete method, we're simply doing a console.log. Here we need to update the state, and that's what we're going to do next. To update the state, we need to add a counter ID parameter here, so we know which counter we need to remove from this list. Now, to make sure that all the plumbing is going to work, before updating the state, first, let's just display counter ID on the console. Now we need to go back to our counter component. Here's our delete button. We need to change this expression and pass the ID of this counter. So as you have learned before, we pass an arrow function, and here we call onDelete with this.props.id. Now let's test this. So back in the browser, I'm going to delete the first counter. You can see the ID of that counter is 1. Beautiful. Let's try another one. That is counter with ID 2. Perfect. So now let's go ahead and update the state. Here in the counters component, as I told you before, in React, we do not update the state directly. In other words, we're not going to remove a counter from this array. Instead, we're going to create a new array without a given counter, and then call the setState method of our component and let React update the state. So here I'm going to define a new constant, call it counters. We're going to set this to this.state.counters. Use the filter method to get all the counters except the one with the given ID. So C goes to C.id does not equal counter ID. Now we have a new array. So let's call this.setState. Pass an object. We want to overwrite the counter's property with this counter's constant. Also, as I told you before, here, because the key and value are the same, we can simplify this code like this. Now, let's test this. So back in the browser, I'm going to delete the first counter, gone, another one, beautiful. So our implementation is working, but there is a tiny issue here that I would like to improve. If you look at the render method of this component, here we're passing 3 props to our child component. OnDelete, which is a function, as well as value and ID. Now, one question you might have is why do we have to pass ID and key while their values are exactly the same? This looks like unnecessary repetition. The reason for this is because this key attribute is used internally by React, so we won't be able to access it in our counter component. That's why we have to pass ID as a prop and then read it via this.props.id. Now, the tiny issue we have here is that we have passed value and ID as separate props. Both these are properties of the counter object. If in the future we add a new property to our counter object, we'll have to come back here and set a new prop, like selected. We set it to counter.selected. And over time, this is going to get messy and ugly. The whole point of using objects is to encapsulate related values. So instead of these 3 properties, we could simply pass the counter object itself. This object includes everything we need to know about a counter. And also, if in the future we add a new property to this counter object, we don't have to come back here and modify this code. Our counter object is carrying all the data about a counter. So with this change, now we need to go back to our counter component and make a couple more changes. Here on line 23, this is where we have our delete button. We need to change this expression. We no longer have the ID property in our props object, so we need to prefix this with counter. Similarly, on the top, where we initialize our state, again, we don't have the value property. We need to prefix it with counter. Save the changes. Let's test the application. So we can increment each counter, beautiful, and delete them. Perfect. We have an issue in our current implementation, and that is that we don't have a single source of truth. Let me show you this using an example. So here on the top, I want to add a button for resetting all the counters. So let's go back to our counters component. Here in the render method, on top of all these counters, let's add a button with a few classes: btn, btn-primary, btn-small, and margin2. And we're going to call this reset. Now, let's handle the click event. We're going to set this to this.handle reset, just like before. Nothing new so far. And here I'm going to implement handle reset. We set it to an arrow function. And in this method, just like our handle delete method, we want to create a new array of counters and call this.setState. So we get the existing counters, this.state.counters. We use the map method to get each counter and reset its value to 0 and then return it. So with this, we'll get a new array of counters. Let's store them here and then call this.setState with this new array. So save the changes back in the browser. Let's click the reset button. Look, nothing is happening here. Why is that? The reason is because we don't have a single source of truth. Let me show you what I mean. So I'm going to open up the Chrome Developer Tools. Let's go to the React tab. So here's our counters component. Look at the state for this component. We have an array of 4 counter objects. If you look at one of these counters, you can see its value is 0. So we successfully updated the state, but we are not seeing the changes in the DOM. Let's take a look at one of our counters. So expand this. Here's our first counter. Look at its props. We have this counter object that we passed from its parent. Look, the value is 0, but we don't see that on the view. Instead, we see 4. So the issue we're facing here is that we don't have a single source of truth. Each of our components have their own local state. Our counters component has an array of counters, and each counter component has a value. This value is currently disconnected from the value property of each counter object that we have in this array. Here's the implementation of our counter component. As you can see here, we're initializing the value property of our state object based on what we get from our props. This piece of code is executed only once when an instance of a counter component is created. So that's why when the page loads, we get the initial value here, and we can increment it because this is a local state in our counter component. But when we click the reset button, the local state of this counter component is not updated. So how can we fix this problem? We need to remove the local state in our counter component and have a single source of truth. And that's the topic for the next lecture. So here in the counter component, we want to remove the local state and only rely on the props to receive the data that this component needs. We refer to this kind of component as a controlled component. A controlled component doesn't have its own local state. It receives all the data via props and raises events whenever data needs to be changed. So this component is entirely controlled by its parent. So let's go ahead and do this refactoring. First, we're going to delete the state property. Next, we need to find any references to this.state and update them accordingly. The first reference is in our handle increment method. So since we no longer have the local state, it doesn't make sense to have this method here because this counter component is going to be a controlled component. So whenever the data needs to be modified, this component needs to raise an event and have its parent take care of modifying the data. So delete. Here's our increment button. Instead of referencing the handle increment method, which no longer exists, by calling a method in the props object, just like how we raised the onDelete event here. So let's get rid of this expression. We're going to pass an arrow function, and in the body of this function, we're going to call this.props.onIncrement. So that's the name of our event. Now, as an argument, we need to pass either the counter ID or a reference to this counter object. I'm going to pass a reference to the counter object because this will make the implementation of our event handler simpler, as you will see in a few seconds. So this.props.counter. We pass the entire counter object and let the event handler take care of incrementing the value of this counter. Now, let's find any more references to this.state. So we have 2 more references here that need to be modified. One is in getBatch classes. So here we need the value of the counter. We can read that from this.props.counter. Here's the last reference. So here we're using object destructuring to read the value property of the state. Since the state property is gone, we're going to read the value from this.props.counter. So we're done with the removing of the local state of the counter component. Here we no longer have a state property, and we're relying entirely on the props object to display data and notify changes. Now let's go back to our counters component. We need to add a new event handler, handle increment. We set this to a function that takes a counter parameter. For now, let's just do a console.log of counter, to make sure all the plumbing is working before we move on to update the state. Next, we need to go to our render method. So earlier we handled the onDelete event. Now we handle onIncrement, and we set this to this.handleIncrement. Let's test the application up to this point. So save and back in the browser. I'm going to increment our first counter. So we get that counter object here with the value 4. Beautiful. Now we need to update the state. Just like before, we are not going to update the state directly. Instead, we should create a new counters array and give it to the setState method and have React update the state. So let's create a new constant, call it counters. We set it to a new array. And here I'm going to use the spread operator to clone this.state.counters. So we're cloning this array. With this, we'll get a new array of counters. However, the objects in this new array are exactly the same objects that we have in the counters array that we have in the state object. Let me show you. So if we go to our new counters array, get the first counter and increment its value, this is going to directly modify the value property of this counter object that we have in the state. So let's do a console.log of this.state.counters of 0. Save the changes back in the browser. I'm going to increment our first counter. Now we can see its value is 5. So we have modified the state directly. And this is a no-no in React. To solve this problem, we need to clone the counter at the given location. So we'll have a different object than the one in the state. We don't have to clone the other counter objects here because we're not going to modify them. So we set counters of 0 to a new object. And once again, we use the spread operator to clone this counter object that we receive as an argument here. Let's test the application one more time. Back in the browser. Now, if I increment the first counter, you can see the value is not updated. So the counter object that we have in the state remains unchanged. Now here we are working with the first counter in this array. Instead, we need to find the index of the counter that we receive as a parameter. So let's define a new constant, index, and we set it to counters.indexOf. We pass our counter object, and finally we replace all these zeros with index. And the last piece is to update the state. So we call this.setState and give it this new counters array. Let's test the application. Back in the browser, I'm going to increment the first counter. Beautiful. Let's delete some of these and click to reset. Perfect. Now let's take this application to the next level. I want to add a navigation bar here on the top, and there I want to display the total number of counters on this page. You have seen this pattern before. It's similar to displaying the total number of products in a shopping cart. So as we add products to our shopping cart, we can see the total number gets updated on the navigation bar. So let's go ahead and implement this pattern. Back in VS Code, let's go to index.js. You can see our root component is the counters component. So here's a visualization of our component tree. We have the counters component on the top, and below that we have the counter component. Now we need to change this structure to something like this. So we want to have the app component on the top. Below that, we want to have a navigation bar and our counters component. So back in index.js, on the top, I'm going to bring back the app component and replace this counters component with app component. Now let's go to app component. So app.js. What we have here in the render method is the default black banner that comes with React projects. We want to replace this with a basic Bootstrap template. I showed you how to do this in the last section when we set up the Vidly project. But let me quickly refresh your memory. So we go to getbootstrap.com. Under examples, if you scroll down, you can see various templates. I'm going to pick a very simple starter template. So we want to have a page like this. Now right click here, go to view page source. Under body, you can see we have a navigation bar, and next to the navigation bar, we have this main element with the class container. This is the container for the content area of our application. Now we don't want a complex navigation bar like this. So let's go back here, go to documentation and search for nav bar. On this page, if you scroll down, you can see a very simple navigation bar under brand. So this is the layout that I'm looking for. I don't want any links or drop-down lists here, just a simple navigation bar. So here's the markup. I'm going to copy this. Now back in VS Code, we should create a new component for our navigation bar. So a new file. Let's save this under the components folder and call it navbar.jsx. Now, just like before, imrc on the top and then cc navbar. Here in the render method, we simply return the markup that we copied from Bootstrap. We just need to rename class to class name and we're done. Also, we don't need the state here, so let's delete it. So here's our navigation bar component. Now let's go back to app.js. We don't need this markup anymore. Instead, we want to render our navigation bar. So on the top, we also don't need the logo. Let's import navbar from the components folder /navbar. And then here we add our navbar component. Now below that, we should add our main element with the class container. And inside this element, we're going to add our counters. I'm going to go back to index.js. On the top, you can see the line for importing the counters is grayed out because we are not using the counters component here. So let's cut this from here and paste it in app.js. And finally, let's add the counters element inside the main element. Now you can see here we have a compilation error because of this red underline, because we're returning multiple root elements from the render method. So we need to wrap them with a react.fragment. So react.fragment, and then we close it here. Okay, beautiful. Back in the browser. So here's our new layout. We have the navigation bar on the top, and below that we have our counters. Now, we want to display the number of counters on the navigation bar. Here's our component tree one more time. Earlier, we passed the state of the counters component to the counter component via props. This is because we have a parent-child relationship between these two components. But as you can see, there is no parent-child relationship between the counters component and the navbar component. So how can we display the total number of counters on our navigation bar? Well, in situations like that, when there is no parent-child relationship between two components and you want to keep them in sync, you want to share data between them, you need to lift the state up. So in this case, we want to lift the state of the counters component to its parent, that is our app component. Now, both the counters and navbar components have the same parent. This is where we have the state, so we can pass it to all the children using props. And that's what we're going to do next. So here in counters component, this is where we have the state, the list of counters, as well as the methods that modify or mutate the state, such as handle increment, handle reset, and handle delete. We should move the state as well as all the methods that modify the state from this component to its parent, that is app component. So I'm going to select all this code here, cut it, go back to app component, and paste it right here. That was the first step. Now, back in counters component, here we have a reference to this.handle reset. But this method no longer exists in this class. Now it's part of its parent. So we need to pass it down using props. So back in app component, let's look at the render method. This is where we have our counters component. We want to modify this to raise events such as onReset, onDelete, and onIncrement. So onReset, we set this to this.handle reset. OnIncrement, we set this to this.handle increment. And onDelete, which we set to this.handle delete. So these are the three events that are raised by this component, and here are the corresponding handlers that belong to the app component. Now let's go back to counters component. So we should change this expression to this.props.onReset, because that's the name of the property that we set on the prop object. So one more time, here in app component, these are the properties of the prop object, right? Now, one more time, back in counters component, we should also update the reference to handle delete and handle increment. So one more time, this.props.onDelete and this.props.onIncrement. Basically, what is happening here is that this counter component raises the delete event, and here we're bubbling that event to our parent. So we're not handling that event in this component, we're simply bubbling it up to the parent of this component. And one last change we need to make here, since we no longer have the state in this component, we need to pass the list of counters via props. So we should change this to this.props.counters. And also, back in app component, we should pass the list of counters right here. We set this to this.state.counters. So now this counters component is a controlled component because it doesn't have any state. It simply receives data and methods to modify the data via props. So it's entirely controlled by its parent. So this is how we lift the state. Now let's test the application and make sure everything is working. So let's increment a couple of these, then reset them, delete a couple of them. Beautiful. Finally, we need to display the total number of counters here on the navigation bar. So here in app component, we're passing our counters to our counters component. Similarly, we can pass this array to our navigation bar component. So we can pass either the counters array or just the total number of counters. So the nav bar itself doesn't have to do the calculations. We can simply give it a number. So total counters, we set it to this.state.counters.length. Or we could take this to the next level and filter only the counters with value greater than 0. So we get counters, filter them where counter.value is greater than 0, and then we'll get the total number of those counters. So save the changes. Now let's go to navbar component. This is where we have the label. Right after that, I want to add a span with a few classes like badge, badge-pill, and badge-secondary. Here we render this.props.total_counters like this. Save the changes and back into browser. So currently we have only one counter with value greater than 0. Let's increment the second counter. Now the value is updated to 2. If we delete the first counter, the total number of counters is updated accordingly. So we lifted up the state from the counters component to its parent, which is the app component. Now we can share this state with the children of this component via props. And with this technique, we have multiple components in sync. So if you look at our navbar component, we only have a single method here. That's the render method. We don't have any event handlers here. We don't have any helper methods to calculate values. We only have a single render method. Also, we don't have any state. We're getting all the data via props. In situations like this, we can convert this component into what we call a stateless functional component. So instead of using a class to define this component, we can use a function. Let me show you how to do this. So we define a constant, call it navbar, and set it to an arrow function like this. In the body of this arrow function, we return a React element. So basically, we take our return statement from here and move it inside of this function. So instead of having a class that extends the component class with a render method, we simply define a function that returns a React element. That's why we call this a stateless functional component. Now, there is nothing wrong with using classes to define components, but some developers prefer to use functions when they're dealing with simple stateless components. What approach you choose is purely your personal preference, but you see a lot of examples of stateless functional components on the internet. That's why I decided to include this in the course. Now, we also have a shortcut for creating these stateless functional components, just like we have CC for creating a class component. We have SFC for creating a stateless functional component. So this gives us a template for defining a function and also exporting it. Now, we don't need this, so delete. Now, one more thing before we finish this. Here we're referencing this.props. This only works in class components. In functional components, you need to add props as a parameter here, and then remove this. React will pass the props object as an argument to this function at runtime. Here in our navbar component, we have a single reference to the props object. Sometimes when working with a more complex markup, we might have multiple references to the props. We don't want to repeat props.props.props. several times. So we can use object destructuring to destructure this props argument. In this particular example, we are interested in the total counters property of this object. So we can destructure this argument and pick the total counters property. First, we add parentheses, then we use curly braces for object destructuring, and then pick the properties we're interested in, like total counters. With this, we can remove props dot, and this simplifies our code. Similarly, if you look at the counters component, you can see here we have several references to this.props. We can simplify this code by using object destructuring. So here in the render method, just before the return statement, I'm going to define a constant, use object destructuring to pick the properties of the props object we're interested in. The first one is on reset, so we pick that. The second one is counters. Let's add that here. We also need on delete and on increment. So on delete and on increment, we pick all of these from this.props. Now, anywhere we have this.props dot, we can replace all of those with nothing. And this makes our code cleaner. Our components go through a few phases during their life cycle. The first phase is the mounting phase, and this is when an instance of a component is created and inserted into the DOM. There are a few special methods that we can add to our components, and React will automatically call these methods. We refer to these methods as lifecycle hooks. So they allow us to hook into certain moments during the lifecycle of a component and do something. In the mounting phase, we have 3 lifecycle hooks: constructor, render, and component did mount. React will call these methods in order. The second lifecycle phase is the update phase, and this happens when the state or the props of a component get changed. In this phase, we have two lifecycle hooks, render and component did update. So whenever we change the state of a component or give it new props, these two methods are called in order. And the last phase is the unmounting phase, and this is when a component is removed from the DOM, such as when we delete a counter. These lifecycle hooks you see here are the frequently used ones. If you look at the React documentation, you will see a few more lifecycle hooks, but they are rarely used, and that's why I didn't want to confuse you with too much details that you're not going to use that often. 90% of the time, you're going to use only the lifecycle hooks that I've listed here. Now, let's see these lifecycle hooks in action. So here in the app class, first, let's look at the mounting phase. I'm going to add a constructor. And because we have added a constructor here, we need to call the constructor of the parent class using super. So here we have a constructor. Let's do a simple console.log app constructor. This constructor, as you have learned before, is called only once when an instance of a class is created. This is a great opportunity for initializing the properties in that instance. For example, one common use case is to set the state based on the props that we receive from the outside. For example, we can set this.state to this.props.something. So here in the constructor, we set the state directly. We don't call this.setState. In fact, if we do that, we will get an error because this method can only be called when a component is rendered and placed in the DOM. So if you need to set the state directly, you can do so in constructor. Also note that here, we won't have access to this.props unless we pass props as a parameter to this constructor and also pass it to the constructor of the base class. Otherwise, this.props will return undefined. Let me show you. So temporarily, I'm going to comment out this line and log this.props here. Here in the console, you can see our constructor is called and our props object is an empty object. But if you forget to add the props to this constructor, we won't be able to access it. So to recap, the constructor is called once and it's the right place to initialize the properties in this class. Now let's remove this.props from here. The second lifecycle hooks we're going to look at is component did mount. Component did mount. This method is called after our component is rendered into the DOM, and it's the perfect place to make AJAX calls to get data from the server. So we can do an AJAX call and then call the set state with new data. For example, in our video application, later in the future, we're going to get the list of movies from the server and then pass that list to our set state method, something like this. For now, we don't have to worry about this. Let's do a simple console.log app mounted. And the third lifecycle hook in the mounting phase we're going to look at is the render method, which we have seen before. Let's just add a console.log app rendered. Now, back in the console, look at the order in which these methods are called. First, we have the constructor, then the component is rendered, which basically returns a React element that represents our virtual DOM. Now React gets that virtual DOM and render it in the actual browser DOM. And then our component is mounted. So when a component is mounted, that means that component is in the DOM. And once again, this is the right place to make AJAX calls and get the data from the server. Now, one thing you need to know about the rendered method is that when a component is rendered, all its children are also rendered recursively. Let me show you. So here in our app component, look at our render method. Here we have a navbar and a counters component. So let's go to our navbar component. Here we have a stateless functional component. In the body of this function, before our return statement, let's do a console.log and display navbar rendered. Now, one thing you need to notice here is that you cannot use lifecycle hooks in stateless functional components, because here we have a single function that returns the output of this component. So if you need to use lifecycle hooks, you can only use class components. Now, let's go to our counters component. Once again, here in the render method, I want to add a console.log with a message like counters rendered. And the last part, let's go to our counter component. Do the same here in the render method and change the message to counter rendered. Now let's go back to the console. As you can see, first the constructor of our app component is called, and then our app component and all its children are rendered recursively. So we have app, navbar, counters, and 4 instances of the counter component. And finally, at this point, our app is mounted and is in the DOM. So this is our mounting phase. Now let's look at the update phase. So that phase happens whenever the state or props of a component changes. As an example, let's look at our increment button. So let's go back to our app component. Here's our handle increment event handler. In this method, we're updating the state of app component. So this will schedule a call to the render method. So our app is going to be rendered, which means all its children are going to be rendered as well. Let's see this in action. So back in the console, I'm going to clear the console and click the increment button. So once again, you can see our entire component tree is rendered. Now I just need to clarify that when I say our entire component tree is rendered, that doesn't mean that the entire DOM is updated. When a component is rendered, we basically get a React element. So that is updating our virtual DOM. React will then look at the virtual DOM. It also has a copy of the old virtual DOM. That's why we should not update the state directly, so we can have 2 different object references in memory. We have the old virtual DOM as well as the new virtual DOM. Then React will figure out what is changed, and based on that, it will update the real DOM accordingly. So here, even though we have several counters, when I click the increment button, only this span is updated. Nothing else will be affected. Let me show you. So if I go to the Elements tab and select this element here, I'm going to click the increment button, and I want you to look at the span here. So increment, see, it gets highlighted because its content is updated. However, if I select another counter and click the increment button of the first counter, look, nothing is happening here. So there is no update on this part of the DOM. Now back in our counter component, I'm going to add another lifecycle hook here. Component did update. This method is called after a component is updated, which means we have new state or new props. So we can compare this new state with the old state or the new props with the old props. And if there is a change, we can make an AJAX request to get new data from the server. If there are no changes, perhaps we don't want to make an additional AJAX request. This is an optimization technique. So let me show you. Here we add a couple parameters, previous props and previous state. Let's do a console.log of previous props, as well as another console.log to show the previous state. Previous state. Now save the changes back in the console. I'm going to clear the console and click the increment button of the first counter. Note that the value is currently 4. So click, look at the console. So ignore all the rendered messages. Look at the first previous props. So this is the props object that we're passing to this counter component. You can see the value of the counter was previously 4, but now it's 5. So we can write code like this. If previous props.counter.value is different from this.props.counter.value, then perhaps we're going to do an AJAX call and get new data from the server. However, if the value is not changed, perhaps we don't want to make an additional call to the server. Of course, this does not make sense in the context of our counter example, but what I want you to take away here is that with this method, component.didUpdate, we can decide whether we should make an AJAX call to get new data based on the changes in props and state objects. Now finally, let's look at the onMount phase. So in this phase, we have one lifecycle hook that is component will onMount. So this method is called just before a component is removed from the DOM. Let's do a console.log of counter onMount. Now back in the browser, I'm going to clear the console again. Now note that when I delete this first counter, we will see the onMount message on the console. See what's going on here. As a result of deleting a counter, the state of app component is changed. So our entire component tree is re-rendered. We have app, navbar, counters, as well as 3 counter components. So with this, we have a new virtual DOM that has one less counter. React will compare this virtual DOM with the old one. It figures out that one of our counters is removed. So then it will call component will onMount before removing this counter from the DOM. And this gives us an opportunity to do any kind of cleanup. So if we have set up timers or listeners, we can clean those up before this component is removed from the DOM. Otherwise, we'll end up with memory leaks. So we have covered a lot about components. Now it's time for an exercise. I want you to extend this counter application and add a new button here for decrementing the value of a counter. Note that if the value is 0, this button is disabled. So if I increment it now, it becomes 1. Now the decrement button is enabled. If I click it, the value is 0 and the button is disabled. Also, we can see that I have changed the label of this button. So we no longer have the increment label. Instead, we have the plus sign. And also, to make this layout nice and clean, I have used Bootstrap grids. So here we have a grid with 2 columns. In the first column, we have our counter, and in the second column, we have our buttons. That's why all these buttons are aligned no matter how big our badge is. So go ahead and spend 10 minutes on this exercise. When you're done, come back, continue watching. All right, so here in our counter component, this is where we have the increment button. First, I'm going to change this label to a plus sign, and then I'm going to duplicate this and change the plus to minus. Now here in the onClick expression, we need to raise a different event that is onDecrement. So we need to go to our counters component and pass onDecrement via props. So let's go here. This is counters component. We're passing onIncrement. We should also pass onDecrement. Now, as I told you before, this component itself does not handle events. It simply bubbles them up to its parent, which is the app component. So here we simply pass a reference to this.props.onDecrement. And finally, we go to app component. Here we have handle increment. Handle decrement is pretty similar. So I'm going to duplicate this and then rename it to handle decrement. Now, instead of increasing the value, we're going to decrease it. And finally, we need to go to our render method. So this is where we're passing handle increment. We need to pass handle decrement as well. This.handle decrement. So conceptually, our counters component is raising an event called onDecrement, and our app component is handling that event using this event handler. This is the actual concept. The implementation in React is using props to pass function references. Okay, now let's test the application up to this point. So here Don't worry about the ugly layout. Let's just make sure this new button works. Click, click, beautiful. Now let's clean up the layout. So we go to our counter component. I'm going to apply a class to this div. So class name, we set this to row. In case you haven't seen this class before, this is one of the Bootstrap classes for implementing grid layouts. The explanation of that is beyond the scope of this course, and that's something you need to learn by looking at the Bootstrap documentation. So in this row, we're going to have two columns. I'm going to add two divs. The first div with the class call-1, that's a small column. And next to that, I'm going to add another div with the class call, which takes the rest of the page. So tab, now we have two divs. In the first div with call1, I'm going to put our span or badge. And in the second div, which takes the rest of the space, I'm going to add our buttons. So let's grab all these buttons, cut them, and put them right here. Now, back in the browser, you can see our buttons are lined up, beautiful. We just need a bit of margin between these two buttons. So here's our decrement button. I'm going to add another class here, m-2, save the changes, back in the browser, that looks better. With this, we no longer need to apply margin on the delete button because as you can see, there is a bit of extra space here. So back in the code, here's our delete button. I'm going to delete the m2 class here. So we'll only have m2 on the decrement button, and this will add a margin to the left and to the right side of this button. Save the changes. One final look. Beautiful. Now the last thing we need to implement is to make sure that if the value is 0, this button is disabled. So here's our decrement button. We want to apply an attribute dynamically. So if I apply disabled here, this button will always be disabled. Now I want to apply this attribute dynamically based on a condition. So back in the code, we set this to an expression. If this .props.counter.value equals 0, we're going to set this to the text disabled. Otherwise, we're going to set this to an empty string. Now you can see if the value of the counter is 0, the decrement button is disabled. Let's increment this. Now it's enabled. Let's decrement it. Now it's disabled. Beautiful. Here's another exercise. Back to our Vidly application, I want you to build a reusable like component like this. So currently I have used this component in our list of movies, but potentially we can reuse this component somewhere else in this application, or maybe in an entirely different application. Maybe we can use this in the list of tweets or Facebook posts. So I want you to sit down for a minute and think about the interface of this component. What input should it receive? What events should it raise? These inputs and events define the interface of this component. So write it down on a piece of paper and then think about implementing that component in React. Think about the props object. What properties are we going to have in that object? Now, as a hint, in order to render this icon, you need to use font awesome. The version we're currently using in this project is 4.7.0, but there is a newer version available that is a bit different from the one we are using. So I want you to search for font awesome 4.7. Look at the documentation here, go to the icons. Here you can search for icons. So search for heart. You can see we have different kinds of heart. We have a full heart and an empty heart. Let's take a look here. So this is the markup that you need to render in order to get an empty heart. So go ahead and spend 15 minutes on this exercise. You will see my solution next. All right, so here in the components folder, first I want to add a new folder, call it common. This is where we'll add all the reusable components that are not specific to the domain of the Vidly application, such as like components, pagination, tables, forms, and so on. So in the common folder, let's add a new file. like.jsx, imrc, and cc, we're going to call it like. Now, what is the interface of this component? As the input, we should tell this component whether the given entity, like a movie, is liked or not. So here we need an input property called liked, which is basically a boolean. It can be a true or false. What is the output of this component? What are the events that this component is going to raise? Whenever we click this heart icon, we want this component to raise an onClick event. So whoever is using this component will then be notified, and then they will take care of toggling the like property of a given object and saving the changes in the database. So this component itself knows absolutely nothing about movies. It's just a simple dumb component that is responsible for rendering an empty or a full heart. It's up to the consumer of this component to tell it what kind of heart we want it to render. So let's go ahead and implement this. For now, we don't need the state, so I'm going to delete this. Now back in the Font Awesome documentation, I'm going to copy this markup here and simply paste it in front of our return keyword. First, I want to make sure that the basic plumbing is going to work. I don't care about clicks and full or empty hearts. I just want to make sure that we get a heart icon in front of each movie. So we have a very basic like component. Now let's go to our movies component. I'm going to add a new column here. So in the table heading, this is our delete column. I'm going to duplicate this. And then in the table body, just before the delete button, I'm going to add another TD. And this is where we're going to render our like component. We need to import this on the top. So import like from common/like. Let's test the application up to this point. So we have an empty heart in front of each movie. Beautiful. This is how I want you to write code, step by step. Don't make big moves. Just write a little bit of code, test it, make sure it works, and then go ahead to the next step. Now we want to work on the input of this component. So depending on the input, this component should render a full or an empty heart. So back in our movies component, here is our like component. Let's pass an input property, liked. For now, I just want to set it temporarily to true. I want to hard code this value. Now back in our light component, the difference between an empty and a full heart is only this postfix here. So we can change this code like this. Let's declare a variable, classes. We set it to FA and FA-heart. This is the base. Now, we look at our props. If this.props.liked is false, we're going to append this postfix-o to these classes. So classes plus equal -o. Now we render the classes dynamically. So we set this to classes. And by the way, I just copied this code from Font Awesome documentation. Here we need to rename this attribute to class name. Save the changes. So now the input to this component works. Beautiful. Let's make this dynamic. So back in our movies component, instead of hard coding true here, I want to set this to movie.liked. So in a real world application, when we get the list of movies from the server, each movie object should also have a property called liked, and that determines if the current user has liked that movie or not. If the user is not authenticated, that property would be false or null or undefined, whatever. It's not going to be true. Now, to make sure that this works, I'm going to go to our fake movie service. So this is where we're getting the list of movies from our imaginary server. Here in the first movie object, I'm going to add the liked property and set it to true. With this change, when we go back to the browser, our first movie should be liked. Now, back here, you can see this is liked, the others are not. Beautiful. Now, the next thing we want to work on is the click event of this like component. I just want to click it and make sure we get a message in the console. We don't care about changing the state. So back in our movies component, here's our like component. this component should raise an onClick event that we need to handle. So onClick, we're going to set this to this.handleLike. Let's go ahead and create this method. So up here, we should put all our event handlers in one place. handleLike. For now, I just set it to a very simple function without any parameters. In the future, we'll decide what parameter we need to pass here. Let's just do a basic console.log like clicked, just to make sure all the plumbing is working. Now, back to our like component, we should handle the onClick event of this DOM element and raise a custom event, which also happens to be called onClick. But these two events are different. So when I add onClick here, we're responding to the click event of DOM elements. But when I set this to this.props.onClick, we are raising another custom event called onClick. We could call this onLike toggle. Doesn't matter. In this case, the DOM event as well as our custom event happen to have the same name. So now our like component is raising an onClick event. Let's test this. Back in the browser, let's open up the console and click this icon. Beautiful, we got this message here. Now you can see our mouse pointer doesn't look like a hand. We can fix this by applying a class or a simple inline style. In this case, because we're dealing with only a single CSS attribute, I would prefer to use an inline style, but if you prefer a class, that's perfectly fine. So we set the style attribute to an expression. We pass a style object. Here we'll have cursor set to a string pointer. Like this. Now, back in the browser, you can see we have this beautiful hand icon. So now that our plumbing is working, we're successfully raising an event from this component and handling it in our movies component. We need to work on changing the state. So back in our movies component, here in handleLike, we need to know what movie is being liked or disliked. So this event handler should receive a movie parameter. Now let's go back to where we have used this to make sure we pass this movie argument. Scroll down. Here's our like component. onClick. Here we need to pass an arrow function. We're going to call this.handleLike, and as an argument, we're going to pass this movie object that we are rendering. So we pass the movie object here. Once again, I'm going to go back to this method and log this movie object on the console before changing any state. I want to make sure we're getting the right movie in that event handler. So here's our event handler. Let's pass this movie right here. Save the changes, back in the console. The first movie is Terminator, so when I click this, we get Terminator, beautiful. The second movie is Die Hard. Let's test that too. We get Die Hard, perfect. Now we are ready to change the state. So here, just like before, we don't want to change the state directly. We want to take a copy and give the new state to the setState method of our component. So first, I'm going to declare a constant movies and clone this.state.movies. Now here we have an array of objects, so we don't want to modify one of those objects directly. We want to clone that object. So in this array, first we need to find the index of that object. That's it. Store it in this constant. Now we go to movies of index and set this to a new object. And here we simply use the spread operator to clone this object. So we copy all the properties here. Now we're going to change movies of index dot liked. We simply toggle it. So we set it to the not operator of movies of index dot liked. So if it's true, it becomes false. Otherwise, it becomes true. And finally, we call this that set state and pass the new movies array. Let's test the application. So let's dislike Terminator. It's gone. Let's like it again. It's back. Beautiful. application is working. Now, later in the future, when we talk about calling HTTP services, this is where we're going to call the server to persist the changes. So all the code we have written here is purely for updating the UI, for updating the view. But we should also call our backend to make sure that the changes are persisted in a database. Now, one last thing before we finish this lecture. Back in our like component, you can see this component is a controlled component because it receives all the data it needs via props, and it notifies any changes to the data, again, by using props. So it doesn't have any state itself. And here we don't have any helper methods, any event handlers. We only have a render method. So we can turn this component into a stateless functional component and simplify this code. So let's delete these comments. SFC, short for stateless functional component, tab. We're going to call it like. And then we don't need this export because we already have one right here. So let's delete this. And finally, I'm going to move the content of the render method into this new function. So I'm going to hold down Alt and press the up arrow to move this code. And then we delete this return keyword. So now we have a stateless functional component. It's a little bit simpler than a class that extends the component. So let's delete this and we're done. Just remember, when you convert a class to a functional component, you should get rid of all the references to this. So I'm going to select both these references, delete them, and then pass props as a parameter to this function. In this section, we're going to take our Vilda application to the next level and add pagination, filtering, and sorting. Let me show you what we're going to build. So we're going to add this list of genres on the left side. When we select a genre, we'll only see the movies in that genre. Note that here we have a message on the top that gets updated depending on the number of movies in this table. So currently we have 3 movies. If I delete a movie, now we have 2 movies in this genre. Now back to all genres, you can see we have a total of 8 movies. Below this table, we have pagination, and we can also sort this data by different columns. So these are the features we're going to add to this application in this section. I should say, out of all sections in this course, this section is my absolute favorite because it's packed with lots of techniques for writing clean code, for refactoring, and best practices. Are you ready? We're going to take a different approach to start this section. Instead of me talking about a bunch of topics and then give you an exercise, we're going to start with an exercise. So I want you to spend 15 to 20 minutes and build this pagination component. So start by thinking about the interface of this component. What data does this component need? What are the events it's going to raise? Think about these and then start implementing this component. Now, in terms of the UI, this is a Bootstrap pagination component. So on Bootstrap documentation, if you search for pagination, you can see a basic pagination component. Don't worry about the previous and next buttons. Just focus on the page numbers. So this is the markup that you need to return from your pagination component. So go ahead, build this. When you're done, come back and see my solution. All right, let's start by building a pagination component. Now, similar to the like component that we built in the last section, we want this component to be completely decoupled from movies so we can reuse it in multiple places. So here in the common folder, let's add a new file, pagination.jsx. Now this time I'm going to start with a stateless functional component because based on the experience, I have this feeling here we're not going to have any local state and we can pass all the data that this component needs via props. So on the top, imr to import React and then sfc to create the component. Let's call it pagination and pass props here. For now, I don't want to return anything, so let's return null. We'll come back to this shortly. Now, whenever you want to build a reusable component, before implementing that, you should think about the interface of that component. What are the inputs that component is going to receive? What are the events it's going to raise? The best way to decide the interface of a component is to use it before implementing it. So let's go to our movies component. This is where we're going to use our new pagination component. So on the top, let's import it. Import pagination from common/pagination module. Now down the bottom, here in the render method, after our table of movies, this is where we're going to use the pagination component. Now let's see what inputs we need to give to this component. I believe at a minimum, we need to give this component the total number of items as well as the page size. Based on this information, this component can calculate the number of pages and render them. So items count, we set this to this, that state, that movies, that length. But actually earlier, we used object destructuring in this method. We extracted the length property and renamed it to count. So let's simplify this expression to count. We should also pass page size. We can hardcode a value here, but as you will find out shortly, we're going to use this value in multiple places, so it's better to store it in the state. So we set this to this, that state, that page size. Now on the top, let's initialize this property. So here's the state. Let's add page size and set it to 4. So with 4 movies on each page, I want to make sure our pagination renders 3 pages. So these are the inputs of this component, but this component should also raise an event whenever the user clicks on a new page. We can call that event onPageChange and set it to a method like this that handle page change. Now let's implement this method. So here, this is where we're implementing all our event handlers. Let's add handle page change. This method should receive the new page number. So page goes to, for now, let's just do a console.log of page. All right, back to our pagination component. So we have determined the interface for this component. Next, we'll implement this component. To render a pagination, we're going to use Bootstrap. So here on Bootstrap documentation, if you search for pagination, you will find this component. And this gives you this kind of layout. Beautiful. Now here's the markup we need to use in order to render a pagination like this. So we need a nav. Below that, we need a UL with the pagination class and a bunch of list items. Each item should have a page item class and an anchor with page link class. So let's go ahead and add this to our pagination component. So here, instead of returning null, we're going to return a nav. Inside that, we're going to have a UL with the pagination class. Inside that, we're going to have an LI with page-item class. And inside the LI, we're going to have an anchor with page-link class. Now here we don't need href. Instead, we're going to handle the onClick event of this anchor. We'll come back to this shortly. So let's delete this. For now, let's just add a page number here like 1. Save the changes back in the browser. Let's make sure our pagination is rendered. Beautiful. So we've got 1 page here. Now we need to render this dynamically based on the number of items and the page size. So here we need to have an array of page numbers like this, 1, 2, 3, whatever. And then we'll use the map method to map each page number to a list item like this. Now, how do we create this array? Well, in props, we have a couple of properties. One is items count and the other is page size. These are part of the interface of this component, right? So we set these to props. Now with these values, we can calculate the number of pages like this. Const pages count, we set this to items count divided by page size. So we have the pages count, which can be 2 or 3 or whatever. Now based on that, we need to create an array. with numbers ranging from 1 all the way up to pages count. How do we do this? There are different ways. One simple way is to use Lodash, which is a popular JavaScript library with a bunch of utility functions. So let's open up the terminal by pressing Ctrl and backtick. Here we install Lodash version 4.17.10. Make sure to install the exact same version so there are no surprises as you're watching this course. All right, Lodash is installed. Now, here on the top, import underline from Lodash. We could call this Lodash or L or whatever, but underline or underscore is a common convention because Lodash is the optimized version of a popular JavaScript library called underscore. So that aside, now here we need to use Lodash to generate an array with these numbers. So we call underscore.range. Our starting number is 1 and our end number is pages count plus 1. We have to add plus 1 here because this method will not include this end number itself. So if pages count is 4, it will return an array with 3 numbers, 1, 2, 3. That's why we need to add 1 to it to make sure the last page is also included. So this will return an array. We can call that pages. Now we're going to map the items in this array to list items. So pages.map, we get each page and map it to a list item like this. Now finally, we need to render the page number dynamically. So that is page. Let's test the application up to this point. The first error we get is each child in an array or iterator should have a unique key. Obviously, we forgot that. So because we're using the map method here, we should give each li a key. So we're going to use the page number because that uniquely identifies each page. Save the changes, back in the browser, no errors, beautiful. So with total of 9 movies and 4 movies on each page, we should get 3 pages. Beautiful. Now let's take a look at an edge case. Back in the movies component, I'm going to set the page size to 10. Save the changes. So we have 9 movies and 10 items on each page. We get only 1 page. In this case, I don't want to render just this number 1 because it's confusing. So if we have only a single page, we don't want to render anything. So here in the pagination component, if pages count equals 1, we want to return null. So nothing will be rendered. Let's test this back in the browser. But we still have 1 here. What's going on? Well, back in the pagination component, let's do a console.log of pages count. Let's see what we get here. As you can see, our page count is 0.9. And that's why we still have the first page displayed here. So if the result of this division is a floating point number, we want to convert it to an integer. To do that, we're going to use math.ceil method. This will return the smallest integer greater than or equal to this floating point number. Now save the changes. Let's test this one more time. Okay, you can see the result of our division is 1. So we have only 1 page, and that's why our pagination is no longer rendered. So we can get rid of this console.log. We're done with rendering the pages. Now we could also add a previous and next buttons here. For now, I don't want to worry about this. Potentially you can do this as an exercise in the future. Next, we're going to work on raising an event when the user clicks on a new page. Now, before we get started, let's revert this 10 back to this .state .page size. So here in the movies component, currently we're handling the onPage change event of the pagination component. Here in this event handler, we're simply logging the current page on the console, but nowhere in the pagination component we are raising this event. So back in the pagination component, here we have an anchor Whenever the user clicks on this anchor, we should raise the onPageChange event. So onClick, we set this to a function, an arrow function, and in the body we call props.onPageChange and pass the current page as an argument. That is this page that we have in our map method. Let's test the application. So here I've got the console open on the right side. As we click on different pages, you can see the current page is displayed on the console. Beautiful. Now back in the pagination component, earlier we used object destructuring, so it's better to use the same approach here, so our code will be clean and consistent. Let's remove props dot and extract onPageChange from the props object on the top. That's better. Now, as we click on different pages, we want to highlight the current page. To achieve this, we need to apply the active class on this list item conditionally. So, if this page that we're rendering equals the current page, we want to add the active class. That means in this component, we need to know the current page. So we should extend the interface of this component and also give it the current page. And this makes perfect sense because sometimes the user may select a given page, navigate away, and then come back. So we want to initialize this pagination component to a different page, not page 1. So here in the props, we should also have current page. And that means we need to go back to our movies component and pass the current page as a prop. So current page, we set this to this.state.current page. So as you can see in the state of this movies component, we're keeping track of parameters like page size, current page, potentially current filter, current sort column, and so on. So let's go on the top and initialize the current page. Here in the state, I'm going to set current page to 1. Now, back in our render method, we can use object destructuring to clean up our code. So constant page size and current page, we're going to extract these from this.state. Now, back here, we can get rid of this dot expressions. Save the changes. Beautiful. All right, next we need to go to our event handler, and whenever the page is changed, we need to update the state. So let me give you a shortcut. On Mac, you can press Command and P. On Windows, Control P. Here, if you type an @ you can look at the members of this class. We want to jump to handle page change. Here we are. So we get the new page, and we call this .setState. We set the current page property to this page. Now, to make sure that all this plumbing is working, I'm going to go back to pagination component. On the top, let's do a console.log of current page. I want to make sure that this pagination component is receiving the current page. So initially, current page is 1, beautiful. Now let's go to page 2. We get that here. Page 3, perfect. So just to clarify, whenever we click on a new page, this event is raised. So we go back to our movies component. Here we handle that event. We update the state. As you learned before, whenever the state of a component is changed, that component and all its children are re-rendered. So the render method is called. Now down the bottom of this method here, we have the pagination component. So the pagination component is re-rendered with new props. So it will receive the new page. All right, the last step for this lecture is to apply the active class to the current page dynamically. So here in the pagination component, I'm going to change this line where we have this list item. Instead of hard coding the page item class, I'm going to pass an expression here. So if this page that we are rendering equals current page, we're going to return page-item plus the active class. Otherwise, we'll only return page-item. As simple as that. Let's save the changes and test the application. So initially, you can see the first page is selected. Let's go to page 2, page 3, page 1. Beautiful. Next, we'll implement the pagination. All right, now that we have built different pieces, we are ready to paginate the data. So currently in handle page change method, we update the state, we set the current page. As you know, this will cause a new rendering. Here in the render method, currently we are rendering the movies that we have in the state object. Now, this is our original list of movies. We don't want to change this list. As we paginate the movies or search for them or filter them, we want to create a separate array. That is the array that we're going to render here. So here's one solution. Here in the render method, we have the page size and the current page. Based on these values, we can paginate the data. So here, if count is not 0, we're going to create a new array. We're going to call that movies, and somehow we're going to paginate the data, get a new array, and store it in this constant. So how do we do this? Well, the pagination algorithm is something that we probably need to use in different places in this application or even in different applications. So we don't want to implement that algorithm here. Firstly, it will bloat this render method. Secondly, we won't be able to reuse it. So here in the project folder, under the source folder, I'm going to add a new folder. Let's call that utils. Here we're going to have all sorts of utility classes and functions. Let's add a new file here. Call it paginate.js. In this module, I'm going to import Lodash because Lodash has a bunch of utility methods that we can use to implement pagination. So implement underscore from Lodash. Now here we're going to export a function. Call it paginate. What parameters do we need here? We need an array of items as well as the page number and page size. Now to paginate the data, first we need to calculate the starting index of the items on this page. And here's the formula for that. We define a constant, call it start index, and set it to page number minus 1 times page size. Now we can use Lodash to go to this start index and take all the items for the current page. So here in Lodash, we have the slice method. We pass our items array here and give it the start index. So this method will slice our array starting from this index. Now that we have a new array, we can go to this array and pick items for the current page. Once again, Lodash has a method for that. That is the take method. So we give it an array and the total number of items we want to take from that array. So we're going to use two of the methods in Lodash. But in order to call these methods using a chain, first we need to convert this items array to a Lodash wrapper. So this is how we do that. Underscore, parenthesis, items. This will return a Lodash object. And with that, we can chain all the Lodash methods like this. So dot slice, dot take, dot whatever. So this makes our code more fluent. So now we go back to our slice method, start from this index, and then take items for this current page. That should be page size or less. Now finally, we need to convert this Lodash wrapper object to a regular array. And for that, we should chain the value method. This will return a regular array and we'll return that from this function. So this is how we can paginate data on the client side. Now in this section, we're not going to look at pagination on the server. That's an entirely different topic. We can come back to that later when we talk about calling backend services. So we have a paginate function. Let's go back to our movies component, import it on the top. So import paginate from, we go one level up, go to the utils folder and import the paginate module. Now let's go to our render method. So command and P, @render. We quickly jump here. So we are ready to paginate our movies. we call our paginate function, give it our array of movies. So that is this, that state, that movies. Or we could simplify this. So here, when we are destructuring the state object, we could also pick the movies property and then simply pass the movies here. Now, the second argument is the current page. So we pass that here. And finally, page size. Finally, we should change this expression. So instead of rendering the movies in the state object, we're going to render the movies that are local in this method. Save. Let's test the application. All right, we have an error here, duplicate declaration of movies. Because here when destructuring, we defined this movies constant, but we also have another movies here. So we can rename this movies to all movies. That's more clear. And here we'll pass all movies to the paginate function. Now back in the browser. So currently we have only 4 items here because we set the page size to 4. We can go to different pages and see different movies. So we successfully implemented pagination. So we have built this pagination component, but we have an issue here. Currently, we're assuming that the consumer of this component is going to pass these props. What if we forget to pass one of these props or pass the wrong type of value? For example, for items count, what if we pass a string like A, B, C? Let's see what happens. We get only a single page, whereas we have 9 movies in the database. This is how we create bugs in our application. Also, if you look at the console, there are no errors here. So in situations like this, we have to go back and forth between different parts of the code to figure out what we did wrong. To prevent issues like this, we need to do type checking. Now in React, we used to have type checking internally as part of the React library, but starting from version 15, this has moved to a different package that we need to install separately. So open up the terminal and install prop-types. The version I'm going to use is 15.6.2. All right, now back in our pagination component. On the top, we need to import prop types from this new prop types module. Now, after we define our component, we need to add a new property to it. And with this property, we'll define the type checking requirements for this component. So after we define pagination, we add a new property to it, prop types. Make sure to spell it properly. And here, P should be lowercase and T should be uppercase. So that's the camel notation. If you don't get this right, type checking is not going to work. So we set this to a new object. And in this object, we'll add the props for our component, as well as their types and whether they're required or not. So what are the props here? Let's go to the top. On line 6, where we are using object destructuring, so we have 4 props in this component. I'm going to copy these props. Now, back in our prop types object, paste them here. I'm going to give each property a value like this. Prop types dot. Here we have different validators like number to indicate that items count should be a number. We also have string, boolean, array, object, function, and so on. To see the complete list of prop types, go to reactjs.org. Under documentation, under advanced guides, if you scroll down, you should see type checking with prop types. On this page, you should see a comprehensive list of all prop types that are available to you. Now back to our code. So we set items count to a number. We can also chain is required to make sure that the consumer of the pagination component will pass this prop. You will see that in a second. Similarly, let's set page size to prop types, the number dot is required. Also, current page should be a required number. So prop types, the number dot is required. And finally, on page change, this should be a function. So we set this to prop types dot func dot is required. Now with this, since we have passed a string for items count, we're going to see a warning in our console. So back in the browser, all right, look, we've got a warning. This will only pop up in the development mode. So when you deploy your application, you're not going to see this. So the warning says failed prop type, invalid prop items count of type string, expected number. Similarly, if you forget to pass a prop, we're going to see a different error message. So as you build components, especially reusable components, it's a good practice to use prop types to catch bugs related to type checking. This will also give some kind of documentation to your component. So whenever you want to use a reusable component, you don't have to look at its render method to figure out what props you should give to this component. You can simply look at the prop types to figure out all the props, their type, and whether they're required or optional. So you have built the pagination component. Now it's time for another exercise. I want you to implement this list for filtering movies. So depending on the item we select, we see different results here. The genres that we have here, they come from our fake genre service. So here in the services folder, we have this fake genre service that we added at the beginning of the course. In this module, we have a single function, get genres, that returns an array of 3 genres. Now note that here we have an additional item, all genres. This is not a valid genre. This is just an item in this list. So you need to add this separately as part of initializing this component. Now in terms of the layout, what you see here is a Bootstrap list group component. Let me show you. So on Bootstrap website, if you search for list group, you will find this component. This is exactly what we're using. And here's the markup that you need. Very, very simple. So once again, start by thinking about the interface of this component and then implement it in a step-by-step fashion. So go ahead, spend 20 minutes on this exercise. When you're done, come back, continue watching. All right, let's start by adding a new file in the common folder and call it list group.jsx. Here on the top, we import React and create a functional component, call it list group. For now, we want to return null. We'll come back to this shortly. Now, as I told you before, whenever you create a component, you should think about the interface of that component. And the best way is to use that component before actually implementing it. So let's go to our movies component. Here on the top, I'm going to import list group from common/list group. Now let's go to the render method. So Command and P or Control and P, @render. We jump right here. Let's scroll down. Here we're going to make a small change. Currently we have a React fragment, and inside that we have a paragraph, a table, and pagination. We're going to introduce a Bootstrap row with 2 columns. In the left column, we're going to have everything that currently we have here. And in the right column, we're going to add our new list group. So the easiest way is to replace this React.fragment with a div. So select this as well as the closing tag and rename both of them to div. Good. Now back here, let's apply a class row. Inside this div, we're going to have 2 divs. One with the class call-2, that is our left column. And next to that, we're going to have a div with the class call, which takes the rest of the space. Tab. So we have 2 columns. Now I'm going to move everything that we currently have here inside of the right column. So let's select the paragraph and everything below that. Cut. So here's our Bootstrap row with 2 columns. I'm going to move everything inside of the right column. And then back here in the left column, I'm going to add our new list group. List group. Now, what do we need to pass here? At a minimum, this list group should get a list of items to render. So let's add the items property. We're going to set this to this.state.genres. Now currently we don't have this, so let's go on the top. Here's our state. Let's add genres. Now similar to how we have initialized the movies property, we can initialize genres right here. And this is perfectly fine for this simple application. But in a real-world application, you're going to call backend services to get these movies and genres. So the right place to initialize these properties is in component did mount lifecycle hook. So let me show you how to do that. For now, I'm going to initialize this to an empty array. Now, let's add component did mount. So to refresh your memory, this method will be called when an instance of this component is rendered in the DOM. Here we're going to call get movies and get genres. So on the top, let's import get genres from services/fake genre service. Now here in component did mount, we're going to call this .set state. We set movies to get movies and genres to get genres. And finally, we should replace this get movies here with an empty array. The reason we should initialize these properties to an empty array is because there is going to take some time until we get the data from the server. During this time, we want to make sure movies and genres are not undefined. Otherwise, we're going to get a runtime error. So we have set the genres property. Now back to our render method. So @render. Here's our list group. We set the items property. For now, I can't think of any other inputs to this component. So let's talk about the events. What events do we need here? Well, I believe whenever the user selects an item, we should be notified so we can filter the list of movies. So here, let's add an event on item select. And we set it to a method like this that handle genre select. Let's go ahead and create this method. So right here, handle genre select. In this method, we should get the genre that is currently selected. For now, we just want to display it on the console. Okay, with all these, we have defined the interface for this new component. So now let's go ahead and implement this. To render a list group, first, let's see what markup we need to work with. So here on Bootstrap website, under documentation, let's search for list group. So on this page, you can see a very basic list group. And here's the markup that we need to work with. A UL with the class list group. Inside this UL, we should have a bunch of list items with this class, list group item. So here in our list group component, let's return a UL with the class list-group. Inside this UL, we're going to have an LI with the class list-group-item. Now we want to render these items dynamically. So first we need to pass props here, use object destructuring to read the items property from the props object, and then map each item in this array to a list item element. So items.map, we get each item and map it to this element, like this. Now, because we're using the map method, we should give each item a unique identifier. So we set the key attribute to item._id. Next, we need to render the text of the item. So here, we're going to render item.name. Now, let's test the application. So this is what we get. On the left side, we have the list of genres, but I think this column is a little bit too small. So here in movies component, I'm going to change this call-2 to call-3. Okay, that is better. So we are successfully rendering the items, but there is a tiny issue with our implementation. Here in our list group component, we are assuming that each item has these two properties, underline ID and name. What if we're working with a different kind of object that doesn't have these two properties? Maybe instead of underline ID, that property is called value. So we don't want to be coupled to this interface. We want to make our list group more flexible. To solve this issue, we need to pass two more props here. These props will determine the name of the target properties, ID and name. Let me show you. So back in our movies component, here's our list group. I'm going to add a couple more props. One is text property, which I set to name, and value property, which I set to underline ID. So when we're using the list group, apart from passing the list of items, we should also pass the name of text and value properties so we can work with any kind of objects. Now back in our list group, here on the top, we need to pick these two properties from our props object. So text property and value property. With this, instead of using the dot notation to access these properties, we'll use the bracket notation to access properties dynamically. So I'm going to replace this with brackets, value property, and item.name with item of text property. With this change, we are no longer coupled to our genres, and we can reuse this list group with any kind of lists. In the last lecture, we added two new props to our list group to make it more flexible. However, these two additional props make the interface of this component a little bit more complex. The fewer props that we have to pass to a component, the easier it is to use that component. As a metaphor, think of a remote control. If that remote control has 50 buttons, it becomes really hard to use. If it has fewer buttons, it's much easier to use, right? We have the same principle here. So how can we solve this problem? Well, in this particular case, we can assume that most of our objects have these two properties, underline ID and name. So we can set the default value for these props. And then if in the future we're working with a different kind of object that doesn't have these two properties, we can overwrite the default values. So back in our list group, here we're going to set default props for this component. So after we define it, we type list group dot default props. We add a new property called default props and set it to an object. Make sure to spell it properly and use the right notation. So lowercase d, uppercase p, that's our camel notation. If you don't spell it properly, what I'm going to show you is not going to work. So in this object, we add our props and their default value. So here I'm going to set text property to name and value property to underline ID. With this, we no longer have to pass these two props when using our list group. So this simplifies the interface of our list group. Let's delete these two lines, test the application one more time. We still have the list of genres, beautiful. Next, we'll handle item selection. All right, now let's work on item selection. So here we want to handle the onClick event of the list item and raise a custom event called onItemSelect. So onClick, we set it to an arrow function, and here we're going to call the onItemSelect prop, because earlier in the movies component where we used our list group, we passed this prop onItemSelect. So back to our list group, on the top, we should extract this property from our props object onItemSelect. So that's a reference to a function. Here we're going to call that function onItemSelect and pass this item that we are rendering as an argument. Now let's test the application. So I'm going to click on action You can see our genre object here. Beautiful. Now, one thing that is missing here is the active class. So whenever we click on a genre, that genre should be active. So here, when rendering a list item, we should dynamically apply the active class if this item equals the selected item. So that means this list group should know the selected item. So back to our movies component. Let's go to handle genre select method. So Command and P or Control and P, @ handle genre select. Right here, instead of logging this genre on the console, we should store it in the state. So this, that set state, we set selected genre to this genre. So as you know, whenever we update the state, this component and all its children are re-rendered. So our list group will be re-rendered. Here we need to pass a new prop, selected item, which we set to this, that state, that selected genre. So now our list group knows what is the selected item, so it can apply the active class to that item. So back to our list group. On the top, we need to extract this new prop, selected item. Okay. Now, when rendering this list item, we should set the class dynamically. So let's change this string to an expression. Here we want to check if this item that we are rendering equals the selected item. We should return list group item class as well as the active class. Otherwise, we're going to return list group dash item. Save the changes. So this is the end result. Now let's test the application. I'm going to select this genre. Beautiful. So the selection works. Now, one last thing before we finish this lecture. I want you to pay attention to the names I have chosen for these props. There is consistency in these names. For example, this prop is called onItemSelect, and this other prop is called selected item. I didn't call this current item. I used the same word, the same language that I used for the other prop. This is something that I want you to pay great attention to, because I see a lot of developers just use messy names for their props, for their functions, for their classes. These are extremely important and very simple to apply. So when you have the same language in your code, you don't have to do all the guesswork to remember what was the name of that property or that function. You don't have to go back and forth between different files. You immediately remember. So always pay great attention to the names you choose. All right, now that we're handling the selection of an item, we are ready to filter the movies based on the selected genre. And that's the topic for the next lecture. All right, we're ready to filter our movies. So here in the movies component, in the render method, on line 48, we're calling the paginate method to paginate all the movies. We need to apply the filter before pagination because the number of pages should be based on the number of filtered movies. So here, first we need to get the selected genre. So on line 44, where we're using object destructuring, let's pick selected genre. Now, before pagination, we need to do filtering. So we define a new constant, filtered. Here we're going to use the ternary operator. So if selected genre is truthy, we're going to apply a filter. So we get all movies and filter them. So m goes to m.genre.underline_id should be equal to selected genre.underline_id. Otherwise, we're going to return all movies. So let me save the changes. So this is how we're doing filtering. If selected genre is truthy, we get all movies and filter them such that the genre of each movie is equal to the selected genre. Otherwise, if there is no selected genre, we're simply going to set this filtered list of movies to the list of all movies. Next, instead of passing all movies to the paginate function, we need to pass the filtered movies. And then down the bottom where we're using the paginate component, instead of passing this count constant, we need to change this expression and pass filtered dot length. So the number of pages are rendered properly. Let's test the application up to this point. So initially, we don't have any filters. We have 9 movies in the database and 3 pages. Beautiful. Back to page 1. I'm going to select action. Now we only see the action movies. So our filtering is working. However, this message on the top is showing the wrong number of movies. So back to our render method. This is where we're displaying that message. So once again, we need to replace count with filtered dot length. Save the changes, back in the browser. So I'm going to select action. Now we see 3 movies, beautiful. Let's select comedy. We only see the comedy movies. So our filtering is working, but we need to add another item to this list called all genres. We'll do that next. Now we need to add a new item on top of this list. We're going to call that all genres. So back in our movies component, here in component didMount method, this is where we're initializing the genres property of the state object. We need to make a slight change here. So we define a new constant, genres. We set it to a new array. We spread the array that is returned from getGenres function. So we have all the existing genres, and then we can put a new object at the beginning of this array. Here we set the name property to all genres, and we don't need to set an ID because this is not a valid genre in the database. This is just an item on top of this list, okay? So now we have an array of genres. We pass that here as the value of the genres property, or we can simplify the code because the key and value are the same. We can get rid of the repetition, and that is better. With this, we get all genres on the top. Let's select action. We get only the action movies. Beautiful. Now let's go back to all genres. Our movies disappear. Here's the reason. In our render method, where we are filtering the list of movies, we're checking to see if selected genre is truthy. If it's truthy, we're filtering the movies. So we get each movie and we make sure that the ID of the genre of that movie equals the ID of the selected genre. In this case, our selected genre doesn't have an ID because we only set the name property, right? That's why we don't see any movies when we select all genres. To fix this problem, we need to change this condition to something like this. Selected genre dot underline ID. So if selected genre and the ID of the selected genre are both truthy, then we will apply a filter. Otherwise, we get all the movies. Let's test the application one more time. So we go to action, we get action movies. We go to all genres, we get all movies. Beautiful. But there is a tiny issue here. If I go to the second page and then go back to the action movies, we don't see anything here, even though on the top it says showing 3 movies. Here's the reason. Let's go back to all genres. As you can see, we're on the second page. So when we select another genre, we are looking at the second page of movies in that genre. In this case, we only have 3 movies or 1 page in any of these genres. That's why we don't see any movies in this table. To fix this issue, whenever we change the filter, we should reset the page to 1. So back in our movies component, in handle genre select method, this is where we're setting the selected genre. We should also reset current page to 1. This will fix this bug. Let's test the application one more time. So let's go to the second page, select action. We see all the action movies, comedy, all the comedy movies, back to all genres, we get all the movies. Beautiful. So we have implemented pagination and filtering, but there is a tiny issue in the output of our movies component. See what's going on here. We have these 2 divs which we use to implement a grid layout. Here in the left column, we have a list group. That's a custom component we have built. In the right column, we have a message. Below that, we have a table with all these details. And then after that, we have the pagination component. The issue we have here is mixed levels of abstraction. So here we have components that are high level or simplified or abstract, like pagination and list group. But we have elements like this table that is low level. It's too detailed. So we don't have symmetry or consistency in our code. So the first thing I want to do now is to extract a new component, let's call it movies table, and move all these details about rendering this table inside of that component. So here in the components folder, I'm going to add a new file, movies table.jsx. Note that this is not under the common folder because it's not a reusable component. It's purely the table of movies that we have on the movies page. Now in the future, we're going to refactor this code step by step and eventually extract a reusable table component. But for now, let's not worry about it. So here on the top, let's import React and create a functional component. Again, in this case, I really don't think we need local state in this component. So I'm going to start with a functional component. We can always promote this function to a class later if we really need to. So let's call this movies table. We pass the props object here. Now back in our movies component, let's select all this table markup, cut it, and paste it right here. All right, now we need to make a few small changes here. So first, we don't have movies. We need to get it from our props object. So as a convention, I would like to do my object destructuring at the beginning of every functional component. With this, we can get an idea of what the interface of this component looks like. So let's pick movies from props. Good. Now, what else do we need to change here? Let's take a look. So here we have these two handlers, onClick for the like button and the delete button. Since we're passing movies via props, we are not supposed to modify the props. So the actual state is stored in the movies component. So here we should raise an event and let the movies component delete or like a given movie. So here on the top, we should pick a couple more properties from our props object. One is on delete and the other is on like. So these are function references, as you know. Now here, instead of calling this.handle like, we're going to call on like. And similarly, on delete. I believe we're done with this component. Now let's use it. So back in movies component, this is where we should use it. So movies table, and of course we need to import it on the top. You can see we no longer need the like component here because it's grayed out. In fact, we need this in our movies table component. So let's cut this line and paste it here. Now back in movies component, on the top, let's import movies table from the current folder, movies table module. And finally, let's initialize it. Here's our movies table. We should pass our movies as well as handlers for on, like, and on delete events. So this.handle like and on delete equals this.handle delete. Save the changes. Now look at the output of our movies component. We have our grid layout, and in this grid layout, we have high-level components like list group, movies table, and pagination. All these components are at the same level of abstraction. We don't have a mixture of high-level components and low-level components, or more accurately, elements. So our code is cleaner here. The intent is more clear. We don't have to scroll up and down to see what's going on here. All right, now that we have our movies table, we need to add sorting to each of these columns. And that's what we're going to do next. Now we need to handle the click event of each of these table headings and raise the sort event. So on the top, we need to pick another property from our props object, onSort. And once again, this is a function reference or a reference to an event handler in the movies component. All right, now I'm going to select this th here. Note that I've selected both the angle bracket as well as th. With this, I'm going to press Command and D. You can press Control D on Windows to select these 4 table headings. Now we can modify them all in one go. So let's type angle bracket th, then unclick, we set it to an expression, we pass an arrow function and call the onSort function. Now as an argument, we need to specify the name of the target property for sorting. The first one is title. The second one is genre.name, because this is a nested property. The third one is number in stock. And the last one is daily rental rate. Now we need to go back to our movies component. Here's our movies table. We need to handle the onSort event. So onSort, we set it to this.handleSort. See, we have a common pattern in this code. Our code is consistent. Okay, now let's implement this handler. So after the other handlers, let's implement handle sort. Here we get the name of the column. Actually, more accurately, this is the path to the target property. For now, let's just do a console.log to make sure we have put all these pieces together properly. So path. Now back in the browser. Here in the console, we have a warning. That's actually from the changes we made earlier. So each child in an array or iterator should have a unique key. We're getting this error from our list group. I'll help you fix that later. For now, let's just focus on what we were doing. So clear the console, click on the first column, we get title, click on the second column, we get genre.name. Beautiful. So in the next lecture, we're going to implement sorting. But before we get there, let's quickly fix the issue with this warning. So let's go to our list group component. This is where we have used the map method. As you can see, we have set the key attribute of this list item. So technically we shouldn't get that error. However, the reason we get that is because earlier in movies component, here in component did mount, we added a new genre to this array. This genre doesn't have an ID. So the ID property that we are using for setting the key is undefined. That's why we get that error. To fix this, we just need to pass an empty string. So underline ID, we set it to an empty string. Okay, save the changes. Back in the browser, the error is gone. So next, we'll implement sorting. All right, to implement sorting, we're going to use the same approach we have used earlier in this component. So in all these event handlers, as you can see, whenever we change the page or select a different genre, we update the state. This will cause a re-rendering. And then here in the render method, we will figure out what exactly we need to display to the user. So here in handle sort method, we need to call this .setState. Let's call that property sort column. We set this to an object with 2 properties, path, which we set to this path, and order, which we set to ascending. Now we can simplify this code by removing the duplication. So for now, let's just implement the ascending sort, and then we'll come back and implement the reverse order. So here's our sort column. We should also initialize this in the state. So when the page loads, we know how we are sorting our movies. So, okay, here's the state. So currently we have current page, page size. Now we add one more piece here, sort column. We set the path to title and order to ascending. Now to implement sorting on the client, once again, we're going to use Lodash. So let's import it here. Import underscore from Lodash. Now we go to our render method. So render. Okay. We should do sorting after filtering data. So first we filter, then we sort, and finally we will paginate the data. This is the order we need to implement these operations. So we call _.orderBy. The first argument is our input, so the array of filtered movies. The second argument is an array of property names, because we can sort by multiple columns or multiple properties. Here we only have sort by one column, so we pass sort column dot path. Obviously, we need to pick this from the state. So here where we are doing object destructuring, let's pick sort column from the state, sort column. Good. And the third argument is the sort order. So once again, we have an array. Because we can sort by multiple columns, we simply pass sort column dot order. This will return a new array. We call that sorted, and then pass that to our paginate function, sorted. Let's test the application up to this point. So initially, you can see our movies are sorted by their title. If we click the genre column, now all the action movies come first, then comedy, and so on. If we sort by stock, we see our numbers are sorted. Beautiful. So let's go ahead and implement the reverse sort order. Here in handle sort method, we need to make a small change. If this path we're getting here is the same as the path we have in our sort column, we should simply reverse the sort order. Otherwise, we should update the path and set the order to ascending. There are various ways to implement this concept, so here's one way. First, we clone the existing sort column object, so constant sort column. We create a new object, use the spread operator to clone this .state .sort column. Now, if sort column .path is the same as this path that we're getting here, we need to change the sort order. So sort column .order becomes, first we check the existing order. So if sort column .order equals ascending, then we should set it to descending. Otherwise, we set it to ascending. Now, otherwise, if path is different, we should set the path. So sort column .path should be set to the new path. And sort column .order should always be ascending whenever we sort on a new column. And finally, we should update the state based on this new sort column object. Save the changes. Back here. So initially, our movies are sorted by their title in an ascending order. If we click the title again, now they are sorted in a descending order. Let's change the sort column, sort by genre. It's ascending again. One more time. Now it's descending. Perfect. So our sorting is working. However, there is a problem with this implementation, and that's what we're going to look at next. So as I told you in the last lecture, there is a problem with this implementation. The problem is that if we reuse this movies table component somewhere else, let's say on another page, there, when this table raises an event, we have to duplicate all this logic for determining the sort order. That doesn't make sense. Technically, this logic belongs to the movies table component itself. So when it raises the sort event, instead of giving us a path that is a string, it should give us a sort column object so we know what is the path and the current sort order. So back in our movies table, we should promote this component from a function to a class because we want to add a method in that class for determining the sort order. So let's create a class component, cc tab, call it movies table. Hit the escape a couple times to make sure you disable multi-cursor editing. We don't need the state, delete. Also remove what we have in the render method. We don't need this line either, export default, because this component is already exported. Now on the top, we need to import the component class. So we import React and then the component class. Okay, we have the skeleton. Now what we have in this function, we need to move it in our render method. So select everything from here all the way to the end. Cut. So here's our functional component. We delete that and move all the code in the render method. Save the changes. Now we need to make a small change here. We need to replace props with this.props because props is not a parameter here. Now before going any further, let's test the application up to this point. So we don't have any errors or warnings here, and our sorting works. Beautiful. So the first step of our refactoring was to promote this component from a function to a class. Now the second step. Here we need to add a new method. Let's call it raise sort. That takes a path. And in this method, we'll have the logic for determining the sort order. So back to our movies component. All the code that we have here, except the last line for setting the state, we should cut this code and move it right here. Now let's see what's going on. We're cloning this .state.sort column. We don't have state here. We get everything via props. So we should clone this .props.sort column. Also, in the last line, we need to raise the sort event. So this .props.unsort, and we pass the sort column object. Next, instead of calling the unsort function, we're going to call this new method that we added to our class. So let's change all the occurrences of unsort. Select, 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 and change them all to this .raise sort. Done. Now back in our movies component, our handle sort event handler no longer takes a path. It takes a sort column object. So sort column. And one final step. In our movies table, as you can see, we expect to get the sort column object via props. So back in the movies component, here in the render method where we are using our movies table, we pass the list of movies. We should also pass the sort column, which we pick from the state, sort column. And this makes perfect sense because if in the future we persist the current sort order or the current page, as the user navigates away from the list of movies and then comes back, we want to initialize this page with the last sort order. So it makes perfect sense to pass this column, the sort column, to our movies table to make sure it's showing the right sort order when this page is initialized. Now let's test the application. So back in the browser, we have a warning here. We'll get to that shortly. Let's just make sure our sorting works. So initially our movies are sorted by the title. Let's click here. Now they're sorted in a descending order. Let's sort by genre. Beautiful. One more time. Perfect. So what is this warning? Here on line 17 of movies table component, unsort is assigned a value but never used. So here in movies table, line 17, you can see unsort is grayed out. We don't need this. Delete, save the changes, and the warning is gone. Beautiful. So we have put the responsibility of determining the sort order in our movies table. And with this, if we reuse this table in multiple places, we don't have to duplicate this logic. So that's definitely a good improvement. But what if you're going to have a table of customers? With our current implementation, again, we have to duplicate this logic in a component like customers table. So we need to take this to the next level. We need to extract a new component like table header that encapsulates this logic. And then we can reuse that table header whenever we have a table. We could have a table of movies, customers, rentals, and so on. So here in the common folder, let's add a new file, table header.jsx. We import React on the top, so imrc, and then create a class component, table header. Now, we don't need the state, so delete it. Back to our movies table, we need to move this method, raise sort, into our new component. So let's put it here. Good. Now, in the render method, we should render something like this. So a T head, a TR, and a bunch of TH elements. Now, in order to render this markup, this table header needs to know about the columns. So let's see what the interface of this table header is going to look like. You should get columns, which is an array. Also, as you can see here, we have two references to this.props. So we should also pass the sort column, which is an object, and unsort, which is a function. So sort column, that's an object, and unsort, which is a function. This is the interface of our new table header component. Now let's focus on the render method. So here we want to return a T head. Inside this T head, we're going to have a TR and a bunch of TH elements. Now we want to render these TH elements dynamically. So let's add an expression here. Get this.props.columns.map. Get each column and map it to a TH element. Now here we need to render the name of the column. So each column should have a property like label. Now back to our movies table. Look at our TH elements. Here we should also handle the onClick event. So I'm going to copy this expression from here and paste it right here. Let me save the changes so the code is reformatted. Let's see what's going on here. So we have T head, TR, a bunch of TH elements. Each TH has an onClick. Here we simply call this.raiseSort, which is one of the internal methods in this class. Now, instead of passing the title, we should pass the path to the target property. So our column objects should also have a path property. Okay? So this is our table header. Now, let's use this in our movies table component. So first on the top, we need to import this. Import table header from common/table header. Next, inside this class, let's create a new property, columns. Note that I'm initializing columns here. It doesn't have to be part of the state because it's not going to change throughout the life cycle of this component. So a simple property is sufficient. Now each column should have two properties. One is path, like title, and the other is label, like title with the capital T. Now let's duplicate this a few times. Let's modify the second column. So the path is genre.name and the label is genre. The third one, the path is number in stock and the label is stock. Next, the path is daily rental rate and the label is rate. Now we need two more columns for our like and delete buttons, but these columns don't have a label, so we are not going to pass this property here. They also don't need the path property because we are not going to sort our movies based on these columns. So for now, we just pass an empty object, so they will be rendered. So we have our columns. Now, let's replace this T head with our new table header component. So table header, we pass our columns. We set it to this.columns. Now, what else do we need to pass here? Let's go back to our table header and see the interface of this component. So we pass the columns. We should also pass sort column and unsort. We already have both of these in our movies table because they're coming from the parent, which is the movies component. So we pass sort column. We should pick this from props, sort column, and we pass that here. And finally, unsort. Again, this already exists in the props object. I would like to put all the events next to each other. So undelete, unlike, unsort, that's cleaner. And we pass that here. Unsort. So here's the result. We pass the columns, sort column, and unsort. Now back in the browser, we have a warning. Each child in an array or iterator should have a unique key. This is coming from our table header, line 24. So here in our table header, line 24, this is where we are using the map method to render th elements. We forgot to set the key attribute, so we set the key to column.path because this uniquely identifies each column. However, back in the movies table component, you can see the last two columns don't have the path property. So we need to give them a new property that can be used as a unique key. So I'm going to call that property key. We can set it to something like and delete. Save the changes. Now back in table header, we need to modify this. So here we can use the logical OR operator and use column.key. So if we have column.path, we're going to use that. Otherwise, we're going to use column.key. Let's test the application. You can see the warning is gone. Our table header is rendered properly. Let's see if sorting works. Beautiful. So now in our movies table component, in the render method, we have the same issue that we had earlier. We have mixed levels of abstraction. Here we have this table element. Inside that, we have this high-level component that encapsulates some detail. But right below that, we have this t-body with all these details about rendering the body of this table. So we have mixed levels of abstraction. This is very ugly. Wouldn't that be nicer if, similar to this table header, we had a component like table body? So let's go ahead and create this component. Here in the common folder, let's add a new file, table body.jsx. Let's import React on the top and create a class component, table body. Now we don't need the state, so let's delete that. Now what should be returned in the render method? Let's take a look at our movies table. So we want a t-body, a bunch of TRs, and a bunch of TDs. So back in table body, let's return t-body, inside that TR and TD. Now we want to render TRs dynamically based on the number of objects we want to display in this table. So this is where we are defining the interface for this component. Back to the movies table component, what data do we need to pass here? The list of movies. So let's set the data attribute to movies. Note that I named this attribute data instead of movies because I want this component to be completely decoupled from movies. It doesn't know anything about movies. In the future, we can reuse this to display a list of customers. So we need to give it the list of movies. Now, back in the table body. So in our render method on the top, just like before, as a convention, we do our object destructuring. We pick all the properties we need, in this case, data from this.props. So let's add an expression. We get the data, map it. We get an item. Again, I'm not talking about movies. I'm talking about items. Each item goes to a TR, like this. Now, similarly, we need to render these TDs dynamically based on the number of columns. So this table body should also know about the columns. So I'm going to pick columns from the props object. Once again, we add an expression. We get the columns and map each column to a TD like this. In the next lecture, we'll render the content for each TD. Now we want to render the content of each TD. As you can see here, in the first TDs, we're simply rendering a property of a movie object. But in the last two columns, we are rendering custom content, such as a like component or a delete button. This is the tricky part. So for now, let's focus on the first four columns. So back in the table body component, here in TD, we want to render a property of this current item. So we get item, which is our current object, we use the bracket notation to access a property dynamically. What is that property? That is column.path. However, this only works for simple properties. If you're dealing with nested properties, this does not work. In this application, one of our properties is genre.name, so we cannot use the bracket notation here. Instead, we're going to use lodash. So on the top, we import underscore from lodash. Now lodash has a method called get, so let's delete this. Here in this expression, we call underscore or lodash.get. We pass our object, that is item, and then the target property that can be nested. So that is column.path. Let's save the changes. Back in movies table. So we have taken care of these first 4 columns. Before we get to the other 2 columns, let's test the application up to this point. So I want to comment out this entire T-body section. Let's select all this. On Mac, press Command and slash. On Windows, press Control slash. With this, we can comment out code in JSX. Now finally, we need to import this component on the top. So import table body from common/table body. Save the changes. So here in the browser, you can see the body of our table is rendered properly. Obviously, we don't have these 2 buttons here. We also have a warning about the lack of a unique key. We'll get to that shortly. So we successfully rendered the first 4 columns. Now let's look at the other 2 columns. So back in the movies table component, let's uncomment this piece of code. So in this column, we have a like component. Earlier, you learned that these JSX expressions get compiled to React elements, which are plain JavaScript objects. As an example, here on the top, I'm going to declare a constant, call it x, and set it to an age 1. You know that this is a React element, which is essentially a plain JavaScript object. The same is true when we have a like component. So that like component that we are referencing in a JSX expression is essentially a plain JavaScript object. So just like we can pass any objects to functions or use them as values of properties, here in our columns array, we can add a new property, call it content, and set it to a JSX expression like this. That's perfectly valid, right? So let's delete this line. I'm going to grab the reference to our like component and put it here. So here's our like component, select, cut, and then put it here as the value of the content property. Good. We're going to use the same approach with the delete column. So here's our delete button, cut, and then add a content property here and set it to this button. Beautiful. Now we can get rid of this T body element. This is no longer used. So delete, save the changes. Back in the browser, we have a few errors here. In movies table component on line 14, movie is not defined. So here in the movies table component where we are defining our columns, line 14, obviously here we have a reference to movie, but we don't know which movie. So how can we fix this problem? Well, we can replace this value with a function. So instead of setting this to a React element, we set this to a function that takes a parameter like movie and returns a React element. Now, movie is the parameter that we're passing here. We have a similar issue with unlike. What is unlike? This is part of the props object. So this movies table, we have used this in our movies component. Here's our movies table. Look, we have unlike, undelete, unsort. These are the events that this movies table is going to raise. So back in our movies table, instead of unlike, we should reference this.props.unlike. Okay? Now we need to make the same change to the last column. So here's our content property. Instead of setting this to a React element, we set it to a function that takes a movie object and returns a React element. And next we need to prefix this with this .props. Good. Save the changes. Back in the browser, we still have a warning about the unique key. You can see our table is partially rendered, but we don't have the buttons. Because in our table body, for now, we're just rendering a property of a movie object. So we need to change this such that if this column has a content property, we're going to render that content, which can be a like or a delete button. So here we need to have a conditional statement. I would rather to extract this logic into a separate method to clean up this code. So let's add a new method here, render cell. This method takes two parameters, the current item and column. They go to this code block. Now here we can check if column.content exists, if it's defined. If it's truthy, we're going to call this, which is a function. So column.content, it's a function. We give it an argument, which is this item. That's the movie we are rendering, right? And this will return a React element. Let me show you one more time. So this content is a function that takes a movie or an item and returns a React element. So whatever this function is returning, we'll simply return it here. Otherwise, if we don't have this property, we're going to render a property of the current item. So we cut this here and return it right here. And finally, we'll call this new method right here, this.renderCell. We give it the item and the column. Okay, let's test the application. So you can see our table is rendered. Don't worry about that warning. We'll get to that in the next lecture. Let's test the sorting. That works. Paging, beautiful. Filters. Awesome. Next, we'll fix the issue with the key. So here in our table body component, we're using the map method in a couple of places. One is for rendering the rows. So here we need to give each row a unique key. That is pretty simple. So we set key. We can assume that most, if not all objects we're going to render have an ID property. So we can set that to item.underline-ID. And of course, we can make this more flexible. So we can pass an additional prop that determines the name of the target ID property. But we have done this before, so I'm not going to repeat this to waste your time. So that is the unique key for each row. We should also apply a unique key to each cell. So here in this TD, we set the key. Here we can combine the ID of the item we are rendering with the pass to the target property. For example, we can set a key like this, item.underline-ID plus column.pass. However, this will work only for the first 4 columns. For the last 2 columns, where we have the like and delete buttons, we don't have the pass property. So we can use the logical OR operator and do something like this. I put this in parentheses. So if we have the pass, we use that. Otherwise, we'll use column.key. I would rather to extract this expression from here and put it in a separate method because this code is getting a little bit ugly. So let's define a new method. Call it createKey. That takes an item and column and simply returns this expression. So let's select this here, cut, return it in this method. And here we call this.createKey for this item and this column. Now let's save the changes so the code is reformatted. That is better. So we have tr with a unique key. We have a bunch of columns or cells in each row. We have a td with a key, and here we render the content for this td. Back in the browser, you can see the warning is gone. We got 2 more issues here in movies table component. On line 32, we have references to onDelete and onLike. We no longer need them. So here in movies table component, on line 32, you can see Undelete and unlike are grayed out, so let's delete these. Done. So all these functions are currently working. The only thing that is remaining is adding the sort icon to each table header. Now we want to add a sort icon to the currently sorted column. So in our table header component, this is where we're rendering a th. Right after rendering the name of the column, we want to add an icon. So here I'm going to add an expression and make a call to this .render sort icon. This is a new method we're going to create, and we're going to encapsulate all the logic for determining the icon in this method. So let's add that here, render sort icon. We set it to an arrow function that takes the current column we are rendering. Now, first we need to see if this column we're getting here is different from the current sort column. So if column.path does not equal this.props.sort column.path, we don't want to render any icons, so we return null. Otherwise, this column is sorted, so we need to render different icons depending on the sort order. So if this.props.sort column.order equals ascending, we should return an icon like this. An I element with a couple of classes, FA font awesome and FA-sort-ascending. Now, in case you're curious how I found these classes, just like before, I looked up the documentation for font awesome version 4.7. I found the sort icon I wanted, and here are the classes that we need. Now, back in the code, here we have repeated this.props.sort column. So let's use object destructuring to clean up this code. We want the sort column property of this.props. With this, we can simplify these expressions to sort column. Okay. And finally, if none of these conditions evaluate to true, that means this column is sorted in the descending order. So we return an icon with two classes, FA and FA-sort-descending. Okay, now let's test the application. We have an error, cannot read property path of undefined. This error is coming from line 22. So column is undefined because here on line 36, where I called render sort icon, I forgot to pass the argument. So we need to pass the current column. Save the changes. So currently you can see our movies are sorted by their title. In an ascending order, let's click this column. That icon is changed. One more time, beautiful. Let's sort by a different column. Perfect. Now the only thing that is remaining here is making this table header look clickable. So here we can apply an inline style, or we can define a class that we can reuse in multiple places. So let's go to index.css. This is our main style sheet. Here we can define a reusable class, clickable, and set the cursor to pointer. Now, back in our table header, we apply this new class to our th. So class name should be clickable. Let's test the application one more time. So now you can see we have this hand icon, beautiful. All right, one last refactoring we want to do here. In our movies table component, look at what we're returning, a table element. Inside that we have table header and table body. With this implementation, next time we want to render a table of items, we have to add the table again, plus the table header. And note that here, we're setting the columns attribute twice. It's a little bit inconvenient to add a new table. So let's extract a new component, call it table, so we can reuse it easily whenever we want to render a table of items. So here in the common folder, let's add a new file, table.jsx. On the top, we import React and create a functional component, call it table. It takes the props object here. Now back to our movies table component. I'm going to select this entire markup, cut it, and paste it here. Now here we need to import the table header and table body components. So back to our movies table component. On the top, I'm going to grab these two lines, cut them, and put them right here. We just need to change the location of their modules. We don't need the common folder because currently we are in the common folder. Okay. Next, we need to modify the value of these attributes. So we need to read all of these from the props. Let's do our object destructuring. So we need the columns, the sort column, the unsort event handler, and data. We pick all of these from this props argument. And then we'll change this .columns with just columns. And finally here, instead of movies, we're going to use data. Okay, now we have a simple reusable table component. These four props define the interface of this component. So let's use this in our movies table component. On the top, first we need to import it. Import table from common/table. Now here in the render method, we will return a table with these properties. Columns, which we set to this .columns. Data, which we set to movies, which we read here from our props, as well as two more attributes. Sort column, which we set to sort column, and finally unsort. Unsort. Now look at the implementation of this movies table component. In this component, we're defining the columns we want to display. So our implementation is very specific to movies. These are the columns we want to render. These are the properties in each movie we want to render. Now in our render method, we're simply returning a table. So this component is a wrapper around this table and has all the data that this table needs. That is a much better implementation. And in the future, let's say we want to render a table of customers. All we have to do is to reuse this table component. All right, one last thing that is bugging me here a little bit. In our movies component, look at the render method. These first few lines is all about object destructuring. That's perfectly fine. But below that, we have this logic for determining the list of movies to display. This logic is polluting the implementation of this method. Ideally, we should just return this output. So let's extract these few lines into a new method. So let's cut this code from here. Add a new method, get paged data. Paste all that code here. All right, now back in our render method. Basically, there are two things we need here. We need the total number of movies after the filter is applied, as well as the movies in the current page. So this new method that we created here should return an object like this. Total count, which we set to filtered.length, and data, which we set to the movies. Now we can come back to our render method, and just before our return statement, define a new constant, call it result, and set it to the return value of this that get paged data. Now here we can use object destructuring to extract the properties that we need. So we want total count and data. Finally, we replace any occurrences of filtered.length with total count and movies with data, or we can come back here and rename data to movies. That's better. So with this refactoring, we have simplified our render method. All the logic for applying filtering, sorting, and pagination is encapsulated in this new method. Now back in the browser, we have these errors here. On line 52, selected genre is not defined. So in this new method, we need a few properties of the state object. So just like we used object destructuring here in the render method, I'm going to copy this code into our new method and then clean it up. So here we need page size because we're passing it to our paginate function. We also need current page, sort column, selected genre, and all movies. Okay, so we're done here. However, in our render method, as you can see, selected genre and all movies are grayed out. We no longer need these. So delete, save the changes. You can see our render method is even cleaner. Now back in the browser, all the errors are gone. Our sorting is working, liking, deleting, filtering, everything is working. Beautiful. There is one more thing I would like to improve in our code. If you look at our table component, here on line 6, we are doing object destructuring. Earlier, I showed you how to destructure the argument of a function. So we can make this code a little bit cleaner like this. By destructuring this props argument, we can get rid of line 6 and make this code a little bit cleaner. So I replace props with parentheses and then move these curly braces right here. So we're picking these properties from the argument of this function, which is the props object. Now we no longer need line 6 and our function is cleaner and shorter. I want you to apply the same technique on the other functional components we have created in the common folder. In this section, we're going to take our Vidly application to the next level by adding routing. As part of this, you're going to learn all about working with route parameters and query strings. You're going to learn how to redirect the user, implement not found pages, as well as nested routing. Are you ready? Let's get started. Before we get started, I want you to download the zip file I have attached to the first lecture in this section. When you open the zip file, you're going to see two folders, Start and Finish. Under Start, you should see Router App. This is a very basic project that I have created to help us learn about routing in React. So it has a few very basic components. We don't want to type all this code by hand. So grab this folder. Then in the terminal, inside this folder, run npm install. Okay, when all the packages are installed, then run npm start. So this is what you should get, a very basic page. And here's our navigation bar. In this section, we don't care about the aesthetics and having a beautiful user interface. We just want to implement routing so we can take the user from one page to another. Also, there is a useful extension I want you to install. I don't know why I forgot to tell you about this earlier. This extension is called Auto Import ES6, TS, JSX, and TSX. With this, you can easily reference your components, and this plugin will automatically import them on top of your modules. So you don't have to manually type an import statement. So just make sure to install the extension that has ES6, TS, and JSX, because there are a few auto import plugins, but this one in particular is helpful in React applications. So go ahead, install everything, and I will see you in the next lecture. Unlike frameworks like Angular, in React, we don't have the concept of routing. Because React is a simple, lightweight library and not a complete framework, it's only responsible for rendering the view, nothing more. So to add routing to our application, we need to install a library called React Router DOM. So open up the terminal and install React-Router-DOM. This is the implementation of React Router for DOM or browser. There is also another implementation called React Router Native, and that is used in native mobile applications, which is an entirely different topic from this course. So make sure to install version 4.3.1. Okay, Now to add routing, there are two steps we need to follow. First, we need to go to index.js. On the top, we need to import a component called browser router from React router DOM. Now let me show you a shortcut. You don't have to type the complete name of a module. You can simply type the first letter of every word. So React router DOM. That's it. Okay. Now we need to wrap this app component with browser router like this. Browser router. And let's close it here. Beautiful. So this component grabs the history object in browsers and passes it down the component tree. So anywhere in our component tree, we'll be able to use the history object. That's what this component does. Next, we need to register our routes. And that basically means we need to tell React what component should be rendered based on a given URL. For that, let's go to app.js. So here in this div, we have a navigation bar. Let's imagine we have a div below that for our content area. So div with the class, let's say content. It doesn't really matter. Now in this content area, we want to render a given component based on what we have in the current URL. That's where we use the route component. So on the top, we need to import the route component from React router DOM. Good. Now we need to register one or more routes. So we add the route component, give it two props. One is path and the other is component. So this route is a component just like the components we have built so far. It has attributes and these attributes will be passed as props. Now let's give this a path like /products and set the component to the products component. In the starter project, I have already imported this component on the top, so you don't need to import it. Now, this route component looks at the current URL. If it matches this pattern, it will render this component. Now, let's duplicate this 3 times. For the second route, we're going to set the path to posts and the component to posts component. The third one is going to be admin, and we set the component to dashboard. And finally, the last one should be homepage, which we set to the home component. Now save the changes. Back in the browser, currently you can see the home component is rendered because the current URL matches the pattern for this route. If we go to products, we see our products component, but we also see the home component. We have the same behavior in our other pages. So if we go to posts, we see our posts component as well as the home component. I will show you how to fix this problem in the next lecture. The matching algorithm that the route component uses checks to see if the current URL starts with this path. If so, then this component will be rendered. So that means if we go to /products, we'll see our products component here. But also if we go to /products/new, again, we see our products component. Because our URL, which is /products/new, starts with /products. For this very reason, this home component is rendered below our products page because when we head over to /products, our URL starts with a /. So both these paths will be matched, and that's why both these components, the products component and the home component, will be rendered. So how can we solve this problem? One solution is to use the exact attribute. So if we pass exact here, this route will match only if the path is exactly this. Let's test the application. Back in the browser, you can see below the products page, we no longer have the home page. And if we go to posts and admin, again, our home component is not rendered. So using exact is one solution. The other solution is to use the switch component. So on the top, we should import the switch component from React router DOM. And then we should wrap all these routes with a switch. The switch will render the first child that matches the location. So let me show you. I'm going to add switch here and close it here. With switch, we no longer need exact. So if we head over to /products, this is the first route that will match. So the other routes will be ignored. Save the changes. Back in the browser, look, we are at /products and we only see our products component. So that means when using the switch component, you should order your routes from the most specific ones to most generic ones. Even though we have implemented routing here, there is a problem with our implementation. Let's open up Chrome Developer Tools and go to the Network tab. Note that whenever I click on any of these links in our navigation bar, we will see a few HTTP requests to our server. So let's go to the home page. Here are our requests. So the first request is to download our HTML page. And the second request is to download our bundle, which is the combination of all our JavaScript code. While this is not a big deal in this simple application, in a large enterprise application, you don't want to download this entire bundle and the HTML page every time the user navigates from one page to another. Think of Gmail. Gmail is super fast. As you click on your emails, you can quickly see the content of your email. The entire page is not reloaded. We refer to applications built this way, like Gmail, as single page applications or SPAs. In single page applications, when the user navigates from one page to another, instead of reloading the entire page with all its assets, we should only update what we have in the content area. So in this application, how can we fix this issue? How can we turn this into a single page application so when we click on these links, we don't have a full reload? We need to go to our navbar.jsx. We need to replace all these anchors with a link component from React Router DOM. So on the top, import link, that's another component, just like route or browser router from React Router DOM. Now, let's select this anchor as well as these other ones and replace them all in one go to link. We should also replace the closing tag. Now, this link component doesn't have an attribute called href. Instead, it has another attribute called to. Save the changes back in the browser. On the home page, first I'm going to refresh the page. You can see a bunch of requests here. So we have the bundle as well as the HTML page. These other two requests are for WebSockets, which is used for hot module reloading. So as we modify our source code, the page is automatically refreshed. Don't worry about that. Now, note that when I click on the products, we are not going to see new requests on the product tab. So click, here's our products page, and there was no additional request to the server. The same happens when we go to posts or admin. Because the content for these components are essentially in our bundle.js. Look at our home component. It's simply a JavaScript function. So all our components are part of our bundle that are downloaded ahead of time when the application loads. So there's no need to re-download this bundle every time the user navigates to a different page. Now back to navbar. You might be curious how this link component prevented additional HTTP requests to be sent to the server. Let me show you. So back here, let's go to the React tab. Now in the search bar, type for navbar, our navbar component, ULLI, we have link. What is inside link? We have a regular anchor. However, this anchor has a handler for the onClick event. That's a prop. You can also see that here. When we click these links, this handler is called, and this function prevents the default behavior of an anchor. So that's why the browser will not send additional requests to the server. Instead, this handler will only update the URL here. Now that the URL is changed, one of these routes will match depending on the current URL, and we'll get a new component in the DOM. So currently we are on the products page. In Chrome Developer Tools, on the React tab, let's search for products component. Look at the props of this component. We have history, location, and match. We didn't pass these props here. So where did they come from? That's one of the things that this route component does. So essentially, a route component is a wrapper around this component that we pass here. So if the path matches the pattern we have set here, it will render this component and it will automatically inject these three props into it. So we use history to work with the history object in the browser, and with that we can send the user to a different page. We also have location, which represents where the app is now. So let's have a look here. Here we have a bunch of properties. You can see the path name is /products. And finally, we have match, which contains information about how this URL matched the path that we set in our route. Let's take a look. Again, we have a bunch of properties like isExact, params, which are route parameters. We're going to look at them later in the section, as well as path and URL. If you're curious about each of these objects and their properties, you can read about them by looking at the React Router documentation. So search for React Router. Look at the second link here, reacttraining.com/React Router. On this page, on the left side, you can see the full documentation for this library. And here, you'll find information about the history, location, and match objects. We're going to use these objects throughout this section, so you will have a good understanding of them. But of course, we're not going to look at every single property. So if you're dealing with specific cases, you can always look at the documentation to learn more about these objects. In the last lecture, you learned that this route component passes 3 additional props to this component. Now, a question you might have is, what if we want to pass additional props to this component? For example, previously, before adding routing, we could use our products component like this. And here we could set a prop like sort by newest. So how can we set additional props when using a route? Let me show you. So first, I'm going to delete this. If you need to pass additional props to this component, instead of the component attribute, you should use the render attribute. So render, we set this to an arrow function. So an arrow function goes to, now here we return our products component. So products, and then pass any additional props like sort by newest. So this arrow function takes no parameters and returns a products component. Okay. Now save the changes back in the browser. Let's go to our products page. Now in React tab, search for products component. You can see we have passed sort by here, and that is also listed under props. However, those other props like history, location, and match disappear. To fix this problem, we need to go back to our arrow function, pass props here. So React will automatically inject those props here. Now we need to pass all those props in addition to this custom prop. How do we do it? We use a special syntax in JSX. So we pass an object here, use the spread operator to spread the props object. So this is something that you can do in JSX. With this syntax, all the properties of the props object will be listed just like this custom prop we passed earlier. Now save the changes back in the browser. Once again, let's search for the products component. Now we have those standard props, history, location, and match, as well as our custom prop. There are times that we need to pass parameters in our routes. For example, here in the list of products, depending on what product I select, we should see a different product ID in the URL. So that's a route parameter. Now, let me show you how to pass and retrieve route parameters. So here in app.js, I'm going to define a new route for our product details page. So route, the path should be something like /products/ and this is where we need to add a parameter like :id. So to define a parameter, we should prefix that parameter with a colon. Now we could also define multiple parameters. For example, here in our third route, let's add a couple parameters. So posts for a given year and for a given month. Now back to our first route. Here we have defined our path. Now let's set the component to product details. Again, this component is imported on the top. So save the changes. We defined a new route, and note that this route is more specific than the second route. That's why I have put that first. Now back in the browser, let's go to the products page and click on one of these products. All right, now here on the React tab, let's search for product details component. Here are the props. Let's expand match. We have params. Look, we have this property ID that is set to 1. And this is coming from this URL here. So we can read the route parameters passed to a component using this match object. So let's go to our product details component. Here we have a basic component with an event handler. Don't worry about this. We'll get to this shortly. In our render method, I want to render the ID of the product in the heading. So here we add an expression. I'd render this .props.match.params.id. Obviously, if we have multiple parameters like year and month, this params object will have two properties named accordingly. Save the changes. Back here, now we can see the product ID displayed in the heading. Back to the products page. Let's pick another product. Now we got 2 here. I don't know if you noticed or not, but as I clicked on a product, we had a complete page reload. So let's go to our products component. The reason for this is because here we are rendering an anchor, and that's why we have a full page reload. So on the top, let's import link from React Router DOM, and then replace this anchor with a link like this. We should also replace href with 2. Okay, save the changes. Back in the browser, in the list of products, let's pick a product. We no longer have a full page reload. In the last lecture, we modified this route and introduced 2 parameters, year and month. Now back in the browser, if you go to the post page, we see the year and month in the URL. But let's see what happens if we exclude the months. We see the home component. What is the reason for this? Well, when we define parameters in our route, by default, those parameters are required. So in this case, our URL did not match this path because we didn't have a value for the month parameter. So then the matching continued, and this last route matched the current URL, and that's why we saw the home component. So how can we make these parameters optional? Well, we need to append a question mark to them like this. This is part of regular expressions in JavaScript. In regular expressions, when you append a question mark to an expression, that means that expression is optional. Now let's save the changes and go to our posts component. Here we have a functional component. We can pass props and read the match object, or we can simply destructure this here. We get the match object, and then we can extract the route parameters. So let's render the year here, match.params.year, and similarly match.params.month. Save the changes, back in the browser. With this change, we no longer see our home component. We have the post component. As you can see, we have a value for the year parameter, but month is empty. We can change the URL and add the month, and now it's displayed here. Or we can remove both these parameters because both of them are optional. We still see the post page, but we don't have any values for the year and month parameters. Even though in the last lecture you learned how to define optional parameters, generally speaking, optional parameters are something you need to avoid. Now, in this particular example, having these optional parameters in the URL makes sense because they give a nice structure to our URLs. For example, we can look at all the posts or posts for a given year or posts in a given month in a given year. But generally speaking, when you're dealing with optional parameters, instead of including them in the route, you should include them in query string. So as you know, query string is what we append to a URL using a question mark. Here we can have 0 or more parameters. For example, sort by, newest, and approved true. So let's imagine we only want to see the approved posts and we want these posts to be sorted by newest. Now we can apply these query string parameters on any combinations of the posts route, such as all posts or posts for a given year or a given year and a given month. These optional parameters can always be added on the right side. So now let me show you how to read these parameters in a React application. Here, let's press enter. Now open up React DevTools. So here, let's go to the React tab and search for the posts component. So you have seen the match object. We use this to extract the route parameters. Query string parameters are in the location object. Let's take a look. Look at the search property. The value of this property is our entire query string. Now, we don't want to manually read this string, parse it, and extract the value for these parameters. There must be a better way. So here in the terminal, let's install query-string version 6.1.0. This is a very popular NPM package for working with query strings. All right, installed. Now, let's go to our posts component. So in this functional component, currently we are destructuring the props object and getting the match property. We should also add location. Now, we're going to get location.search. This is a string, as you saw earlier. We're going to parse this string using the query string package. So on the top, import query string from query string module. This object has a parse method. So query string.parse. Here we pass location.search. And this will give us an object with properties based on the parameters in the query string. So here we have two parameters, sort by and approved. That object will have properties named accordingly. So we can either store everything in one object or use object destructuring to immediately extract the sort by property. In this case, I want to show you the actual object. So let's log this on the console. Now back in the browser. So this is the object that we get as a result of parsing the query string. Note that the values here are always string. So if you want to work with numbers or booleans, you need to parse them accordingly. Now let's see what happens when we go to an invalid route, such as /xyz. We get the home component. This is not the desired behavior. We want to redirect the user to a not found page. But before we implement that, let's review one more time why we're seeing the home component here. So in app.js, we have the switch along with these routes. In this particular case, this last route matched the current URL. That's why we saw the home component. But what if we apply the exact attribute here? In this case, we should display the home component only if the user is at the root of our website. So save the changes back in the browser. Now with XYZ, we no longer see the home component. So that is better, but we want to redirect the user to a different URL like /notfound. So here in app.js on the top, we need to import one more component from React Router DOM. That component is redirect. With this component, we can redirect the user to to a different URL. So if we get to this point, that means none of our routes are matched. So we can redirect the user to /not-found. Now, what do we want to display to the user at this URL? Well, we need to register a new route with this path and the not found component. So here we add another route, set the path to /not-found and component to not found, which is already imported on the top. Save the changes. Now you can see we are on the not found page. So if I change the URL to an invalid URL, we get automatically redirected to not found and we see this message here. Now this redirect component has another application. Sometimes you want to move resources on your website from one URL to another one. You can use the redirect component to achieve this. Here is an example. I'm going to add a redirect here. But this time, instead of setting to, we're going to set from and to. So this will be matched. If the current URL matches what we pass here, then we'll redirect the user to this new destination. So as an example, if the user navigates to /messages, we want to redirect them to /posts. Let's test this. Back in the browser, I'm going to head over to /messages. You can see I automatically got redirected to /posts. There are times that you want to redirect the user when they click a button or submit a form. Here's an example. In our product list, let's go to one of these products. Imagine we have a form here and a save button below that form. When the user clicks this button, we want to take them back to the products page. This is what we call programmatic navigation. So how do we do this? Well, let's open up React DevTools. So here, React tab. Here, let's search for the product details component. So far, you have seen the match and location objects. Now let's look at the history object. So this object has a bunch of useful methods for navigation, such as go back, go forward, as well as push and replace. The difference between push and replace is that this push method will add the new address in the browser history, so you can click the back button and go back to where you were. But replace basically replaces the current address, so we won't have history. Now to implement programmatic navigation, let's go to our product details component. Here's the handler for our save button. To take the user back to the products page, we need to write code like this. This.props, .history, .push, and the address is products. Save the changes. Back here, let's click this button. Now we are back in the products list. With the current implementation, if I click the back button, you see we're back to the product details page. Now let's see the replace method in action. So I'm going to change this to replace, save the changes. Once again, let's click this button. We're on the products page, back. As you see, we didn't go back to the product details page. This method is often used in login pages. So when the user logs in and goes to a new page, if they click the back button, you don't want to take them back to the login page. All right, now let's take this simple application to the next level. So I'm going to go to the admin. Here on admin dashboard, we have two links, users and posts. When I click on either of these links, we'll see the content of that page below here. In the first glance, you might be wondering, what is the use case for this? Well, you know that the links we have here on the top are part of our imaginary navigation bar. Now, when we go to the admin dashboard, we could have another navigation bar on the top, or maybe a sidebar on the left side, or maybe here we could have a few tabs. So as we select each tab, we'll see different content. This is what we call nested routing. So we have routing on the top and on the bottom. Now, let me show you how to implement this. So here in our project, let's go to the components folder, admin, and open up dashboard. On this dashboard, we're going to add 2 links. So on the top, we need to import the link component from React Router DOM. Now, let's add a UL. Inside this UL, we're going to have a list item. And inside this list item, we're going to have a link with the 2 attributes set to an empty string. Now we want 2 of these list items. So let's put this expression in parentheses and then multiply it by 2, tab. This is what we get. So the first one should be the link to /admin/posts. And we call this posts. And similarly, the second one should be /admin/users. And the label is users. Now, what we have here, this UL, ideally should be part of a separate component like navbar or sidebar or tabs. So let's quickly extract these elements and put them in a separate component. So here in the admin folder, I'm going to add a new file, sidebar.jsx. We import React on the top and create a functional component, call it sidebar. Now back in the dashboard, let's move this UL and all its children right here. And obviously we need to import the link component on the top. So I'm going to move this import statement to our sidebar as well. All right, now we have this sidebar. Let's add it to our dashboard. So here we import sidebar from the current folder /sidebar. And then add it right here. Now next to the sidebar, we're going to have the content area. So here we can use the route component just like how we used it on app.js to render a component in the content area of our application. So back on the dashboard, let's add a couple of routes here. The first one, the path should be /admin/users. If this path matches, we want to render the users component. Now my auto import plugin sometimes doesn't work. We don't know what's going on, but anyway, so let's import users from users. We should also import posts from the posts module. And then let's duplicate this, change the path and the component accordingly. That's all we have to do to implement nested routing. So what I want you to understand here is that you don't have to use the route component only on app.js. This is a regular component, just like other components we have created so far. So we can use it anywhere. What matters is that if the current URL matches this path, then we're going to get this component at this very location. Now, before we test the application, we need to import the route component on the top. So import route from React Router DOM. Save the changes back in the browser. Let's go to the admin, posts, and here's our posts component. All right, so here's your exercise for this section. I want you to add this bootstrap navigation bar on the top with 3 links: movies, customers, and rentals. As part of this exercise, you should create 2 very simple components: customers and rentals. Here, all I want you to display is a heading. Now, if we go to an invalid URL, like XYZ, we should be redirected to the not found page. And when we go to the root of this website, we should be automatically redirected to the movies page. Also, I want you to modify this table and replace the title that was a text with a link. When we click this link, we should go to a new page that is our movie form. Note that here, we're rendering the ID of the movie that is passed as a URL parameter. In the next section, we're going to build a form here, and instead of rendering the ID in the heading, we're going to populate the movie with the given ID. Also, I want you to add the save button here. When we click this, it should take us back to the movies page. And one last thing, note that here when I click on one of these menus, that menu gets highlighted. You can see the currently active menu is a little bit darker. To implement this, all you have to do is to replace the link component with nav link. So this is another component in React Router DOM. When you use this component, it automatically applies the active class to the currently selected link. So go ahead, spend 20 minutes on this exercise, and when you're done, come back, continue watching. All right, to add routing, first we need to install React Router DOM version 4.3.1. All right, done. Now in index.js, we need to import browser router on the top from React Router DOM, and then wrap our app component with this browser router, like this. Okay, so this adds routing to our application. Now I'm going to create a few simple components that we're going to use as part of routing. Now in components folder, I'm going to add a new file, customers.jsx. Here we import React and create a functional component called customers. For now, I just want to return an h1 customers, very simple. Now I'm going to pause the recording and create a few more components, including rentals, not found, and movie form. So these are my new components: customers, movie form, not found, and rentals. Next, I'm going to register routes. All right, now let's register our routes. So we go to app.js. On the top, I'm going to import the route component from React Router DOM. Now let me show you a Zen coding trick. I'm going to create 4 route components. Each route component should have 2 attributes: path and component. So times 4 tab. That didn't work because the extension of this file is .js, and we don't get this kind of Zen coding in JSX expressions. So that's why I told you at the beginning of the course to use JSX extension. Now in this particular case, we can rename this, or we can change the language of this file from JavaScript to JavaScript React. Okay. Now one more time, type 4 tab. That still doesn't work. Now one more time, a route component with path and component attributes. We want 4 of them. That's what we wanted. So the first one, the path should be /movies, and the component should be the movies component. Similarly, the second one should be /customers to customers component, and rentals. Here we set the component to rentals, and finally the last one to /not found, and we set the component to not found. Obviously, we need to import these 3 components. For some reason, my auto import plugin didn't work. Don't blame it on me. So all right, now let's test the application up to this point. So currently on the homepage, we don't see anything because we have not registered a route for this path. But if we go to /movies, we see our movies page. If we go to /customers, we see the customers page, and similarly the rentals page. So all of these are working beautiful. What if we go to not found? We get that as well. Now with all these in place, there are 2 more things we need to add. One is to redirect the user from the home page to /movies. So here we need to use the redirect component. So I'm going to import it on the top, redirect. And then here, redirect from the root to /movies. Let's test the application one more time. So I'm going to go to the home page. I get redirected to the movies. Beautiful. However, if I go to /customers, again, I get redirected to the movies page. The reason for this is because this path, as you learned earlier, matches any URLs that start with /. So now to fix this, we need to wrap all these with a switch component. So if we go to /customers, this route takes over and the other routes are ignored. So on the top, let's import the switch component and then add it here, switch and switch, wrap everything. Now back in the browser. So we are on the movies. If you go to the home page, we get back to the movies page. If we go to the customers page, we see our customers page. Beautiful. And one last thing. If we go to an invalid URL, we should be redirected to the not found page. So we need another redirect. But this redirect should not have the from attribute, so it can be applied to any other URLs. So we want to redirect to /notfound. All right, let's test this one more time. If we go to XYZ, we get redirected to the movies. The reason for that is because this path matches /XYZ. So we want this redirect to be applied only on the home page, not any URLs that start with /. So here we apply the exact attribute. Let's test the application one more time. So we go to the home page, we are redirected to the movies. If we go to XYZ, we get redirected to not found. Beautiful. And if we go to /customers, we get our customers page. So our routing is now working. Next, I'm going to add a navigation bar. All right, now let's add a navigation bar. So in the components folder, a new file, navbar.jsx, import React, and create a functional component called navbar. Next, I'm going to go to Bootstrap website. In the documentation for the navbar component, there are several examples. I'm going to use this one. It doesn't have any drop-down menus. It's simpler. It has 3 items here plus a disabled item that we don't need. So I'm going to copy this markup and then paste it in our navbar component. Next, we need to replace all these class attributes with class name. That's it. Next, we need to replace all these anchors with link or nav link to apply the active class automatically. So with this selected, I'm going to replace all of these anchors with nav link. Good. Similarly, we need to rename the closing tag. So one more time, close this with /navlink. Sweet. And finally, we need to replace all href attributes with 2. Good. Now here, instead of navbar, we're going to display the name of our application widly. For this particular link, we don't need to use navlink because we're not going to apply the active class here. So I'm going to select this navlink as well as the next one and replace them with link. Next, I'm going to change the 2 attribute to the root of our application. Okay, we're done with this. Now we need to add our links. So here we have home, features, pricing, and so on. I'm going to replace home with movies. Also change the 2 attribute to /movies. The next link should be to /customers. And finally, the last one should be to /rentals. We don't need the disabled link, so let's delete that. Also, note that here the active class is applied in the sample code. We don't need this. We want this to be set dynamically by the navlink component. So we're pretty much done with this component. On the top, we need to import link and navlink from React Router DOM. Next, we need to add this to our app component. So let's go to app.js. So here we have a container for the content area. Just above that, I'm going to add our navbar. Now my auto import plugin is going to work, as you can see in the tooltip. So enter, and it automatically added this import statement on the top. I would like to reorder this and put app.css at the end. That's cleaner. So first we have React, then we have React Router DOM, then we have all our custom components, and finally any CSS modules. So we added the navbar, but now we have an error because we are returning 2 elements here. So we need to wrap them with react.fragment and close it here. Good. Let's test the application. So here's our navbar. You can see there is a padding on the top. Let's quickly fix that before going forward. So let's go to index.css. I added this top padding early on, so let's change that to 0. Now back in the browser, you can see our navigation bar is on the top, but the content area is so close to the nav bar. To fix that, we can add our navbar class here. So this class is applied to our navigation bar. That's part of Bootstrap. So here we apply margin bottom to, let's say, 30 pixels. Now the content area is not too close to the navbar. You can see because we're on the customers page, this customers link is active. If I go to rentals, we see rentals and rentals is active. Movies, beautiful. So we're done with the navbar. Next, I'm going to add links to this table. All right, now to add links to this table, we need to go to our movies table component. Here in the array of columns, we need to modify the first column and introduce the content property. Earlier, we used this to render custom content, such as a like component. Now we want to render a link component. So let's add content here. We want to render a link like this to /movies/ Now here we need to add the ID of the movie dynamically. So just like the other content properties, instead of passing an element here, we need to pass an arrow function that takes a movie. So movie goes to, now to render the ID of the movie here, now I'm going to remove this text here. Instead pass curly braces. Inside the curly braces, I'm going to pass a template literal, so the backtick character. So our string is /movies/ and here we add an argument. So $, curly braces. What do we want to render? movie._id. That's what we need to have. Okay. Now in between the link tags, we need to render movie.title. So this is the end result. Our content property should be a function that takes a movie, renders a link. The to attribute is set to an expression. Here we have a template literal. If you're not familiar with template literals, you really need to take my JavaScript Basics for Beginners course. But basically, we use them to dynamically insert values into a string. So here we're adding movie.id. And finally, we render movie.title. Now, before going any further, we need to import the link component on the top. So import link from React Router DOM. Now back in the browser, our links are rendered properly, beautiful. If we click them, you can see the URL is updated and we have the ID of the movie in the route. Now we need to register a new route for this movie details page. So let's go to app.js. Here's the route to the list of movies. Above that, I'm going to add a new route to our movie details page. So the path should be /movies/:id. And the component should be movie form. So let's import this on the top. Import movie form from component /movie form. Save the changes. Back in the browser, now you can see we are on the movie form. If you go back to the movies, we have the list of movies. Now finally, on the movie form page, we want to extract the ID from the URL and display it right here. So let's go to movie form component. Here we have a functional component. I'm going to destructure the props and grab the match property. Here we can render match.params.id. Save the changes. Now you can see the ID of the movie in the heading. Beautiful. And one last thing. Here we need to add a button and programmatically take the user to the movies page. So let's wrap everything with a div. Inside this div, I'm going to add a button with a couple classes, btn and btn-primary. Call it save. We handle the onClick event. Now here, because we have a functional component, we can't do this .handle save. So for now, we can pass an arrow function. Here we can work with the history object directly. First, we need to extract it from our props object. So we grab history and then call history.push, and the address is /movies. That's all we have to do. Save the changes. So here's the end result. Now back in the browser, click save. We're back in the list of movies. Almost every application needs some kind of form. So in this section, we're going to take our Vidly application to the next level by implementing a few forms. We'll start by building this login form, and then as an exercise, you will build a registration form, a form to add or edit movies, and a search box to quickly look up movies. Are you ready? Let's get started. Let's start this section by building a login form. So in the components folder, let's add a new file, loginform.jsx. On the top, we import React and create a component class called login form. We don't need the state for now, so let's delete that. In the render method, let's just return an h1 login. Now let's register a new route in app.js. So open up app.js. Here I'm going to duplicate our first route. Okay. Change the path to /login and the component to login form. Note that my auto import plugin imported this login form on the top, but I would like to move it up so it's close to the other components. This way our code is clean and consistent. So we import all these components, and finally we import any style sheets. Okay. Next, we need to add a link to our navigation bar. So let's go to navbar.jsx. Here I'm going to duplicate the last link, change the label to login, and the to attribute to /login. Let's test the application up to this point. So here we have a login link, click, our login page, beautiful. Now we're ready to build a Bootstrap form. Here on Bootstrap website, let's look at the markup we need to create a form. So we have the form element. Inside the form, we have a div with the class form-group. With this div, we group a label and the corresponding input field. So you can see inside this div, we have a label and an input field. We also have some text that is for giving the user a hint like this. Now note that each label has a for attribute, and the value of this attribute is the ID of a given input field. For example, here, this label is referencing this input field. With this, when the user clicks on a label, the referenced input field automatically gets focus. Also note that our input fields have this class, form-control. Now back in our login form component, first we need to wrap this h1 with a div. Let me show you a cool trick. So I've selected this text and I'm going to press Shift, Command, and P on Mac or Shift, Control, P on Windows. This opens up the command palette. On the top, search for wrap with abbreviation. Enter. Now type the name of the tag you want to use to surround the selected text. For example, a div. See, now this text is surrounded with a div. We can also do Zen coding here. For example, we can say we want a div with the class container. And as you can see, that is reflected in JSX using the proper attribute, class name. Now we don't need this attribute, so let's delete that. All right, we have a div. Now we need a form. Inside this form, we need a div with the class form-group. Inside this div, we need a label. And next to that, we need an input with the class form-control. We need two input fields. So I'm going to select this div with the class form-group and all its children. Now I'm going to put this expression in parentheses and then multiply it by 2. Tab, boom. We don't need the action attribute, so let's delete that. Next, we need to set our labels. The first one is username and the second one is password. Save the changes. So this is what we have built. The next thing we need to assign is the for attribute. Note that because for is a reserved keyword in JavaScript, the name of this attribute is HTML form. For the same reason that here we cannot call this attribute class, because class is a reserved keyword, so we use class name. Now let me show you another cool trick. Here I'm going to assign this input field an ID. So ID, we set it to an empty string for now. Now whatever I type here, I have to copy and then paste it here. That is boring. Let me show you a better way. So I put the cursor right here. Now I'm holding down the Alt key and click right here. Now we have multiple cursors, so we can type a new ID like username. Beautiful. One more time for the second input field, I'm going to set the ID attribute, put the cursor here, one more time, and type a new ID like password. Done. And finally, we need a submit button. So a button with two classes, btn and btn-primary. We call it login. Save the changes. And this is what we get. By default, HTML forms make a full round trip to the server. Let me show you. So here I've got the network tab open on the right side. Let me clear the content of this tab and then submit this form. All right, look, we have a full page reload. Our HTML page as well as our bundle are downloaded from the server. That's not the kind of behavior we want in our React applications, right? So let me show you how to properly submit a form in React. Back to our login form, here's our form element. Every form element has an event called onSubmit. We're going to set this to handler. So let's call that handle submit. We set it to a function that takes an event object as an argument. This event object has a method that you have probably seen before. So e.preventDefault. This prevents the default behavior of this event. In this case, submitting the form to the server, which causes a full page reload. So we prevent the submission of the form. And then at this point, we will call the server, save the changes, and then redirect the user to a different page. For now, let's just do a console.log. Submit it. Finally, let's set our handler, this.handle submit. Now let's test the application. So one more time, I'm going to clear the network tab, submit the form. Note that we don't have any extra requests here. We don't have a full page reload. And if we look at the console tab, we see our message. Now when submitting the form, we need the value of our input fields. In plain or vanilla JavaScript, we can get the value of an input field like this. We call document.getElementById, by ID, pass the ID like username. This returns an input field. Then we'll access the value property. And with this, we can get the username. But this is not how we should access DOM elements in React. In other words, in React applications, you should never work with the document object, because the whole point of React is to put an abstraction over document object model or DOM. So we don't work with that directly. And with this, our applications would be easier to maintain and easier to unit test. But what if you really need to access a DOM element? In React, there is a way for that. In order to get access to this username element, we need to give it a reference. So first, in our component, we define a property. Let's call that username. And we set it to react.createRef. This will create a ref object. Now, Here in our input element, we set the ref attribute to this.username. Now, when submitting the form, if you want to get that username, instead of working with document.getElementById, we'll work with this.username. This ref has a property, current, which returns the actual DOM element. Now we can access the value property and get the username. So if you really need to access the DOM, that's the way to do it. But when building forms, there is a better way. We're going to look at that in the next lecture. But for now, let's just finish up the discussion about refs. So as a rule of thumb, you should minimize your use of refs. Use it only when you know what you're doing. For example, sometimes you want to manage the focus of an input field. You really want to get a reference to that DOM element. Or maybe you want to work with animations or third-party DOM libraries. In those cases, it's okay to use ref, but don't overuse them just to make things happen. So as an example, in this lecture, let's see how we can use ref to set focus on a given input field. So here in our component, I'm going to add a lifecycle hook. Component did mount. When our component is mounted, I want our username field to get focus. So this.username.current, this returns a reference to our DOM element, and then we'll call the focus method. Save the changes. Back in the browser, you can see our username field has focus. Now you may argue that there is a better solution here. So instead of defining a ref, adding a component lifecycle hook, and calling the focus method, we could simply use the autofocus attribute. So here's our input field. We could apply autofocus and note the capitalization. So F should be uppercase because all these attributes in JSX are named using camel notation. So if you type a lowercase f, you're going to get a runtime error. Now, we apply the autofocus here. And then to prove that this works, I'm going to comment out this lifecycle hook, save the changes. Back in the browser, our input field is still selected. So as you see, you don't always have to use refs. Use them only when you really have to. In the next lecture, I'm going to show you the proper way to work with input fields and get their value. When building forms, quite often our form components have a state that is initialized based on what we get from the server. For example, let's imagine instead of a login form, we were building a movie form. In our movie form, we need to call the server, get the movie with the given ID, store it in the state, and then populate the form. So here in our login form, let's add our state property, set it to an object. In this object, we want to have an account with two properties, username and password. For now, I've just initialized these to an empty string. Now save the changes. Back in the browser, let's type something in the username field. Now let's open up React DevTools. Then let's search for our login form and look at our state object. See what's going on here? We have this username property here that is completely detached from this username field. Because these input fields have their own state, whatever we type here is stored in the input field. To solve this problem, we should get rid of the state in this input field and only rely on this state object. We want to have a single source of truth. How can we do this? We should convert this element to a controlled element. Remember, controlled components, controlled elements are the same. They don't have their own state. They get all the data via props, and they notify changes to the data by raising events. So back to our login form. Here's our username field. We need to set the value attribute to this, that state, that account, that username. With this change, this input field is no longer going to have its own state. We're using props to set its value. So its value is always coming from state, account, username. Save the changes. Now back in the browser, note that if I type something here, nothing happens. The reason for this is because currently the username property in our state is an empty string, and because we have bound the value of this input field to our username in the state, it's always showing an empty string. To solve this issue, we need to handle the change event of this input field. Whenever the user types something here, that event is raised, and that's a good time for us to get what the user typed and update the state. Updating the state, as you know, will cause a re-rendering of this form, so our input field will be re-rendered with the updated state. Let me show you. So back to our username field, I'm going to handle onChange event and set it to this.handle change. Now let's implement this method. So handle change, we set it to a function that takes e or event as an argument. Now here we want to update the state, but as you have learned, we're not going to update the state directly. Instead, we want to clone it and then have React update the state. So let's create a new account. We set it to an object, use the spread operator to clone this.state.account. Then we set account.username to e.current target. That returns our input field, and then we can get the value property. And finally, we'll call this.setState and pass our new account object. Back to the browser. Now, I can type something here that perfectly works. In React DevTools, if we search for login form and look at our state object, you can see the username property of this account object is in sync with what we have in the form. So we have a single source of truth. However, in our current implementation, we're only updating the username property of our account. What about the password? We'll look at that next. In our handle change method, currently we are only setting the username property of our account object. It doesn't make sense to create another handler for the password property. So we want to set the property dynamically. And as I've told you before, whenever you want to work with properties of an object dynamically, instead of the dot notation, you should work with the bracket notation. So here we want to have a string that identifies the name of the target property. Where do we get that from? Well, we can give each input field a name property and then read it like this: e.currentTarget.name. As simple as that. So back to our input fields, let's set the name to username. And one more time for the password. First, we need to set value. We want to bind this to this.state.account.password. And of course, we can use object destructuring to clean up this code. We'll get back to this shortly. Next, we need to handle onChange. So onChange, we set this to this.handle change. And finally, we set the name attribute to password. Now, before going any further, let's use object destructuring here. So in our render method, I'm going to pick the account property of this.state. And then we can get rid of these repetitions. I've selected both of them. Delete. Beautiful. So now each input field has a name attribute, and in our handle change method, we read that to set the target property of the account object. Now, once again, you can see we have repeated e.currentTarget. In this implementation, we don't need any other properties of the event object. So we can destructure this argument like this. We pick current target and then rename it to input. And with this, we can select e.currentTarget and replace it with input. Isn't that better? That's much better. All right, now let's test the application. So A and B. And here in React DevTools, let's search for login form. Let's take a look at our state. You can see our account object is in complete sync with our login form. So now that you have learned how to build a form and keep it in sync with the state, let's take a look at a few common errors. First, I'm going to remove the username property. Let's see what happens. Back in the browser, we don't have any errors in the console, but the moment I type something here, we get this warning. A component is changing an uncontrolled input of type text to be controlled. Now, this error message might be confusing, but let me explain what's going on here. We removed the username property. So if we try to access account.username, we'll get undefined. Undefined and null cannot be used as values of a controlled element. In other words, here when we are setting the value of our username field, if we pass undefined or null here, React will not see this element as a controlled element. So this element is going to have its own state, it's going to have its own value, but the moment we type the first character, because we're listening to this change and we're updating the state, now account.username becomes A. So then we're passing A as the value of this input field, and that's why we get this warning. So initially we started with an uncontrolled element, and all of a sudden we're converting that to a controlled element. So that's the reason React is giving us this warning. It's telling us to decide between using a controlled or uncontrolled input element. So one way or another. We'll run into a similar issue if we pass null here. So as I said, null and undefined cannot be used as a value of controlled elements. So with this, when we load the page, we get a different warning. Value prop on input should not be null. Consider using an empty string to clear the component or undefined for uncontrolled components. So this is the reason initially I set username to an empty string. So as a rule of thumb, whenever you're building forms, you should initialize the properties of your state object either to an empty string or some value that you get from the server. In our current implementation, we have some duplication. For each input field, we should have this div with the class form group, as well as a label and an input field. And you can see some values are repeated here. For example, what we have for the HTML4 attribute of the label, that is username, is exactly the same for the ID and name attributes of the input. Do you see the pattern here? We have repeated the same pattern for the password field. So that's a good time to extract this markup and put it into a reusable component. So here in the common folder, let's add a new file, call it input.jsx. We import React on the top. And because we don't need state here, because we're working with a controlled component, we can create a functional component. We call this input, which takes props. Now we need to go back to our login form. Select this container div along with the label and the input, cut, and then paste it into our new component. All right, now let's make the necessary changes. So we have this username in 3 places. We want to replace all these with props.name. So that's the name of our input field. Or we can make this code better by destructuring this argument. So let's remove that, destructure it, and pick the name property. Now, wherever we have props.name, we can just use name. Isn't that better? Next, we need to replace this username with something we get from our props object. Let's call that label. So here we pick label as well. Save the changes. Good. We got a couple more changes to make. Here's one, account.username. We want to replace this with the value property of the props object. So one more time, let's add the value here. And finally, onChange. Again, we want to replace this with something from the props object. We call that onChange. So finally, let's add that here. So this is the interface of our input component. Now back to our login form. On the top, let's import this input component from current folder /common/input. Now back to our form. This is where we had our username field. We're going to replace this with input. Now we should set its props. So name should be username. Value should be account.username. Label should be username with a capital U. And onChange should be this.handle change. Save the changes. So this is the end result. You can see using this input is easier than this div with a label and input. So let's get rid of the password field as well. Instead, I'm going to duplicate this input, change the name to password, value to account.password, label to password with a capital P, and we leave onChange as is. With this change, our form is much easier to read and understand. We are not distracted by all those bootstrap classes. Almost every form that you build needs some kind of validation. So over the next few lectures, we're going to add validation to our form. Initially, we're going to validate upon submitting the form, but later I will show you how to validate as the user types something here or when they press tab and leave an input field. In terms of the implementation, in our state object, just like we have a property that includes all the data for this form, we're also going to have a property that includes all the errors in this form. Initially, we set this to an empty object, and if there are errors in the future, we will add properties to this object like this. Username, we set this to an error message like username is required or too short or whatever. So the properties in this object map to the name of our input fields. Okay. Note that here I'm using an object instead of an array because it's much easier to find the errors for a given input field. For example, with an object, we can find the errors for the username field like this. If we had an array, then we would have to call the find method and then pass a predicate like e goes to e.name equals to username. It's really ugly. So that's why we use an object here. Now, initially, we set this to an empty object. Now, in our handle submit method, here we're going to call a method like validate. So this.validate. This method will return an object that looks like this. So we get that object, errors, and then we call this.setState errors. So we'll update the state here, which will cause a re-rendering. And with this, we can render error messages. Now, we can assume that if there are no errors, this method is going to return null. So we can check. If we do have any errors, we're going to return immediately. So we won't call the server. Now let's build a very basic validate method. So validate, we set this to an arrow function. For now, let's just return an object like this. Username is required. We'll come back to this shortly. Let's test the application. Now I'm going to submit the form. Here in React DevTools, let's search for our login form component. Let's take a look at the state. You can see we have errors and username is set to this error message. In the next lecture, we're going to build a basic validation function. All right, now let's implement a basic validation. So here in our validate function, first, I'm going to define an object, errors, set it to an empty object, and then for each input field, we're going to write some validation logic like this. If this.state.account.username, we trim this. Now, if it equals an empty string, we're going to add a property in our errors object. So we said errors.username, we set it to an error message. Username is required. We need to repeat the same logic for the password field. So let's use object destructuring to clean up this code. We pick the account property of this.state and then get rid of this.state here. Now let's duplicate this for the password field. So let's replace both instances of username here with password. And also the error message, password is required. Now, this is a very basic validation. It's not very scalable. So later in this section, I'm going to show you how to replace this implementation with a more flexible and sophisticated one. For now, don't worry about these details. I just want you to understand all these building blocks and how they talk to each other. So for now, we're just checking to see if these input fields have a value. In your application, you might have some complex validation requirements. For example, you may want to check the value of multiple input fields to see if they are valid as a whole. So instead of checking to see if an input field has a value, you can implement your own custom validation rules. Now finally, instead of returning this object here, we should either return null if there are no errors, or this errors object. We can do something like this. Return object.keys. We pass our errors object. This will return an array of all the keys in this object. Now we look at the length property. If it's 0, we're going to return null. Otherwise, we'll return our errors object. Okay? Now, to test the application, here in our handle submit, when we call this.validate, right after that, let's do a console.log of errors. Save the changes, back in the browser. So I'm going to submit the form without any values here. This is our errors object. We have two properties, username and password. If I add something for username and submit the form again, now we get a different object. We only have the password property. And finally, if I also fill out the password, now we get null, so there are no errors and the form is submitted to the server. Beautiful. Next, I will show you how to display these validation errors. So here's the current implementation of our input component. This component is responsible for rendering the label and an input field. We're going to give the responsibility of displaying an error message related to this input field to this input component. So here, right after this input field, I'm going to add a div with two classes, alert and alert-danger. Again, these are both bootstrap classes. In this div, we want to render an error message. So on the top, we should get the error prop and render it here. Error. Now we want to render this div only if error has a value. So with this selected, let's put this in an expression. Here we prefix this with error and. So you learned this technique earlier when we talked about conditional rendering in the component section. So if error is truthy, then this expression will be returned. Otherwise, if it's falsy, this is going to be ignored. Okay? Now back to our login form. We need to pass this error prop to our input components. So right here, let's add error. We should set this to this.state.errors.username. Actually, it's better to use object destructuring here. So just like we pick the account property of the state object, we should also pick the errors property or the errors object and then use that here. One more time, I'm going to copy this line and apply it to our password field. But we should change username to password. Okay, save, back in the browser. So initially both fields are empty. Let's submit the form. We get two errors here. Let's fill out the username field, resubmit the form. That error is gone, beautiful. One more time, let's fill out the password field, submit. Oops, we got an error. Cannot read property username of null. And this happened on line 52. We can click here and this takes us straight to the code. So here we try to access the username property of null. The reason this happened was because in our handle submit method, this is where we call our validate method. If we don't have any errors, this errors is going to be null. So we set the state, and that's why we got this runtime error. To fix this issue, we need to change line 27 to something like this. So we're going to set the errors property to this errors object or an empty object. So if this is truthy, we'll use this object. Otherwise, instead of null, we'll use an empty object. So in other words, our errors property should always be set to an object. It should never be null, okay? Also, we no longer need this console.log. Let's delete that. Let's test the application one more time. So one more time, I'm going to submit the form. Good. Fill out both fields. Submit. We no longer get that error. Beautiful. Next, I'm going to show you how to validate a field as its value changes. To validate an input field on change, we're going to take a similar approach we took when submitting the form. So we should validate that input field and set the errors object accordingly. So here in our handle change method, right at the beginning, we need to do validation. But we are not going to call this .validate because this will validate the entire form. If the user is typing something here that is invalid, they should only see the validation errors related to this input field and not the entire form. So instead of calling the validate method, we should call another method that we're going to build in a second called validate property. We give it this input and it will return an error message. Now we need to update the state. So first we should clone the errors property of our state object. Const errors, we set it to a new object. Use the spread operator to clone this .state.errors. Now we have an error message. We can rename this to be more precise. Now, if this error message is truthy, we are going to store it in our errors object. So we set errors of input.name. So if the name of the input field is username, we're going to set the username property of the errors object. We set this to this error message that we get from our validation function. However, if we don't get an error message, we should delete the existing property so the error is cleared up. So we delete errors of input.name. And finally, here, when calling setState, we should also pass the updated errors object. All right, with this in place, now we need to implement this method. So let's implement it right here. Validate property. It takes an input. Now, once again, I'm going to implement a very basic validation. This is not the ideal way. Later, we're going to replace this validation with a better and more sophisticated implementation. So we need to check the name of the input field. If that equals username, here we're going to add all kinds of validations for this username field. For example, if input.value.trim equals an empty string, we should return username is required. Now, I know you're going to complain, but Mosh, we already implemented this earlier. I know, and as I told you, this is a very basic implementation. We don't want to get hung up on third-party libraries. I just want to make sure you understand the big picture before we look into the details. So here we could have other rules. It doesn't matter for now. Similarly, we're going to add a validation rule for our password field. But before duplicating this, I would like to improve this code. So you can see we have repeated this input in a couple of places. Once again, we can destructure this argument and pick name and value properties. And with this, we no longer have to repeat input. That is better. Now let's duplicate this and change it for the password field. So we change the error message as well. Beautiful. So we have two validation functions. One that validates only one property or one input, and the other that validates the entire form. Now let's test the application. So here, initially, our username is set to an empty string. That's why it's valid. If I type A, it's still valid. But if I remove this, we get this error message. Username is required. If I type something again, the error is cleared. So you have seen all these moving parts working together. Next, I will show you how to get rid of this ugly implementation. To implement validation rules, we're going to use a very powerful library called Joy. So search for npm joy with an I. Let's take a look here. On this page, you can see an example of using Joy. Basically, the idea behind Joy is to define a schema, which is a simple object. In this object, we're going to add all our properties and their validation requirements. For example, we can tell Joy that username is a string, it's alphanumeric, it should have a minimum of 3 and a maximum of 30 characters, and it's a required field. Similarly, we can apply regular expressions to strings. Similarly, we can say birth year should be a number, it should be an integer between these values, or email should be a string of type email. So it comes with a lot of predefined validators, but you can also add your own. So here in the terminal, let's install joy-browser. This is the implementation of Joy for browser. The version I'm going to use is 13.4. Okay, beautiful. Now let's go to our login form. Login form. On the top, we should import Joy from joy-browser. Now in this component, we should define a schema. The schema doesn't have to be part of the state because it's not supposed to change. So we set schema to an object. In this object, we need two properties. Username, we set this to joy.string. That's a method we need to call. And we can chain another method required. So we can define these validation rules in a fluent way. Similarly, we're going to add password. That's also going to be a required string. Now, at the time of recording this video, we don't have really good IntelliSense when working with Joy-browser. If you're working in Node, the IntelliSense is better. So we have a schema. Now we can validate our object using one line of code. So here in our validate method, let's call joy.validate. The first argument is the object that we want to validate. That is this.state.account. The second argument is our schema. So this.schema. Now let's take a look at the result. So I'm going to log it on the console. So let's submit the form here. All right, here's our result object. It has an error property. This error has details, which is an array. Currently in this array, we have only one item. That's the error for the username field. Because by default, Joy terminates validation as soon as it finds an error. This is what we call abort early. So to fix this problem, we pass another argument here and we set options. So we set abort early to false. Save the changes. Now back in the browser, let's submit this form one more time. Now look at error, details. In this array, we have two errors, one for username, one for password. Let's expand one of these objects. So each object has a message that you have seen, and it also has a pass that is an array. And in this array, we can find the name of the target property. So this is the object that we get as a result of validation using Joy. What we need to do is to take this complex structure and convert it into a simplified structure that our application understands. So in this component, we have assumed that we have an errors object, and in this errors object, we have 0 or more key value pairs where the key is the name of the target field and value is an error message. This is our simplified structure. So in the next lecture, I'm going to show you how to map the object that we get from Joy into our errors object. All right, so one more time, let's submit this form and look at the object we get from Joy. So here in the console, this object has an error property. This is only set if we have at least an error. Otherwise, error is going to be null. Now in this object, we have details, which is an array of objects. So the challenging part of this task is to map this array into an object. That is our errors object. So back to our validate method. On the top, we're calling joy.validate. We want to keep this, but I'm going to delete everything else here because we are going to rewrite this code from scratch. So we get the result object. If result.error is falsy, we want to return null. Otherwise, we have to get that array and map it into an object. So we define our object. Now we need to iterate over that array, and for each error message, we should add a new property to this object. So here's our details array. In this array, each object has a message and a path. These are the properties that we are interested in. This path property, as you can see, is an array, and the first element in this array is the name of our target property. So one simple implementation to map this array into an object is like this. For let item of result.error.details. So we iterate over this array. Now, each item has a path property, which is an array. The first element here is the name of our target property. So using bracket notation, we set errors of. Now, we're setting a property in our errors object. What is the value of that property? Is an error message. That is item.message. So this is how we can map an array into an object. Now, some developers don't like to use a for of loop. They prefer to use the map method of arrays. You can also use reduce. The implementations can get a little bit complex for some students. So for clarity, I'm going to stick with this for of loop. Finally, we'll return our errors object. Now let's test the application one more time. So I'm going to submit this empty form. We get 2 errors. Let's fill out the username. The error disappeared. Let's fill out the password. Submit the form again. Beautiful. However, there is a tiny issue here. Let me refresh this page. Submit the form again. Look at the capitalization of this name. We have username with a lowercase u. This is coming from our schema. But when displaying error messages to the user, we want to have friendly names. So here we can call another method, label, and assign a friendly name to this field, like username with a capital U. One more time for the password. Now save the changes. Back in the browser. Let's submit this one more time. The issue is gone. Beautiful. So we're done with re-implementing our validate method, but there are a couple of things I would like to improve here. Note that we're referencing result.error in a couple places. So it's better to use object destructuring to pick the error property. And with this, we can remove this duplication. That is better. The other thing I would like to improve is this third argument here. That looks a little bit ugly to me. For these first 2 arguments, we are referencing objects in this class, but then all of a sudden we have these curly braces, which look a little bit like a code block. And as you can see, our third argument has ended up on a new line. This is a little bit confusing. So I personally would like to define a new constant, call it options, set it to our third argument, that is an object with this property. Okay. Now, instead of passing this object here, I would like to pass options. With this, we don't have our third argument ending up on a new line, and our code is more expressive. All right, we're done here. Next, we will re-implement our validate property method. All right, now we're ready to re-implement this validate property method and get rid of these ugly if statements. So we're going to take the same approach we took in our validate method. So we should call joy.validate. Now, as the first argument, we cannot pass this .state.account because this will validate the entire account object or the entire form. In this particular case, we only want to validate one input field. So we should create another object. In this object, we should have only a single property. The name of that property should be set dynamically based on the value of this name argument. So if name is username, this object should have a property called username, and the value of that property should be what we get here, like this. But we don't want to hardcode username here. We want this to be set dynamically. That's where we use computed properties in ES6. So we replace this hard-coded key with square brackets and pass name. So whatever name is at runtime, that will be used to set the key. Okay? So we pass our object here. Now, as the second argument, we need to pass a schema. Once again, we cannot pass this.schema because this is the schema for the entire form. If we pass this simple object that has only a single property and validate it against this schema, Joy is going to scream at us, say, hey, this object doesn't have this property and that property and that property. So we need to give it a sub-schema, a simple schema with only one property. Let's take a look at our existing schema. So this is our schema object. So if you're validating the username field, we should have a schema object that has only this property. Okay, so here I'm going to define a new constant, schema. We set it to a new object. This object should have only one property. The name of that property should be set dynamically at runtime. Once again, we use computed properties. So we pass name here. Now, what is the value? The value is not the value of the input field. We should get this value from this schema object. So we go to this object, we find a property with the given name, and whatever its value is, we're going to reuse this value. So here, the value should be this .schema of name. Okay, so with this, instead of passing this .schema, we'll pass schema. Now, in this particular case, we don't need to pass the options argument for aborting early. That is unnecessary. In fact, we want to abort early because there might be, let's say, 3 validation errors with the given field. We don't want to display all those validation errors at once next to this field because from a usability point of view, that is confusing. It's better to display one validation error at a time. Otherwise, it's like the form is screaming at the user. Hey, this username should be a minimum of 3 characters and maximum of 10 characters and have a dot and 2 numbers. That is too much. So we don't want to abort early. Now, once again, this will return a result object. We'll pick the error property. Now, if error is null, we'll return null. Otherwise, we'll return error dot details of 0. We get the first detail. And as you remember, this object has a message property, so we'll return that. And of course, we can rewrite these last 2 lines using the ternary operator. So we'll return, if error is defined, we'll return error.details of 0.message. Otherwise, we'll return null. And with this, we no longer need these 2 statements. That is better. All right, let's test our form. So I'm going to type 1 character here and then delete it. We get our error message. Beautiful. So with Joy, we're defining our schema in one place. And unlike our previous implementation, we have not repeated the validation rules for each field. Now, chances are you might be a little bit confused about the implementation of validate and validate property methods. Don't worry about this because soon we're going to extract a reusable component so you don't have to re-implement these methods ever again. The only time you had to do this was during this course. In the future, whenever you build a form, all you have to do is defining the schema. That's all. And you will see that soon. Before we start our refactorings and simplify our implementation, I want to add one more feature to this form. I want this login button to be disabled unless the form is valid. So back to our login form. This is our login button. We should set the disabled attribute, disabled, to either true or false. So here we can call this .validate. As you saw earlier, this method will either return null or an object with 1 or more errors. If it returns null, null is considered falsy So it's similar to passing false here. Similarly, if this method returns an object, that object is considered truthy, so that is similar to passing true here. So with this simple change, now back in the browser, you can see initially our button is disabled. If we type something in both fields, it becomes enabled. If I remove the password, now we have an error and our button is disabled. Beautiful. Throughout this section, we have built this login form that has fair amount of code. We don't want to repeat all this code, especially the parts about validation, every time we want to build a new form. So in this section, we're going to quickly overview the code in this component and decide what parts we need to extract and put in a reusable component. So let's start with the state. What is reusable here? Well, we want every form to have this errors property in the state object. What about the schema? Is this reusable? Obviously not. This is specific to login. What about the validate method? Do you see anything about the concept of login in here? Absolutely not. This is a completely reusable piece of code. The only tricky part is the first argument we pass to the validate method. Here we're referencing this.state.account, but we're not going to have this account object in another form. Maybe we're editing a movie. So what should we do here? Well, we can come up with a convention and assume that in all our forms in the state object, we're going to have a property called data that represents the data behind that form. Here, that data should be set to an account object. In another form, data will be set to a different kind of object. With this simple convention, we can easily extract this validate method and put it in a reusable component. The same is true for validate property. What about handle submit method? Well, this one is an interesting one. The first part of this method is reusable because every time we build a form in React, we want to disable the default behavior. We don't want to post this form to the server. Also, every time the user clicks the submit button, we want to validate the data. And if there are any errors, we want to return. We don't want to continue. But what happens after is dependent upon the kind of form we're building. What about handle change? Again, here we are dealing with a reusable piece of logic because every time the user is typing something in an input field, we want to validate that input field, but we also want to update the state. Now, once again, here we're referencing the account object, but if we rename this to data, then we'll have a completely reusable piece of logic. And finally, the render method. Obviously, what we return here is dependent on the kind of form we're building. However, the last part here, this submit button, apart from the label, everything else is reusable. For example, we want to disable our button when the form is not valid. Also, we want to apply these two classes. So over the next few lectures, we will refactor this code step by step and extract a reusable form component. As I explained in the last lecture, the first thing we need to do is to rename account to data. So here I'm going to bring up the replace dialog. The shortcut on Mac is Alt, Command, and F, and on Windows probably Alt, Control, F. If you want to double check, it's right here under Edit menu, Replace. So anywhere we have account, we should replace that with data. Let's replace all. Beautiful. Now we're going to create a new component. We'll call that form. Then we'll move any reusable piece of logic into that new component. And then we'll have login form extend that new component instead of the component class in React. So it will inherit all the methods we have defined in its base class. Okay. So in the common folder, let's add a new file. We're going to call this form.jsx. On the top, we import React and create a class component called form. Now back to our login form. Every form should have a state, and in the state we should have data and errors properties. So back to our form class, I would like to initialize these properties like this: data, we initialize it to an empty object, and errors also should be an empty object. Good. Now back to our login form. We're going to leave schema here because that is completely dependent upon each form. But we're going to move this validate as well as validate property methods into our new component because they're entirely reusable. So cut, back to the form class, paste them here. Now, because we're referencing joy, we should also import joy on the top. So import joy from joy browser. Good. Now down the end, we don't need the render method here because this form component is not supposed to render anything. Okay, delete. Now back to our login form. What is next? Handle submit. As I told you in the last lecture, the first part of this method is reusable, but what happens after will change from one form to another. So here we can do a simple refactoring like this. We can add a new method, do submit, and move these last two lines into this new method. And then in handle submit, we call this .do submit. Now look at this implementation. Do you see anything specific to the concept of logging in? Of course not. This is completely reusable. So we cut this and move it to our form class right here. Okay. What else? Now we have handle change. Once again, this is entirely reusable. So let's select it and move it to our new form. I believe we're almost done. Let's go back and double check. So we're left with the render method, which is obviously specific to each form. So we moved all the reusable methods to our form class. Finally, we need to have our login form extend the form class. So on the top, let's add form here. And of course, we should import it on the top from common/form. All right, save the changes. Back in the browser, you can see our submit button is disabled. I type A here, remove it. Our validation is working. Let's fill out both fields. Now we have login, click, and we get this message, submitted. Beautiful. So with this refactoring, we simplified our login form. Next time we want to build a form, we don't have to write all that code from scratch. All we have to do is to initialize the state, set the schema for that form, determine what should happen when the form is submitted, and finally decide what to return when the form is rendered. But wait a second, we are not done yet. In the next lecture, I'm going to show you how to simplify the implementation of this render method. Here in our login form, look at the submit button. Apart from what we have here as a label, everything else should be exactly the same in every other form. So we can add a helper method in our form class for rendering a submit button with a given label. So I'm going to select this markup, cut it, back to our form class. Let's add a new method here. Render button. We give it a label and return this markup. Finally, we replace login with label. That's it. With this, we can go back to our login form and call this .render button, give it a label, login. Save the changes. And here's our button. Beautiful. Now look at our input fields. We have a repetitive pattern here. For example, the name that we set here, in this case, username, we have a property with the exact same name in our data and errors objects. Also, for every input that we add to this form, we should handle the onChange event. If we don't do this, our form will not be in a valid state. Because as you learned earlier, whenever the user types something into this form, we want to make sure that the state is updated. We don't want to remember to handle the onChange event. So, similar to how we extracted a method to render the submit button, we're going to extract a method for rendering an input. So let's select one of these inputs, cut, back to our form, add a new method here, render input. And here we return this markup. Now let's see what we need here. First, we need a name parameter that we're going to use here. So let's add name and replace this username with name. Now, as you can see, we have a property with the exact same name in these two objects. We can get rid of these and use bracket notation to simplify this code like this. So data of name and errors of name. Isn't that better? That's much better. What else do we need here? A label. So let's add a label parameter and render it right here. We're done with this method. Now back to our login form. Here we call this that render input. The name is username and the label is username with a capital U. Now let's get rid of this second input and duplicate this line. Finally, let's replace both these usernames with password and also change this P to an uppercase P. Now look at our render method. Isn't that beautiful? Only a few lines of code. As you can see, we no longer need data and errors here. In fact, we need to move this line into our render input method. So cut, back to our form. This is where we're referencing data and errors objects. So let's extract them from the state. And one last thing, because we're referencing the input component here, we need to import it on the top. So import input from the current folder / input module. Save. Now back to our login form. On the top, we no longer need the input component, so let's delete it from here. That is better. So here in the browser, you can see both our inputs are rendered. Now, one more thing before we finish this lecture. As you can see, the password is in clear text, so let's fix this issue. Back to our form class, we should add a new parameter here, call it type, and pass it to our input component. So type equals type. Now we can give this a default value because most of the time we want an input of type text. We don't want to type it every time. So let's set this to text. Now, if you want to change this somewhere, we can always do so. So save, back to our login form. Here in the render method, for the username field, I'm not going to pass the type argument because I want to rely on the default value. But for password, I'm going to set the type to password. So here in our form, we're passing this prop to our input component. Now let's go to this component and apply the type prop dynamically. So input. As you can see, here we have set the type to text. Instead, we should set it to the type parameter in this method. So let's add type on the top. Beautiful. Save the changes. Let's see if this is working. It is. Beautiful. So we have fixed this issue, but we have a tiny issue in this implementation. Every time we want to apply a new attribute to this input, we have to add it on the top and then explicitly set it here. Also, as you can see here, we have a repetitive pattern. Value equals value, unchange equals unchange, name equals name, type equals type. I'm going to put all the attributes that follow this pattern next to each other. So here we have type. I'm going to move this up. Then we have name. I'm going to move this too. So in this method, there are 3 parameters that we specifically need. One is label, because we should use it here. The other is name, because we should use it for this attribute, as well as the name attribute of our input. And finally, error. Any other attributes, we can automatically pass them by using the res operator. Let me show you what I mean. So on the top, I'm going to extract name, label, and error, and delete everything else. So delete, delete, and delete. So we get name, label, error, and here we use the REST operator to get the other properties from the props object. Now here in our input field, I'm going to delete the initialization of value on change and type. So delete, and use the spread operator to initialize them. So here we had an object, we spread the res parameter, and this is exactly equivalent to the code that we had earlier. Now save the changes. With this change, our input component is simpler, and next time we want to use it somewhere, let's say we want to pass an additional attribute, we don't have to come back here, extract that parameter, add that parameter to our object destruction list, and then specifically set that here. By using the REST and spread operators, we can automatically set any other attributes that are in our props object. Actually, I made a tiny mistake here. Make sure to include the name attribute here, because if you don't include this, it's not going to be part of this res parameter, because this res parameter includes any other properties other than name, label, and error. So when we use the spread operator to spread this res parameter, we're not going to include name. So make sure to add name here. All right, time for exercises. Here's the first exercise for this section. I want you to build a register form like this. So we have 3 fields, username, password, and name. Username should be a valid email. So as soon as I type something here, we get this alert, username must be a valid email. So let's change that to something like this. The error is gone, beautiful. The password should be minimum 5 characters. So if I type ABC here, we get this error, password length must be at least 5 characters long. Let's add a couple more, beautiful. Note that our register button is disabled because the form is invalid. The moment I type the name, the button becomes enabled. Now note that in this section, we're not going to register users. That's going to come later when we talk about authentication and authorization. So for this exercise, all I want you to do is to build this simple form and also add a link on the navigation bar. Just to let you know, in this section, I'm not going to type the solution by hand because a lot of these materials are repetitive, and honestly, I don't want to waste your time typing the same thing over and over. Instead, I'm going to show you my code and do a quick review. If there are areas that require discussion, I will talk about them in more detail. Also, if you want to study my finished source code, you can download it from the first lecture of this section. So go ahead, spend 15 minutes on this exercise. When you're done, come back, continue watching. All right, let's take a look at my register form component. As you can see, this component extends our form component that we have built in this section. Here's our state. We have data with these 3 properties, as well as errors. Pretty straightforward. Let's take a look at our schema. We have username, which is a string, it's required, and it's an email. Password is also a string, it's required, and it should have minimum of 5 characters. And finally, name is just a required string without any other restrictions. Here's our doSubmit method. All we're doing here is logging something on the console. And finally, our register form. Again, pretty self-explanatory. This is exactly like our login form with an additional input, that is our name input. Also in app.js, I have registered a new route. So that is right here. And as you can see, for this route, we'll render our register form component. This next exercise is more challenging and is going to take about 30 minutes of your time. But I highly encourage you to dedicate yourself to this exercise because the challenges you're going to go through are very similar to the challenges you see in the real world. So if you can't finish this exercise successfully, you're not going to be able to work on a real React project. So as you see, I have added this new button here, new movie. When we click this, we go to /movies/new. Here we have a form with 4 fields: title, genre, which is a drop-down list, number in stock, and rate. As you can see, our save button is initially disabled because the form is invalid. We can fill out the form, add a new movie like my new movie. Set the genre, number in stock, which should be a number between 0 and 100. So if I put in -1, it's going to complain. So let's set this to 5. And rate, which should be a number between 0 and 10. So if I type in 11, once again, we're going to see a validation error. So let's set the rate to 2.5, press enter, we save the changes. Obviously, changes are not saved on the backend in a database, they're entirely in the memory. Now, because this table is sorted by the title, our new movie is not on the first page, it should be on the second page, right here, my new movie. We can click this, go back here, make changes, let's add a plus here, change the genre to comedy, number in stock to 2, and rate to 3.5. Once again, press enter, go to the second page, it's right here, you can see our changes are reflected. We can also delete this, and it's gone. Now previously, we didn't fully implement this delete action. If you look at the handler behind this button, it only removes it from this table, but not from our data source. So if you go back and add a new movie, come back to this table, you will see that the movies you deleted are still there because they are not removed from the movies array. And one last thing, let's go to this movie, Terminator. Now if I change the ID here to an invalid movie, we get redirected to the not found page. And if we click the back button, we go back to the movie form populated with Terminator. So I want you to treat this like a real-world task. Imagine you're working with me, you're part of a team. I briefly explained the features I want you to add to this application. So take a note of these new features and implement them one by one. Now, before you get started, I just want to give you a hint. I have deliberately put 2 bugs in our fake movie service, and it's your job to find and fix those bugs. Otherwise, some of the CRUD operations around movies will not work. So go ahead, spend 30 minutes on this task. When you're done, come back, see my code. All right, now let's take a look at my solution. So in movies component, here in the render method, just above our table, I have added this link to /movies/new. I've applied a couple of bootstrap classes to make it look like a button. And also there is an inline style to add a bit of margin. This is purely a temporary solution. In the future, we can come back and revisit this. Now, let's take a look at our movie form. So as we can see, this movie form extends our form class. In the state, we have data. Here in the data, we have title, genre ID, number in stock, and daily rental rate. Note that here, I've called this second property genre ID because this is specifically the ID of a genre, not the entire genre object with ID and name. So when the user selects a genre here, all we care about is the genre ID. That's why I've specifically called this property genre ID. Here we also have genres, which I have initialized to an empty array. Later, as you will see, in component.mount, we'll get the genres from our imaginary server. And we also have errors just like before. Now let's take a look at our schema. So we have underline ID, which is a string. I didn't set this to required because when creating a new movie, we don't have the ID property. I've set title to a string. It's required. Pretty basic. Genre ID is the same. Number in stock and daily rental rate, they're both numbers and they have a range. So number in stock is minimum 0 and maximum 100. So pretty straightforward. Next, let's take a look at component.mount. So first we get genres from our fake genre service and then update the state. Next, we'll read the ID parameter in the route and store it in a constant called movie ID. If that equals to new, we'll return immediately because we don't need to populate the form with an existing movie object. So if the ID is not new, we'll get the movie with the given ID. The chances are that movie does not exist So we need to check for that. So if it doesn't exist, we're going to redirect the user to /notfound. Note that here, instead of using history.push, I have used history.replace, because if you use history.push, when the user clicks the back button, they will get back to this page with an invalid movie ID. And then again, they will get automatically redirected to the not found page. So they will end up in an infinite loop. They can never click the back button to go back to where they used to be. Also, note that I have used the return keyword here, so the rest of this code in this method will not be executed. Don't assume that just because we are redirecting the user somewhere else, the rest of this method will not be executed. You can do a console.log and see whatever you write here will be executed. So here basically we are updating the state, we're setting the data property, but we are not setting that to the movie object we get from the server. This is a very typical real-world scenario because the RESTful APIs that we have on the server are general purpose. They are not built for a specific page. So the data that they return is often used on several pages. Now each page needs a piece of that data, and it is also possible that what we want to display on the page is a little bit different from the structure of that data. So that's why I've defined this method here, map to view model. So this method gets a movie object that we get from the server and maps it to a different kind of movie object that we can use on this form. We refer to that kind of movie as a view model. It's a model for the view. So here basically we are returning a new object, and look at our transformation. We're setting ID to movie.id, title the same, but we don't have a genre property here. We have genre ID, which is mapped to movie.genre.id. So the movies that we get from the server, they are hierarchical. They have nested properties. They have more data than what we need. So here we only need the genre ID. That's why we're mapping it to movie.genre.id. And similarly, we're mapping number in stock and daily rental rate. Pretty straightforward. Let's move on. Here is our doSubmit method. So when the form is submitted, we call the save movie function. This is another function in our fake movie service. So we give it our movie object, our view model, which looks exactly like what you see here. So we save the movie and then redirect the user to /movies. Pretty straightforward, except that I have defined a new method in our base class. So previously we implemented render input. Now I have implemented render select, which basically renders a drop-down list with this name, with this label, and these options. Let's take a quick look here. So I'm going to go to the form component. Let's search for render select. Very, very similar to what we have built before. So I've defined a new component called select, and here I'm initializing that component, setting name, value, label, options, as well as onChange and error. So the job of these helper methods like render select, render input is to return the right component and hook into the onChange event. Without these helper methods, we have to manually set onChange every time. Now, if you look at the implementation of select, again, it's pretty self-explanatory. So just like the input, we have a div with the class form group, we have a label, but instead of an input, we have a select. Below that, we have an empty option, and then we'll map all the options that we get into option elements. Now, you could argue that what we have here is a little bit similar to what we have in our input component. So in both these components, we have this div with the class form group, we have a label, and then after that, we have an alert. So you might be wondering why I didn't refactor that component and conditionally render a different kind of input depending on the type. That would certainly work, but if you look at other kinds of inputs like checkboxes and radio buttons in Bootstrap, you will realize that those fields don't quite match this structure. So if you want to support those kind of input fields, then you will end up with a lot of if, else. That would make your code look really ugly. So that's why I decided to separate these two components despite having some similarities. After all, software engineering is all about trade-offs. There is no perfect solution. Here, yes, we have a little bit of code duplication, but I believe our code is cleaner and easier to understand than having one component like input that would support all kind of input fields. And finally, let's take a look at the 2 bugs that I have fixed in our fake movie service. So fake movie service. So down the bottom, here's one bug. So in our save movie function, we get a movie from our movies array. Previously, we had the name property here, but our movies have a title property. So that's one line that I fixed. And also on line 87, previously we didn't have this toString here. And with this, we could not edit a new movie. So we're done with this exercise. If you want to examine my code in more detail, you can download it from the first lecture of this section. On our movies page, I wanted to add a search box to search for movies by their title. So here I can search for The, and as you can see, we have 2 movies that start with The Avengers and Sixth Sense. Note that our search is case insensitive, so here all my letters are lowercase. Also, if I select a genre on the left side, and then search for a movie, that selected genre disappears. Because when the user types something here, they don't care what genre this movie belongs to. They just want to find a movie with this given title. So we don't want to force them to go select all genres and then type something here. We automatically clear the selected genre. For the same reason, if the user has typed something here and then selects a genre, that search query is cleared. So in other words, when filtering movies, we should either filter them by the selected genre or a search query, but not both of them. Otherwise, this is going to be confusing for the user. So go ahead, spend about 15 to 20 minutes on this exercise. When you're done, come back and let's look at my solution. So in our movies component, right above the movies table, I have added a new component, search box. This search box is a controlled component, so it doesn't have its own state. It gets all the data via props and notifies changes by raising events. Instead of building this component, I could simply add an input field here, but I decided to encapsulate that input field inside of a search box so we would have a simpler interface to work with. Let me explain what I mean. Look at this onChange event. It's handled by this method. Let's have a look at this method. So handle search. Here's the method. Note that it gets a query. This is a string. If I added an input field in this form, this handler would get E, short for event. Then we would have to do something like e.currentTarget.value. That's boring. And then we'll have to repeat this every time. So that's why I put this input field inside of a component. This component raises an event. In the handler, we get a string. That is the query that the user types in the input field. Now in this handler, we're setting the state. So we set the search query to what we get here. Also, we reset selected genre for the reason I explained to you. And we also set current page to 1. If we don't reset the current page, it is possible that the user might be, let's say, on page 3. Then they search for something, and let's imagine we only have 1 page of result. If the current page is still on 3, the user will not be able to see the search result. Okay? Also, I have modified handle genre select. So if the user selects a genre, we set that here, and at the same time, we reset the search query to an empty string. In case you're wondering why I didn't set this to null to be consistent with the code below, the reason for this is because here we're dealing with a controlled component, that is our search box. So earlier you learned that when you're working with control elements or control component, you cannot use null or undefined. Otherwise, React thinks you're working with an uncontrolled component. So the moment the user types something in an input field, React is going to get confused, thinking you're trying to convert an uncontrolled component into a controlled component. Also, here on the top where we initialize the state, I initialized search query to an empty string. And I also added selected genre. Previously, we didn't have this before, and our page worked perfectly fine, but I decided to list all these parameters here and initialize them, so the next developer reading this code doesn't have to do much guesswork. Everything is well documented in the code. Now let's take a look at the implementation of our search box. So we have a simple, stateless, functional component. Here we're returning an input, give it a name, a couple of bootstrap classes, form control you have seen before. This one, my-3, that is short for margin. Why? So we're applying margin on the y-axis, which means top and bottom. And 3 is the amount of margin. We also have a placeholder. We set the value based on what we get from our props object. And finally, we handle the onChange event. And here, basically, we raise a custom event with the value of the input field. So this is how we are simplifying the interface of an input field. Next time we want a search box, we don't have to repeat all this code. We simply use our search box component. So this is the big picture. Now back to our movies component. Let's take a look at get page data method. In this method, we filter, sort, and paginate data. I have changed our filtering logic. So previously we had a constant called filter. I changed that to a variable. So initially we set filtered to all movies. Now, if you have a search query, we call all movies.filter, where m goes to, now we get the title of the movie, convert it to lowercase, and check to see if it starts with this search query in lowercase. Otherwise, if we have genre, we filter movies by the selected genre. So this part is exactly like before. Now, personally, I'm not quite happy with this implementation. I think all this logic around searching and filtering is a little bit ugly, maybe more than a little bit. In the future, I'm going to show you how to simplify this implementation using a custom collection. As I told you at the beginning of the course, every application has a front end and a back end. So far, our focus has been purely on the front end. So none of the applications we have built so far had a back end. Now, building a backend is an entirely different topic and it's beyond the scope of this course. However, as a React developer, you need to know how to connect your React applications to a backend. And that's the topic for this section. So I want you to download the zip file I've attached to this lecture. In this zip file, you will find a folder called HTTP app. Now here in the terminal, let's go to this folder, run npm install, and then start the application with npm start. This is what you should get. We have a single page with a button for adding a new post, and below that we have the list of posts that we can update and delete. We're going to use this simple application for the demos in this section. Are you ready? Now, in the last lecture, I told you that as a React developer, you don't have to worry about building the backends. That's the job of a backend or a full stack developer. So in this section, we're going to use a fake backend called JSON placeholder. So head over to jsonplaceholder.typicode.com. As you can see here, JSON placeholder is a fake online REST API. What is REST API? Well, REST stands for Representational State Transfer, and API stands for Application Programming Interface. That's too much jargon, right? So let me make it super simple for you. This website provides a bunch of endpoints that are publicly accessible over the internet. You can send HTTP requests to these endpoints to get, create, update, and delete data. We refer to these endpoints as APIs or Application Programming Interfaces. So they give you an interface to use in your applications. Let me show you. So if you scroll down, under resources, you can see all these endpoints. We have endpoints to work with posts, comments, albums, photos, to-dos, and users. Let's take a look at one of these. So posts, note the URL in the address bar. So we have JSON placeholder.typicode.com/posts. That is the posts endpoint. When we send an HTTP request to this endpoint, this is what we get. We have an array of objects. Each object is a post object. It has 4 properties: user ID, ID, title, and body. The chances are what you see in this video is different from what you see on your machine. Here we have proper formatting and color coding. This is because of an extension I have installed here. Let me show you. So that extension is called JSON View. So if you add this to your Chrome, you will also see all the JSON data properly formatted. So when we send an HTTP request to this endpoint, we will get an array of posts. Now, using the same endpoint, we can also create, update, and delete a post, as you will see later in this section. So to recap, JSON placeholder gives us an API or application programming interface. This API consists of a few endpoints like this post endpoint we have here. Using these endpoints, we can send HTTP requests to these endpoints to create, read, update, and delete data. We refer to these actions as CRUD operations. So you have learned that in React, we need to send HTTP requests to a backend to get or save data. But how can we do that? Well, as I told you at the beginning of the course, React is just a simple, lightweight library for building user interfaces. All it cares about is rendering the view and managing the DOM. It makes sure that what we have in the browser DOM is in sync with the state of your application. That's all React does, nothing more. So React does not have an opinion about how to send HTTP requests to the server. And this is one of the good things about using React. You can use the libraries that you prefer to send HTTP requests. In contrast, if you have worked with a framework like Angular, you know that in Angular, we have an HTTP module for sending HTTP requests. And if you have been programming in Angular for a while, you know that that HTTP module has had several breaking changes and it's really a pain in the neck. So when using Angular, you have to do things the Angular way. But when using React, you have freedom. You have the flexibility to choose the libraries that you prefer. So what are our options here? Well, most modern browsers have the ability to natively send HTTP requests using the Fetch API. This API was introduced in the recent years and is pretty much implemented in most, if not all, modern browsers. The other option is jQuery Ajax. Chances are you have already worked with this library before. So if you're comfortable using jQuery Ajax, you can bring it to your React applications and use it to send HTTP requests. There is also another very popular library called Axios. Axios is a Greek word which means worthy of or suitable. And that is my preferred way to send HTTP requests in a React application. If you prefer to use the native Fetch API in browsers or jQuery Ajax, that's perfectly fine. In this course, I'm not going to waste my time or your time comparing all these solutions and discuss their advantages or disadvantages. You can read about them on your own. So here in the terminal, let's install Axios version 0.18. Now you might be wondering why I'm using Axios even though it doesn't even have a version 1. Well, if you look at NPM, you can see the number of weekly downloads for Axios is over 2.4 million. So it's a very, very popular library for sending HTTP requests. So go ahead and install this. In the next lecture, I will show you how to use Axios to get data. So we have installed Axios. Now we want to use that to get the list of posts from our backend and then display them here on this table. So in VS Code, let's open up app.js. On the top, we should import Axios from Axios. Now, earlier in the course, I told you that the right place to call the server and get some data is in component did mount lifecycle hook. So here in this component, type CDM, that is short for component did mount, enter, here it is. Now we call Axios.get to send an HTTP request and get some data. The first argument is the URL. What is this URL? That is the URL of our posts endpoint. So let's copy this and then paste it here. Now this method returns a promise. So let's store that here. What is a promise? A promise is an object that holds the result of an asynchronous operation. An asynchronous operation is an operation that is going to complete in the future. You know that when we send an HTTP request, there is going to be a delay until we get the result. It doesn't happen immediately. There's always going to be a delay, maybe 5 milliseconds, maybe a second, or even longer. So this promise object promises to hold the result of an asynchronous operation. When we create a promise, initially, it's in the pending state. Now, when the operation completes, that state will change to either resolved in case of success or rejected in case of a failure. Let's have a quick look at this promise in the console. So console.log of promise. Save the changes. Back in the browser, here's our promise. You can see at the time we logged it, it was in the pending state. However, when we expand it, we can see its status is changed to resolved. That means this asynchronous operation completed successfully. Now these square brackets you see here represent an internal property. So here promise does not have a property called promise status that we can access using the dot notation. This is an internal property. Similarly, we have another internal property, promise value, and this is the actual object that we get when our asynchronous operation completes. In this case, that is the response that we get from the server. So this response object has a few properties like data. You can see here we have an array of 100 posts. These are the posts that we're getting from JSON placeholder. We also have another property, headers. These are the HTTP headers that the server sends to the client. We also have request, which is the original request. We have status, 200, which indicates success. Now, how can we get this response from our promise? Well, this promise object has a method called then. With this method, we can get the result of an asynchronous operation. But this is the old way of doing things, and I don't want to waste your time showing you poor way of doing things. In modern JavaScript, we have a keyword called await. So we can await this promise and get the actual result. So we store the result here in a constant. That result is actually a response object. Now, whenever you use the await keyword in a function, you should decorate that function with the async keyword. So here we should decorate this function or this method with the async keyword. Now let's log this response on the console like this. Back in the browser, here's the actual response we get. Beautiful. But there is a cleaner way to write this code. Here we don't really need this promise constant. We can simply await the result of the call to axios.get and get the actual response object. So we await this, get the response, store it here, and then we don't need the second line. So we have the response. Now this response has a property called data, which is the array of posts we get from the server. So here we can use object destructuring to get data and rename it to posts. Finally, we call this .setState to update our posts. Done. Save the changes back in the browser. You can see our table is populated with the posts we got from the backend. Beautiful. Next, I'm going to show you how to create a new post. In this application, we have this add button for creating a new post. Now, in a real-world application, we probably have a form somewhere. The user fills out that form and then clicks the save button. At that point, we need to create an object and send it to the backend for persistence. So on the backend, we'll get this object and store it in a database permanently. So now let's simulate this scenario. Back in our app.js, Here we have this event handler, handle add. In this method, we want to create a new object. So object. As you have seen, our posts have at least two properties, title and body. So I'm setting these to arbitrary values. Now we want to send this to the server. So once again, we're going to use Axios for that. But this time, instead of using the get method, we'll use the post method. We use get for getting data and post for creating data. So Axios.post. Now the first argument is the URL of an endpoint. We're going to use the exact same URL. We don't want to duplicate this in multiple places. So let's cut this from here and store it in a constant called API endpoint. Now we can reuse this in multiple places. So back in component.mount, I'm going to pass that as the first argument to the get method, API endpoint. And similarly, in handle add, we're going to pass that to Axios.post, API endpoint. Now here, because we are creating data, we need to include this data in the body of the request. So we need to send this object to the server. So we'll pass that as the second argument to this method, object. Now similarly, this method returns a promise. So we should await it to get the response. Now, just like before, we use object destructuring to pick the data property and rename it to post. Because in this case, when we send an HTTP request to create a new post, the server or the backend will respond with the newly created post, not the entire list of posts. Okay. Now, because we have used the await keyword here, we should decorate this function with the async keyword. So we put async here. Note that here we have two different syntaxes. So component.mount is just a method in this class. That's why we put async here. But handle add is basically a property that we're setting to a function. That's why we apply async here and not here, right? So this is how we create data. Finally, let's log this new post on the console. Save the changes, back in the browser. Let's click add. Beautiful. So here's the object that we get from the server. It has the properties that we send to the server, title and body, but it also has an ID, which is the ID of this newly created post. That is 101. Now note that if I click add multiple times, the ID comes back as 101 or 102. It's not reliable because this is a fake service. So it doesn't return a unique identifier every time you create a new post. So we have sent our post to the server. Now we need to add this to our table. That is pretty easy and we have done this before. So we create a new array, posts. We want to add this new post at the beginning of this array. So we add that here and then we'll spread this .state .posts. And finally call this .setState posts. All right, let's test the application. So I'm going to click this and here's our new post. Beautiful. Now note that if we click this multiple times, we get this warning on the console, encounter two children with the same key 101. This is because these objects don't really have a unique identifier. Ignore this warning in this application. In a real application with a proper backend, you're not going to see this warning. Now let's see the life cycle of a request in action. So open up Chrome Developer Tools. Here on the Network tab, clear what we have here. Now back on the web page, click Add to add a new post. Now back on the Network tab, we can see we have two requests here. One with the status 204, the other with the status 201. Let's look at the first one. Here on the Headers tab, you can see the request URL is set to our post endpoint. Request method is set to options. What is this? every HTTP request has a property called method that determines the intent of that request. The common methods we have are get for getting data, post for creating data, put for updating data, and delete for deleting data. Now back here, we have an HTTP options request. The reason we have this request here is because this application is hosted at localhost, but its backend is hosted somewhere else, jsonplaceholder.typicode.com. These are two separate domains. So for security reasons, whenever an application sends an AJAX request to a different domain, the browser always sends an options request. That is why we have this request here. Now let's take a look at the second request. This request is again sent to the same URL, but our request method this time is post. And as I told you earlier, post is used for creating data. The status of this request is 201, which means a resource was created. Now if you scroll down the bottom, on the request payload, you can see the object that we sent to the server. That is our post request with title and body properties. Now, if you look at the response tab, you can see the response that JSON placeholder returned to us. We have a request object. It has the same properties we sent to the server plus a new property. So Axios wraps this object in a response object. That response object has a data property that we picked using object destructuring syntax. But that response object has additional properties that we can use to read the status of the response, the headers, and so on. So this is the life cycle of a request. Next, we're going to look at updating data. All right, now let's take a look at updating data. So here in handle update method, we get a post object. Let's say we want to change the title of this post. So we update it like this. So we have modified an object in memory. Now we need to send this object to the server or to the backend for persistence. So once again, we use Axios for that. But here we have two methods for updating data. We have put and patch. What is the difference? We use patch to update one or more properties, or put to update all properties. Let me show you. So first I'm going to use put. Now, as the first argument, once again, we need to pass the URL, but this time our URL is a little bit different. So we have API endpoint. This references the entire posts collection. But in this case, we're updating a specific post, so we should include the post ID in the URL. So back here, we have our API endpoint. Let's append a slash and then post.id. Of course, a better way to rewrite this is using template literals in ES6, but for now, let's just not get hung up on these little details. Now, as a second argument, we need to pass the data to be sent to the server. When using the put method, we should send the entire post object, so we put that here. In contrast, if we use the patch method, we don't have to send the entire post object. We can send only one or more properties, and these are the properties we want to update. For example, let me duplicate this. We can call patch, and here, instead of sending the entire post object, we send a custom object that has the title property set to post the title. So we are sending only the properties that should be updated. That is the difference between put and patch. Now, we don't need this here, so let's delete this. So we call put, we get a promise, we should await that, and also apply the async keyword here. We get the response, we can pick the data property, and then we can log this on the console. Let's have a quick look. So here I'm going to update the first post. This is the object we get from the server. So the server returns the entire post object. We have body, ID, title, which is updated, and user ID. In order to update an object, or more accurately, a resource, we send an HTTP request to a given endpoint. In that endpoint, we have the ID of that resource. The server gets that ID and the object we put in the body of the request, and then returns that object or that resource in the body of the response. Now, in this example, we're not going to use this object. So to simplify the code, I'm going to delete this constant. So we have sent our post object to the server. Finally, we need to update the UI. So just like before, we need to clone our posts array. We create a new object and spread this.state.posts. Next, we need to find the index of this post in this array. So constant index, we set it to posts.index of post. Now we go to that index, so posts of index, create a new object, and then spread the post argument. And finally, this.setState, we pass our posts array here. Save the changes. Let's test the application. So once again, I'm going to update the first post. You can see the title is changed. Let's try another one. Beautiful. Next, I'm going to show you how to delete data. And finally, let's look at deleting data. So once again, we use Axios. This time, we're going to call the delete method. Now, the URL is exactly the same URL we used for updating data. So we start with API endpoint and then append the post ID. Now, when deleting a resource, we don't need to include anything in the body of the request. All we need is the URL that identifies this resource. So finally, let's await this and then make this async. Okay. So at this point, our post is deleted from the server. So now we should remove it from our table. This is pretty straightforward. So we create a new constant, posts, and set it to this.state.posts. We use the filter method. We get a post and compare its ID with the ID of the post we're deleting. So post.id. So we want all posts except the post that we're deleting. And finally, we should call this.setState and pass this new posts array. Done. Let's test the application. So here I'm going to delete the first post. Gone. Beautiful. So we have implemented all the CRUD operations, but there is a small issue in our current implementation. Note that when I click the delete button, it takes about a second until this post is removed from our table. Have a look. Delete. It took about half a second or a second. It wasn't immediate. We have the same issue when updating a post or adding a new post. There is a delay until we see the result. And here's the reason. The reason is that in our current implementation, we're always calling the server first, and then we're updating the view or the UI. With this implementation, if an error occurs while calling the server, the rest of this function will not be executed. This is what we call pessimistic update. So we are not sure if the call to the server is going to succeed or fail. In contrast to pessimistic update, we have optimistic update. So we can assume that most of the time, the call to the server succeeds. So instead of calling the server first, which is going to take some time, we're going to go ahead and update the UI, and then we will call the server. Now, if this call fails, we can revert the UI back to its previous state. Let me show you how to implement this. So first, I'm going to move these two lines up. So we're going to update the UI first and then call the server. Save the changes back in the browser. Now, when I click the delete button, this post will be immediately removed. Have a look. Delete, delete, delete. So even though the call to the server still takes about a second, this implementation gives the user the illusion of a fast application. But we are not done yet. So what happens if something goes wrong? We need to undo the most recent change. In React, this is pretty easy because we never update the state directly, so we can always have a reference to the previous state. So here on the top, I'm going to define a constant, call it original posts, and set it to this.state.posts. Now, if this call to the server fails, we're going to call this.setState and pass our original posts. This will easily revert our UI back to the previous state. So, in order to detect errors, we need to wrap this call with a try-catch block. So, try, put this line here, and then catch. In catch, we get an exception or an error, and this is the moment when we display an error to the user and revert the screen. So we can display an alert like something failed while deleting a post. And then we call this.setState, set our posts to original posts. As simple as that. Now let's simulate an error. So right after the call to axios.delete, I'm going to throw an error. This is just a simulation because our fake backend JSON placeholder is always up and running. So it's hard to simulate a real error unless I disable my Wi-Fi so there is no internet connection. But I can do that for several reasons. So that's why I'm throwing an error. So let's test the application. Back in the browser. Note that when I click the delete button, this post will immediately disappear. And then after about a second, we're going to see an alert telling us that something failed. And then this post will come back to the table. Have a look. Delete, it's gone. We got the alert, something failed. Okay, and the post is back. So this is how you implement optimistic updates. First, you keep a reference to the original state. Then you update the UI before calling the server, and then wrap the call to the server in a try-catch block. In the catch block, you'll display an error and then update the state to the previous state. In the last lecture, you learned that in order to handle errors, we should wrap our code in a try-catch block. If an error occurs, we catch it here and then undo the changes. So far, so good. However, there is more to error handling than what you have seen so far. First, we need to differentiate between expected and unexpected errors. So, expected and unexpected. What do I mean by this? Expected errors are errors that our API endpoints predict and return. For example, here if we try to delete a post with an invalid ID, the server will return a response with the status code 404, which means not found. This is a standard HTTP error that you have probably seen before. As another example, we have the status code 400, which means bad request. And this happens when we try to submit a form with invalid data. So on the server, the validation fails and the server will respond with a 400 error. As you can see, all these errors are in the 400 range. In the HTTP protocol, we refer to these errors as client errors. So errors that happen because the client did something wrong. In this case, we should display a specific error message to the user. For example, in case of deleting a post, if the server returns a 404 error, we should tell the user, hey, this post is already deleted. Or maybe this post could not be found. So something specific. In case of a 400 error, we should tell the user what fields in the form were invalid. So these are examples of expected errors. Unexpected errors are errors that technically should not happen under normal circumstances. Here are some examples. If the network is down, we won't be able to call the server. So this is an unexpected error because the network should not be down. This is an exceptional situation. Another example, the network might be up, but maybe the server is down. Or perhaps the server is also up and running, but the database is down. Or maybe all these pieces are up and running, but we have a bug in our application code. So these are examples of unexpected errors that should not happen under normal circumstances. We need to handle these kind of errors differently. First, we need to log them. So in the future, we can look at our log and find the errors that shouldn't have happened. Also, we should display a generic and friendly error message to the user. For example, an unexpected error occurred. So now let's modify this code and handle these expected and unexpected errors accordingly. So how can we check if this exception we get here is an expected error? Well, this exception object has two properties, request and response. So request and response. This property is set if we successfully get a response from the server. If the network is down or the server crashes, we won't get a response, so this property will be null. The request property will be set if we can successfully submit a request to the server. Otherwise, it's going to be null. Now, in this case, we have one expected error, that is the error with the status code 404. So to check for this error, we need to write code like this. If exception.response is truthy and its status equals 404, that means we have an expected error. So we can display an error like this post has already been deleted. Now let me delete these two lines here. We don't need them. In this API endpoint, this is the only expected error that we have to deal with. Anything else should be treated as an unexpected error. So let me delete all these comments. We don't really need them. So else, first we need to log the error. For now, I'm just going to log it in the console. In the future, we'll come back and talk about logging in more detail. So logging the error, and here is the exception or the error object. And then we should have a generic error message. I'm going to move this alert right here and change the message to an unexpected error occurred. That's it. Now, either way, whether we have an expected or unexpected error, we should revert the UI to its previous state. Now let's test the application and simulate these two kinds of errors. So first, I want to simulate an expected error. Let's add an invalid post ID here. Let's say 999, and we're not going to send post.id. Back in the browser, I'm going to delete this post. We got this message, this post has already been deleted, beautiful. And in the console, we don't have a message about logging this error. This is not something that we should log because it is possible that the user has multiple tabs open. So on one tab, they delete a post, maybe on another tab, that post is still there. So when they delete this post, they get that error. That is not an indication of something being wrong in our application. So we don't need to log it. It's a client error. By the same token, if the user submits a form with invalid data, we don't want to log that error. It's just a client error, so the client should fix that error. Now let's simulate an unexpected error. So I'm going to put this post ID back. However, I'm going to change the URL to something invalid like this. So with this change, we're not going to get a response from the server because this is not a valid URL. Okay? Save the changes back in the browser. Delete. We got our generic error. An unexpected error occurred. And here on the console, we're logging this error. Beautiful. In the last lecture, you learned how to handle expected and unexpected errors. Now, currently, we have done this only in our handle delete method, but we need the same kind of error handling when creating a post, updating a post, and getting all the posts from the server. So if we have an unexpected error, we should log that error and display a generic friendly error message to the user. We don't want to repeat these two steps everywhere. There must be a better way. That's when we use an interceptor in Axios. So in Axios, we can intercept our requests and responses. And if we have a response with an unexpected error, we can handle that error in one place. So we can log that error and display a friendly generic error message to the user. Let me show you how. So on the top, after our import statements, we type Axios.interceptors. Look, we have two properties here. We can intercept all our requests before going out or intercept the responses we get. So now we want to intercept our responses. Here we have a use method. This method takes two parameters. Both these parameters are functions that will be called. The first function will be called if the response is successful, and the second function will be called if the response includes an error. Now, in this case, we don't want to intercept successful responses. Maybe in your application, whenever you get a successful response from the server, you want to log that somewhere for auditing. Who knows? In this case, we don't care about that. So I'm going to pass null here. And then here we should pass a function. So error goes to a code block. This function will be executed every time we have a response with an error. Let me show you. So I'm going to do a console.log interceptor called. Now to pass control to our catch block, we need to return a rejected promise. So return promise.reject. This will create a rejected promise. We simply include this error in our promise object. With this implementation, whenever we have a response with an error, this function will be called first, and then the control will pass to our catch block here. Let me show you. So here I'm going to do a console.log handle delete catch block. Save the changes. Now let's add an invalid post ID back in the browser. Let's delete this post. Okay, you can see our interceptor got called first, and then control was passed to our catch block. So we don't need this console.log anymore. Now we can move these two lines in our interceptor. So if you have a response with an unexpected error, we can log the error and display a friendly generic error message. So let's cut this code from here. Also, we don't need the else block. Now back on the top, I'm going to remove this console.log. Instead, we're going to log our error, display our error message, and then return a rejected promise. But we want to execute these two steps only if we have an unexpected error. So if we have an expected error, we can simply return a rejected promise. Okay? So let's modify this code like this. If error.response is truthy and error.response.status is greater than or equal to 400 and this status code is less than 500. So if it's in the 400 range, that means this is an expected error. We simply return a rejected promise. We don't log it. We don't display this generic error message. Okay. So we can extract this expression into a constant. Let me cut this from here. Define a constant, expected error. Then we can change this to, if we have an expected error, we'll return a rejected promise, otherwise blah, blah, blah. Or we can reverse this condition. So if we have an unexpected error, then we don't need this return. We will log the error and display our generic message. Either way, we will return a rejected promise. That is a better implementation. Save the changes. Now the code is reformatted. So let's go back to our delete method and make sure this refactoring is working. So let's go to handle delete. Here it is, beautiful. So note that we removed the handling of unexpected errors. So we don't have to repeat this everywhere. We have implemented it once in our interceptor. So here we have an invalid post ID. Let's make sure everything works. So back in the browser, oops, we have an error here. Line 12, X is not defined. So back on the top, this is the code that I copied from our delete method. Instead of X, we're dealing with error. Save the changes. Okay, good. Delete. In this case, because we're simulating an expected error, we get this message. This post has already been deleted. Okay, good. As you can see, the error is not logged. Now let's simulate an unexpected error. So back in our handle delete, let's pass a valid post ID, but change this URL to an invalid URL. Save the changes. Delete. Now we got a generic error message and the error is logged. So with this interceptor, we're handling unexpected errors globally. So we don't have to repeat this everywhere. And that means in our component did mount method, if we can't get the list of posts from the server, our interceptor should kick in, log the error, and display a generic error message. Let's simulate that. So I'm going to change this to an invalid URL, save the changes. Back here, you can see we got our generic error message and the error is logged on the console. Beautiful. So our interceptor did its job properly. Now, back to our component did mount method. You might be curious why I didn't add a try catch block here. Because in this case, we are not anticipating expected errors. So we don't need to catch the error. And also we don't need to revert the UI to its previous state. In our handle delete method, we had to add this try catch block here to check for a specific expected error and also to undo the changes we made to the UI. So to recap, you would need the try catch block only if you need to do something specific as a result of this failure. Otherwise, leave the handling of unexpected errors to the interceptor. So with this interceptor, we improved handling of unexpected errors. Perfect. But this implementation is not ideal. First of all, it has polluted our app module. So at the beginning of this module, we have all these details about intercepting errors, checking to see if the error is unexpected, logging it, blah, blah, blah. All these details have polluted our app module, which should be the root of our application. The other issue with this implementation is that tomorrow, when we build another React application, we have to come back and copy paste this snippet into our new application. This is not very portable. It would be nicer if we had a separate module like HTTP service module and all this code was in that module. Then our app module will not be polluted with all these details. And also we could simply copy that file, that HTTP module file, into a new project. That will be more portable. So in our project, let's add a new folder, services. Here we add a new file, http service.js. Now back to our app module. Let's cut all this code from here and move it into our HTTP service. On the top, we need to import Axios. So I'm going to grab that from our app module. Here it is, cut, and paste it here. Now at the end, I want to export a default object. This object should have 4 methods: get, post, put, and delete, just like the Axios object. So get, we set this to axios.get. Post, we set it to axios.post. Put, similarly, and finally delete, we set it to axios.delete. Now with this change, we can go to our app module. On the top, import HTTP or HTTP service, whatever you want to call it, from services/HTTP service module. And then anywhere we have a reference to Axios, we can simply rename that reference to HTTP. So I've selected this Axios. Let's find the other references. So we have 4 references. Let's rename all of them to HTTP. Now with this change, in this module, we no longer have a reference to Axios. We have hidden Axios behind our HTTP service module. So if in the future we decide to use a different library instead of Axios, there is only a single place we need to make that change. That is our HTTP service module. As long as this module exports an object with these methods, get, post, put, and delete, the rest of the application will not be affected. In our app module, we don't care what library we are using to send HTTP requests. So that's one of the benefits of introducing this HTTP service module. And also, for our next project, we can simply copy this entire file, this entire module into a new project. That is much easier than copying a snippet of code. And also in app module, we no longer have that ugly code for configuring an interceptor. The other thing we can improve here is taking this API endpoint constant out. Chances are we're going to use this URL in several places in our application. We don't want to hard code it on top of app module. That's just so ugly. So let's move this to a configuration file. Here in the project, in the source folder, let's add a new file. Call it config.json. Here we add a JSON object. Let's add a key called API endpoint and set it to this URL here. So let's cut this string and move it here. Good. Now here we could have several other configuration parameters. Currently, we only have our API endpoint. Now back to app.js, we can remove this ugly line from here. And on the top, import config from current folder config.json. Now, anywhere we have a reference to API endpoint, we can prefix all of them with config dot. So I've selected this API endpoint. Let's select the other references. Good. Let's change them to config.api endpoint. Like this. All right, now let me show you how to display a toasty like this. It's toasty here. That is much nicer than the native alert box in browsers. So in the terminal, let's install React-Toastify version 4.1. Beautiful. Now let's go to our app module. On the top, we need to import a component from this module, that is toast container. We import this from React-Toastify. We should also import its CSS library. So import react-toastify/dist/react-toastify.css. Now we need to add this component, toast container, to our app component. So let's go to the render method. Here we have a React fragment. Right after that, we can add our toast container. We're almost done. Now, finally, we need to go to our HTTP service. So here we're going to replace alert with a toast notification. So on the top, we need to import this toast object from React-Toasty, and then replace alert with toast.error. We have other helper methods here like toast.success, info, and so on. Now, to make sure that this works, let's go back to our app module. Here, in our handle delete method, let's produce an unexpected error. Now back in the browser, delete, and here's our toasty. Beautiful. One more thing before we finish this lecture. This toast that we import from this module is a function. And as you probably know, in JavaScript, functions are objects. So we can use this toast like an object like this, called the error method, or we can use it like a function. So we call toast, and now let's see the difference. Delete. Look at these colors. I think this is very beautiful. So if you want to display information messages to your users, you can simply call the toast function. Otherwise, you can use it as an object and call specific methods like error, info, and so on. So here in our HTTP service, if we have an unexpected error, currently we log it on the console. This is perfectly fine on a development machine, but when we deploy our application to a production environment, this is not going to be helpful. Because as you know, this console is part of the end user's browser. And as developers, we don't have access to that console. So we need to store this error. We need to log it somewhere that we can access. And that's when we use a logging as a service provider. There are several login as a service providers out there. My absolute favorite is Sentry.io. I've talked about this service in my other courses. It is my absolute favorite service. So let me give you a quick tour of how you can use Sentry. When you create an account and log in, you'll see a dashboard like this. Here we can create a new project. On the top, you can select the kind of your project, in this case, React. We give it a name, let's say React App. Create a project. Now, all we have to do is to install a script called Raven.js and then write a few lines of configuration in our index.js to initialize Raven. So back in VS Code, open up the terminal and install Raven-js version 3.26.4. Beautiful. Now, let's go to index.js. Here on the top, we import Raven from Raven.js. So Raven is an object. It has a bunch of methods. Now we go back to Sentry.io website. We're going to copy this configuration from here and paste it right here. Note that here we have two properties, release, which indicates the version of our application. So in your log, you can see what version this error is coming from. Let's set this to version 1. We also have the environment set to development-test. Potentially in the future, you can dynamically set this depending on the current environment. For now, let's not get hung up on these details. So we configure Raven and install it. Done. Finally, with this, we can go back to our HTTP service. And instead of logging this error on the console, we'll log it using Raven. So on the top, we import Raven from Raven-js and then replace this console.log with Raven.capture exception. We pass our error here. Done. That's all we had to do. Now let's test this. So I'm going to go back to our app.js and modify our handle delete method to create an unexpected error. So just like before, I'm going to change this URL to an invalid URL. Okay. Now back in the browser, let's delete a post. We got this error. Now back to our Sentry.io dashboard. Let's select our project here. On this page, we can see all the unresolved issues. So as you can see, just a few seconds ago, we had a network error. Let's take a look here. On this page, you can see all kinds of data about this error, where it happened and how it happened. So on the top, you can see all the information about the environment. So my browser, Chrome version 67, the environment was our development environment. We can see my operating system, my IP address, and so on. Below that, we have our stack trace. And after that, we have breadcrumbs. This is my absolute favorite feature of Sentry.io because this tells us a story about how this error happened. So initially, we had this XML HTTP request or an AJAX request to this endpoint. We got the list of posts. After that, we had another XML HTTP request to this endpoint. This is for hot module reloading that we have in our development environment. Then we had a UI click event. And this is because I clicked on the delete button. And here you can see where that delete button is located. So we have a table. Inside that table, we have a T body. Then we have a TR and so on. So I clicked this button. Then there was another XML HTTP request. So we sent a delete request to this endpoint. And as you can see, our URL is invalid because I put an S in front of HTTPS. And as a result of that, we got this exception, network error. Now let's go back to the list of issues. Here we have lots of other features for managing the issues. We can assign them to different developers in the team and then track if and when these issues are resolved. It's a very, very powerful tool. If you're interested to use Sentry.io, here's the pricing model for this service. If you're a hobbyist, you can use it for free. If you're a small team, you have to pay a monthly amount, and that amount goes up as the size of your application and the number of errors you want to track increases. But if you sign up via my website, you can get 2 months of their small plan for free. That is the value of $52. In case you're interested, you can find the link on my website at programwithmosh.com/tools. Let's quickly review the changes we made to add Raven to this application. On index.js, we added these few lines to configure and initialize Raven. And then in our HTTP service, we added this line to capture an exception and store it on Sentry.io. There are a couple of issues with this implementation. Let's go back to our index.js. The first issue is that we have polluted this module with the details about setting up our logging service. Index.js is a high-level module and is responsible for bootstrapping our application. It's like a manager, it's delegating tasks. The details of this task should not be here. So that is the first issue. We have polluted index.js with the details of our logging service. The second issue is that our current implementation makes it hard to replace Raven with another library in the future. Because if you want to replace Raven with another library, another implementation, we have to search in our project, and anywhere we have a reference to Raven, we need to modify that reference with something else. And chances are the other login library we use may not have a method called capture exception. It might have a different method, the parameters might be different. So we have to make several changes across different files to replace Raven with another library. To solve this issue, we need to extract all the logic for working with Raven and put it in a separate module. This way we will have a single place for working with Raven. And if we decide to replace Raven with another library with another login service, there is only a single place we need to modify. Let me show you. So once again, in our services folder, let's add a new file. We call it log service.js. In this file, we need to add two functions. One is init, and the other is log, which takes an error. Now we should get the implementation of these functions from our other modules. So back to index.js, let's grab these few lines, cut them, and put them in our init function. Obviously, we need to import Raven on the top. So let's grab the import statement from our index module and put it right here. Now we need to implement our log function. That's pretty easy. So back to our HTTP service, this is how we log using Raven. Let's cut this and put it right here. And finally, we need to export a default object with two methods, init and log. So this is the interface of our logging service. Our logging service has two methods, init and log. These are the methods that we're going to use in our application code. So back to index.js. On the top, we need to import our logging service from services/log service. We could also call this logger. That is a nicer, shorter name. Now here we call logger.init. See what happened here? Our index module is no longer polluted with the details of setting up our login service. The details are somewhere else inside of this method. That is better. Now back to our HTTP service module. On the top, we no longer need to import Raven. Let's import logger from log service. And then if we have an unexpected error, here we call logger.log and pass this error object. With this refactoring, we no longer have a reference to Raven in this module or index module. The only place we have referenced Raven is inside of our log service. If tomorrow we decide to replace Raven with another library, this is the only file, the only module that we need to modify. All right, back to our Vidly application. This application we have built so far doesn't have a backend. All our data is in the memory. If we make any changes and refresh the page, the changes are gone. So we want to add a backend to this application to persist the data permanently. And that's what we're going to do over the next few lectures. Now, as I told you at the beginning of the course, React is a front-end library. Our focus is purely on building the front end. Backend is an entirely different topic. It requires familiarity with different technologies, and I have a few comprehensive courses about building the backend. So in this section or in this course, we are not going to build the backend. Instead, we're going to use the backend that I have built in my Node course. So if you want to see how I have built this backend line by line, I highly encourage you to take my Node course. That's a very comprehensive course, about 14 or 15 hours long. I've covered everything from the basic to the advanced topics. This backend we're going to use is implemented with Node, Express, and MongoDB. Node is a runtime environment for executing JavaScript code outside of a browser. With Node, we can build web servers that respond to HTTP requests. Express is a framework for building RESTful APIs, and MongoDB is a database management system for storing our data. So, over the next 2 lectures, I'm going to show you how to install MongoDB on your machine. If you already have MongoDB, feel free to skip the next 2 lectures. First, we're going to look at installing MongoDB on Mac, and then we'll look at installing it on Windows. Once you have MongoDB, then I will walk you through adding the backend to this application. How to install MongoDB on a Mac machine. If you're a Windows user, you can skip this video and watch the next one. So first, I want you to head over to brew.sh. This is the website for Homebrew. Homebrew is a package manager for Mac OS, very similar to NPM. So if you haven't installed Homebrew before, simply copy this line here. It's very simple. Open up the terminal and then paste the command. Now here, press enter, type in your password. Now this is going to download some binaries and it's going to take a little while. All right, beautiful. Now we have Homebrew. So we can install MongoDB with one command. So brew install MongoDB, just like how we do npm install, let's say MongoDB. Now on this machine, I've already installed MongoDB. That's why we get this warning. On your machine, the installation is going to take a few seconds. Now, once you're done, you need to create a directory for MongoDB to store its data. So by default, MongoDB stores data in this directory, /data/db. So let's create this. mkdir -p/data/db. You can see here I got a permission denied error. So we need to run this command with higher privileges. So we need to put sudo on the front. Enter the password. Beautiful. Now you need to make sure that this data directory has the right permissions. So run this command. Sudo space chown space dash capital R space backtick ID space dash un backtick space /data/db. So look at this command. Now enter. So our data directory is ready. It's configured with the right permission. Now we need to run MongoDaemon. That's a service that runs in the background and listens for connections on a given port. So let's run MongoD. That is short for MongoDaemon. Okay, now you can see MongoDaemon is waiting for connections on port 27017. Now back in the browser, head over to mongodb.com. Here we're going to download a client to connect to MongoDB. So select this download button on the top. On this page, go to the Compass tab. This is MongoDB Compass, which is a client application to connect to a MongoDB server. We can look at our databases, we can work with our data. So here, make sure the platform is OS X. Download this. Now this is going to give you a DMG. So open that. And then drag and drop MongoDB Compass onto the applications folder. With this, we can run MongoDB Compass. So here's MongoDB Compass. On this page, connect to host. Leave the default values such as host name, which is set to localhost. And here's the port. the same port that our MongoDB server is listening to. Now let's connect to this host. Beautiful. We're successfully connected to our MongoDB server. By default, here we have two databases, admin and local. These are purely for MongoDB to do its job. We're not going to touch these databases. MongoDB on Windows. So open up your browser and head over to mongodb.com. On this page, on the top right, click this download button. And then here, select the Community Server tab. This is the MongoDB server that we run on our machine. Make sure Windows is selected. And then download this MSI. So let's save this. All right, and now let's run it. So this gives us a very simple installer. Let's go ahead, next, accept the license agreement, next, and do a complete installation. Now on this page, there is this checkbox here, install MongoDB Compass. This is the client application that we use to connect to our MongoDB server to look at our databases. Now, for some unknown reason, on this machine, I have had no success installing Compass as part of installing MongoDB server. So I'm going to uncheck this and then download Compass separately. Next, install. All right, MongoDB is installed. Beautiful. Finish. Now back on MongoDB website, let's go to the download page one more time. And this time select the Compass tab. And here, from the platforms, select Windows, and then download. Okay, now let's run it. All right, this is Compass. We're going to get back to this later. So now let's open up File Explorer and go to Program Files and then MongoDB. Next, Server. Now the version I'm running is 3.6. Chances are in the future when you're watching this, the version will be different. So select that folder and then bin. And finally, MongoD. That is MongoDaemon, which is a service that runs in the background, and that's basically our MongoDB server. Now, what I want you to do is select this path here. Now, in the search bar, search for Advanced System Settings. So here, View Advanced System Settings. On this page, we need to go to environment variables here. And then from this list of system variables, select path. Click edit and then new. And here we paste the path that we copied earlier. That is the path to the directory that contains our MongoDB server. Okay. Now, okay. On this page, also select OK. Done. Now, open up command prompt and run MongoD. If you don't see this output and get an error like MongoD is not recognized, you need to restart command prompt. So close all the command prompt windows that are currently open on your machine and then open it again. So when you run MongoD, you should see an output like this. By default, you're going to get an error. So here, look, we get this exception. Non-existent path, data directory c:\data\db not found. So by default, MongoDB stores your data in this folder. So let's create this folder. md c:\data\db. Okay, now let's run MongoD one more time. This time we don't get that exception, and the last message is waiting for connections on port 27 017. So this verifies that MongoDB server is running. Now we can go to MongoDB Compass. So here's the welcome screen. Let's just go next, 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 and get started. On this page that is connect to host, we need to specify the MongoDB server we want to connect to. So leave the default values as they are. So the host name is localhost and port is 27017. Now let's connect. Beautiful. We successfully connected to our MongoDB server. So here by default, we have two databases, admin and local. These are for MongoDB to do its job. We're not going to work with these databases. Now that you have set up MongoDB, let me show you how to add the Node backend to our Vidly application. Head over to github.com/mosh-hamadani/vidly-api-node. This repository contains the complete source code of this Node backend. And here you can see all the steps to set this up on your machine. It's pretty easy, and I'm going to show you that in a second. Now, if you're not familiar with Git or GitHub, you can find this project in the zip file that I have attached to the first lecture of this section. So here in the start folder, you should see vidly-api-node. So wherever you have the Vidly project, copy the API project right next to it. Now in this lecture, I'm not going to copy this. I'm going to show you how to get this project from GitHub. So back to GitHub. Here, let's grab the URL of this repository, copy. Now back in the terminal, currently I'm outside of our Vidly folder. So let's run git clone and then paste the URL of our Git repository. Okay, cloned. Now you can see we have Vidly API node right next to our Vidly project. So let's go to this folder, Vidly API node. Now we need to install the dependencies. So npm I. Okay, beautiful. Next, we need to seed our database with some sample data. So run node seed.js, done. Now, if you open up MongoDB Compass, you should see this Vidly database. Inside this database, we have three collections: genres, movies, and users. And as you can see, these first two collections are populated with some documents. So finally, let's go back to the terminal and start our web server, node index.js. You can see our web server is listening on port 3900. So open up your browser and head over to localhost port 3900/API/genres. You can see the list of genres returned from our MongoDB database. We also have another endpoint for our movies. This endpoint has full support for all the CRUD operations, so you can send HTTP requests to create, update, and delete movies as well. Before modifying our Vidly application to talk to this Node backend, let's quickly make sure that we can successfully create a movie by sending an HTTP request to the movies endpoint. To do this, I'm going to use a Chrome extension called Postman. If you don't have Postman, simply search for Postman Chrome. Here's the link. Add this to your Chrome, and then you'll be able to access it under Apps, Postman. Here in Postman, we can send various kinds of HTTP requests to any given endpoint. Here, open up a new tab and enter this URL, http localhost port 3900/API/movies. Note that the type of this request is GET, and we can change that here, as I will show you in a second. First, let's send a GET request to this endpoint. Send. So this is what we get in response. We get an array of movie objects. Each movie has these properties: underline ID, title, number in stock, daily rental rate, and genre, which is a complex object. So this is the same kind of movie object we have worked with in our Vidly application. Now let's see if we can create a new movie. So change the type of this request to post. Now in the body of this request, we need to add a movie object. So from this list, select raw and then change the type of the request to JSON, that is application/JSON. Here, let's add an object, set a few properties, title, a new movie. Make sure to put the keys in double quotes because that's the valid JSON format. In JSON, all keys should be in a string. We should also set number in stock. We set this to a number. Then let's set daily rental rate. We set this to another number. And finally, we should add genre ID. We need to set this to a valid genre ID in our database. So open up MongoDB Compass. Here in the list of genres, let's grab one of these genres. So simply copy this string. Now back in the Postman, let's pass that genre ID here. Click send. You should get an error, 401 unauthorized. It's telling us that access is denied, no token provided. We'll look at implementing authentication and authorization in the next section. So for now, to help you connect this Vidly application to its backend, I have added a configuration setting for enabling or disabling authentication. This is purely for this course, so you don't get hung up on the details of authentication. It's not something you should do in a production environment. So here in the terminal, stop the web server by pressing Ctrl and C. Now open this project in Visual Studio Code. Here in the config folder, look at default.json. You can see we have a key, requires auth, which is set to true by default. If you change this to false, you can modify the data without having to authenticate. So save the changes. Now, back in the terminal, run node index.js one more time. Okay, our web server is restarted. Now back in Postman, let's send this request one more time. This time we got a response with the status 200, which means okay. Here's our new movie. You can see it has a unique identifier. Beautiful. Next, we'll look at the exercises you should do for this section. Look at the list of movies. Currently, all our data is stored in the memory. I want you to make the necessary changes and populate this page, that is the list of genres and the list of movies, with the data we have in our MongoDB database. Now, before you get started, I want to give you a tip. Look at our movies module. Here we're importing the getGenres function from fake genre service. Now imagine we have another module called genre service. So let's change this to genre service. This genre service also happens to export a function called getGenres. So it has the same interface as the fake genre service, but instead of working with an array in memory, it uses our HTTP service to call our backend. So this is what I want you to do. Instead of making big changes to this file, do step-by-step refactoring. Create a new module called genre service. In that module, export this function getGenres and write the necessary code to get the list of genres from the backend. With this module in place, we don't have to make big changes in our movies component. The only change we have to make is adding async and await. Because these functions we have defined in our fake services, they don't return promises, they return arrays. So go ahead, replace fake genre service with a real genre service and make sure that this list, the list of genres, gets populated with the genres we have in our database. Once you get that working, then move on and replace fake movie service with a real movie service. So go ahead, spend about 15 minutes on this exercise. You will see my solution next. So here in the services folder, we have HTTP and log service. Let's take a look at the HTTP service. Here we have two external dependencies, Axios and React Toastify. So we need to install these libraries as well. Here in the terminal, let's install Axios version 0.18.0 and React-Toastify version 4.1.0. Okay, beautiful. Now, in order for Toastify to work, we need to add a toast container to our app component. So let's go to app.js. On the top, we need to import toast container from React Toastify. We should also import the CSS. So import react-toastify/dist/react-toastify.css. Okay, and finally here in our render method, just above the navbar, I'm going to add a toast container. Beautiful. So we brought all the dependencies of our HTTP service. Okay, now let's take a look at our log service. So before recording this video, I decided to comment out this code because I didn't want to use Raven in our Vidly application, because for using that, you will have to set up a Sentry account. And maybe you don't want to do that yet. So to keep things simple, here we just want to log the error on the console. So console.error, and we pass this error object. Let's delete this commented code. We're still going to keep the interface of this module exactly as is. Maybe in the future, we'll decide to replace this implementation and use Raven. For now, we don't care about it. Also on the top, let's delete this import statement. Good. So back in the browser, our application is still working. Let's take a look at the console. We don't have any errors. Good. So next, we want to replace the list of genres with the genres we have in our MongoDB database. Okay, now let's go to our movies component. As I told you before, we don't want to do a big bang change. We want to do step-by-step refactoring. So first, let's replace this fake genre service with a different service that talks to our backend. So in the services folder, let's add a new file. We call it genre service. This module should have the exact same interface as our fake genre service. Let's take a quick look at fake genre service. So here we're simply exporting a function called getGenres. So I'm going to copy this into our new module, but instead of returning something from this array, we're going to call the server. So on the top, first we need to import HTTP from our HTTP service. And here we simply call http.get, pass the URL, that is HTTP localhost port 3900/API/genres. And finally return the result. Now I know that we should not hard code this URL here. The right place to store this is in a config file. But as I told you earlier, we want to do step-by-step refactoring. So in this lecture, our focus is purely on the genre service. Save the changes. Now back to our movies module. Let's replace fake genre service with genre service. Now let's see where in this module we have used this function. So Command and F, get genres, we have used it in component did mount. Now this new function returns a promise, so we cannot spread it like this. Instead, we need to call it and then await it to get the actual result. So we get the result. Now here we need to get the data property, so we can use object destructuring to get the data, and then we'll pass the data here. Now because we have used await here, we should decorate this method with async. Save the changes. Now this list of genres is actually populated with the genres we get from the server. So did you see what I did? I created a new service with the exact same interface as fake genre service. We kept the interface the same, but changed the implementation. With this approach, the impact of changes is minimal. In this case, the only change we had to make was to apply this async and await here. Now imagine our fake genre service, instead of returning an array, what if it returned a promise that would resolve to an array? If that is how our fake genre service was implemented, then we wouldn't even have to make this change here. The only change we would have to make was replacing fake genre service with genre service. Next, I'm going to replace this fake movie service with a real movie service. In this lecture, we want to replace fake movie service with a real movie service. Now, our fake movie service has a few functions. In this module, in this component, we are using only 2 of these functions. So in this lecture, we want to focus only on these 2 functions, nothing more. So here in the services folder, let's add a new file, call it movieservice.js. Here we need to export 2 functions. One is get movies, and the other is delete movie, which takes a movie ID parameter. Now here we need to import our HTTP service from HTTP service module, and then call http.get. We need to pass the URL that is localhost port 3900/API/movies. And then we'll return the result. Similarly, for our movie ID, we need to call http.delete. Now, I don't want to repeat this address. So for now, let's just extract a constant, call it API endpoint, and set it to this string. Okay, and then we can use this in 2 places. That is better. Now, when deleting a movie, we should pass API endpoint and append the movie ID here. That's it. So let's go back to our movies component. We'll replace fake movie service with the real movie service. Now let's see where we have used these 2 functions so we can apply async and await. Let's search for get movies. Here's one instance in component did mount. So once again, we should call get movies, await the result, and get the data property, and then rename it to movies. With this, we can simplify this last line like this. We're done with this function. Now let's find delete movie. Okay, it's right here. So here we have implemented optimistic update. So we're assuming the call to the server is going to succeed. That's why we update the UI first. However, when working with a real backend, as you know, things may fail. So in those situations, we should undo the changes. Here I'm going to define a constant called original movies and set it to this.state.movies. And then we can simplify the second line. Instead of repeating this.state.movies, we can use original movies. So then we'll delete the movie. Here we should await this call and also apply async here. Now it is possible that this movie is deleted. So our API endpoint may return the 404 error. Let me quickly show you the implementation of this API endpoint. So here in Vidley API node project, under routes, let's take a look at movies.js. If you scroll down the bottom, here we have on line 66, router.delete. This is the ID parameter. So you can see if we don't have a movie with the given ID, we're going to return a 404 error. All right, so back to our movies component. We delete the movie. Here we need to wrap this in a try catch block like this. Try catch exception. So we check if exception has a response and response has the status code 404. We want to display a toast notification to the user. So on the top, we should import the toast function from React Toastify. Now let's go back to handle delete. Okay, here, if we have a 404 error, we're going to call toast.error. This movie has already been deleted. So this is the error that we expect to get from our API endpoint. If there is an unexpected error, our HTTP service will automatically log it and display a generic error message. Now, either way, we should undo the changes. So we will call this .set state, set movies to original movies. Save the changes. Now let's test the application. All right, our list of movies is now populated with what we have on the server. So let's open a new tab pointing to the same page. I'm going to delete this movie here, test movie, delete. Let's refresh the page. The movie is not there, so our delete function worked properly. Now let's go to the first tab. Test movie is still there because we don't have a real-time application. So the data does not get refreshed automatically. Now at this point, if I try to delete this movie, we should get a toast error. Let's have a look. Delete. And here's our toast error. Beautiful. Earlier when building this genre service, we talked about moving this somewhere central, so we don't have to repeat it everywhere. The right place to put this is in a config file. So here in the source folder, let's add a new file, config.json. In this file, we add an object with one key, API URL. And we set this to localhost port 3900/API. Now back to our genre service. We import config from /config.json and then modify this string and prefix it with config.api URL plus genres. So this is the base URL of our APIs. And then we have multiple endpoints, one endpoint for genres, another for movies, and so on. Also, we can simplify this code and use object destructuring. So instead of importing config and then typing config.api URL, we can destructure this and pick API URL and then use it here. That is better. We should make the same change in our movie service. So let's go to movie service. On the top, we import API URL from /config.json and then change our API endpoint. We prefix it with API URL and get rid of this ugliness. Save, done. So we're done with our movies page. However, when we try to edit a movie, we get redirected to the not found page. So our application is broken, and your job is to fix this as part of your next exercise. So I want you to focus on the movie form. Make the necessary changes to connect this form to the backend. So look at the movie form component. Here we're still using our fake services, so I want you to replace these one by one. And here's a hint before you get started. When saving a movie, you may get an error when calling the server, because the object that you put in the body of the request is not supposed to have an ID property. So make sure to delete that property before calling the server. So go ahead, spend about 15 minutes on this exercise. When you're done, come back and see my solution. So here in the movie form component, first I want to replace this fake genre service because this is already ready. So let's rename this to genre service. Now let's see where we have used this function, get genres. We have used it here in component did mount. So we need to await this call, get the data property and rename it to genres, and then apply async here. That's all we had to do. Save the changes. Let's create a new movie. Look at our genre drop-down list. All these items are coming from our backend. Beautiful. Now let's replace fake movie service with the real one. Here we're using two functions that currently don't exist in our movie service. So let's rename this to movie service and then add these two functions to our movie service. So here's our movie service. Let's duplicate this function and rename it to get movie that takes a movie ID. Here we need to append movie ID to API endpoint. Pretty straightforward. And then let's export another function called save movie that takes a movie object. For now, we don't care about the implementation. We'll come back to this later. First, let's make sure that we can populate the form with the right movie. So back to the movie form component. Let's see where we have used the get movie function. Get movie, it's here in component did mount. So once again, we need to await this, then get the data property and rename it to movie. Save the changes. Now back to the list of movies, let's edit one of these movies. The form is populated, beautiful. What if we pass an invalid movie ID here? We get this error in the console, the 404 error, but technically we should be redirected to the not found page. Back to our movie form component, in component did mount method, look at line 46. We call the get movie function. This returns a response object that has this data property. Previously, when we worked with our fake movie service, we assumed that if the movie does not exist, our get movie function would return null. That's why on line 47, we're checking to see if movie is falsy. But this code no longer works, so we need to wrap this in a try-catch block and check the status of the response. If it is 404, then we will redirect the user to the not found page. So let's add a try-catch block here. We move this line in the try block. So if we can successfully get the movie, then we should set the state like this. Otherwise, if we catch an exception, let's move this line here. We want to check to see if exception has a response and the status of this response is 404. If that is the case, we want to redirect the user to the not found page. Now here we're at the end of this method, so we don't even need this return keyword. Save the changes. That's it. Now let's test this implementation. You can see we are redirected to the not found page. Beautiful. Our application is working, but I'm not quite happy with this implementation. There is so much going on in this method. If another developer looks at this code, they can't tell quickly what is going on here. They have to read every line of this method. We want our code to be so clean and self-explanatory, like telling a story. So what are we trying to do in this method? Two things. One is populating the genres, and the other is populating the movie. And that is if we are editing a movie with a valid movie ID. So we want to break this method, component did mount, into two methods, populate genres and populate movie. Let me show you. So let's create a new method, populate genres. Here I'm gonna cut these first two lines and move them in our new method. Now, because we're using await here, we should apply async to this method and then call it this.populate genres and await it. Similarly, we're going to extract these few lines and put them in a new method like populate movie. Once again, because we're using await, we should make this method async. And finally, back to our component did mount. Here we call this.populate movie and await it. So now our code is telling you a story. When we look at component did mount, we know that there are two things that should happen. One is populating the genres, the other is populating the movie. The details of these operations are somewhere else. They're not polluting this method. So if there is something wrong with populating the movie form, we just go and look at this method. That is better. There is one more thing we can improve here. This try-catch block in the middle is kind of ugly. So it is better to move these two lines inside the try block like this and put the try keyword at the beginning of the method. All right, we're done with our refactoring. Next, we'll focus on saving the movie. All right, now we're going to focus on save movie function. In this function, we should either create a movie or update it. So we check if movie.id exists. We should update the movie. So we send an HTTP put request to API endpoint +/+ movie._id. So that is our URL. And then we need to pass this movie in the body of the URL. However, this movie has an ID property, and our RESTful API on the backend doesn't like the ID property to be in the body of the request, because that is confusing. If we have one ID in the URL and another ID in the body of the request, which one is correct? So we should remove the ID from this object, but we don't want to modify this object directly, because if you look at our movie form, this is where we have used the save movie function. The movie object we're passing is part of our state. We don't want to directly modify this. So back to our movie service. Here we can use the spread operator to clone this object. So body, we create a new object and spread the movie. Then we delete body.underline_ID and finally pass body here. So that is our update scenario. Otherwise, we're dealing with a new movie, so we should send an HTTP post request to the server. HTTP.post. We pass our API endpoint as well as our movie object. And also we should return the result to the caller. And one more time here. We're done. Now back to the movie form. This is where we're using this function. So we should await the result and mark this function as async. Save the changes. Back in the browser, let's update an existing movie. I'm going to change Hangover to Hangover Plus, change the genre to action, number in stock to 1, and rate to 3. Save the changes. You can see all the changes are reflected. Beautiful. Let's also create a new movie. Okay, here's our new movie. So here's our movie service. Do you see an issue in this implementation? Something repetitive. Do you see that? It's the calculation of this URL for a specific movie. All these concatenations, they just look so ugly. So it would be better if we extracted this logic into a separate function. So on the top, let's create a function, get movie URL. It takes a movie ID and returns API endpoint plus / ID. Or we can use template literals in ES6 and change this to something a little bit more elegant. So we use backtick, add a placeholder that is $ and curly braces. In this placeholder, we pass an argument. So API endpoint. So what we have here will be replaced dynamically at runtime. We want to have the API endpoint, then a / and then the ID. So we add another placeholder and pass this ID here. Now note that here I'm not exporting this function because this function is purely used in this module. It's part of the implementation detail of this module. We don't want other modules to see this implementation detail. So remove export. Now let's use this new function. So here on line 15, let's replace this ugly expression with get movie URL and we pass the movie ID here. But there is a tiny issue with our naming. Look, HTTP get, then get movie URL. It's kind of repetitive. We can rename this function using F2 to movie URL. That is better. Now one more time. In our save function, when sending the HTTP put request, let's replace this with movie URL. And here we pass movie._ID. And finally, when deleting a movie, let's replace this with movie URL and we pass movie ID. That is better. So we're done with this service. Now, nowhere else in our application we're using these fake services, so it's time to delete them and clean up our code. Beautiful.